Maltratei, sim, maltratei demais. E machuquei, meu coração que bate calado, 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 que bate, bate. Oi, 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 oi. Maltratei, sim, maltratei demais. E machuquei, meu coração que bate calado, 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 que bate, bate.
Officier à dessus. Algo que yo olvidé. algo que yo olvidé. Algo que yo olvidé. Quisiera decir algo que yo olvidé.
Hey, hey, hey! That is Daniel. Thank you, Daniel.
Thank you,
Awesome.
Daniel.
Hey, Vanessa, how's it going?
Hey, I'm good. How are you
Yes,
doing today?
yes, day two across ponds in every direction.
Many directions. I
Yes,
love it. We had
we
a
were
great time yesterday, right?
absolutely, and similar to yesterday, right now, we were literally in Slack going, I don't want to interrupt this music. This is very hard. Can we just have this be a party? Which is my fantasy. We will have at some point an in-person DJ desired state evening party. That's our plan, right? We hope that
Yeah,
it will happen soon and safely and yeah, and outdoors.
yeah.
So yes, you are Vanessa Abankwah. I am Tamao Nakahara. Thank you everybody for joining us for GitOps Days Day 2 of our 2-day event. It was so exciting to see everybody joining us online. And coming up next, I know, Vanessa, you are excited because one of our speakers is Philip Laine, a Flux maintainer that you got to spend
Yep.
time with at the Flux booth at KubeCon EU.
Great. It was great having his knowledge. It's sometimes easier to have because obviously we work with Stefan. Stefan will be joining us next also. But it's great to hear from Stefan and see them interact together and just share their knowledge. I didn't know there was so much stuff you could learn about Flux and Flagger.
Yes. And I think it's I don't want to say it's an uphill battle, but there's so much development going on. You know, it's just and from contributors in the community, from the engineers who work on Flux and Flagger. So, in fact, you are wearing the Flex Your Flux
I am.
T-shirt because
I am.
you kicked off this campaign because we said even people who have been using Flux and know so much about it, yeah, they there's a lot to be reminded of and updated on. And so, you know, hopefully give us feedback. We're just trying to make it as easy as possible for people to keep up. And in fact, Daniel Holbach, who is our DJ Desired State, every month has a fantastic newsletter on all these updates of what's going on. So yes, if you have not joined the Flux mailing list, then you'll be alerted of the new blog posts that Daniel works very hard to put up. And I've definitely gotten feedback from people about how helpful they are. All right, so on that note, let me give a quick overview of this event. If this is the first time that you've ever come to a GitOps Days event, well, welcome, and we are so glad that you are here. Make sure that you are in the Slack channel. It's been really great to see everybody asking questions there, as well as we do keep the YouTube comments open in case you're saying like, hey, I can't hear you. But please, yeah, send your questions to Slack because when the speakers come and go, they will still monitor. Like if they have to leave right after their talk, they'll still come and answer your questions even days later. So you will not be, your questions will not go in silence. And we are really excited by all the discussion that we saw yesterday. So GitOps Days is a 2-day event in which, hopefully you've been able to see what is GitOps. If you register, you'll still be able to see yesterday's stream where lots of people define that and help give an intro for that. And we've been featuring so many users of GitOps, in this case, using the Flux project. GitOps Days in the past, we've had mixed technologies. For this event this time, there was so much Flux stuff that we are focused on Flux, but definitely will have a mixture in the future. But for yesterday and today, we just had so many people from State Farm, Safaricom, OSO.sh, Anova, Ring Central, Zscaler, Orange, and many more. You will be able to see them from yesterday. And then today, many of those people I just mentioned will be here to talk about their use cases, what's gotten them to GitOps, what's helping them, the business value, the technical value, and you can ask them all the questions that you want. So if you wanted to meet other Flux users and to ask them questions, beginner to advanced, everybody's on different parts of their journey and they'll be sharing their experiences. Yesterday, we also had a series of platform people who talked about how they use Flux to deliver GitOps to their customers. So Microsoft, Amazon, D2IQ, VMware, Red Hat. If you are already using, oh, and Weaveworks, of course, I have to mention, that's our company. We have all these offerings. If you're like, oh yeah, I want GitOps, but I don't know, how I want to get started. If you're already on Azure or if you're already on AWS, well, they're already providing those offerings to you. So check those out. And finally, we have so many great speakers today and yesterday talking about Flux working with different technologies like Terraform and HashiCorp Vault. And today you're hearing about control plane and others. So there's many, many ways in which both the community and the maintainers have been dedicated to how Flux works with other technologies. So we have a jam-packed day today with that. So Vanessa, are you excited from the
I
London
am,
side?
yes, it's like 3 o'clock in the afternoon here, but I am so pumped for day two. I don't want it to end. I wish it was a week, but let's get into it. I'm really interested in to learn more. We have some key learnings about Flux 1 and Flux 2 later. I'm really interested in about 2.
Yes, and who knows, maybe that'll happen in the future. So right now we have a jam-packed 90 minutes with Stefan and Philip. We're waiting to see Philip join, who will be, there you are, hello. We have several maintainers of the Flux and Flagger projects that are in the CNCF. So please, we'll have 90 minutes with Philip and Stefan and ask every question you've ever wanted to ask. So take it away.
Okay, hello everyone. I'm Stefan, and I'm here with Philip. We are two of the Flux maintainers group, and today we are going to give you a deep dive into various Flux features. Not all of them, because it's impossible to do it in 2 hours, but some of them. For those of you who are new to Flux, let me give you a short overview of the Flux project. So Flux started around 6 years ago in Weaveworks as a way to simplify our continuous delivery on Kubernetes. Kubernetes was very young back then. There were no custom resource definitions, no operators, and stuff like that. So Flux version 1, which was developed and still maintained, was a simple tool that will synchronize your cluster state with a single Git repository. So you put all your definitions in there, and once you set up Flux on the cluster, Flux will try to get the cluster state in the same definition as the Git repo. That's the whole idea behind GitOps. And what that brings you is that you don't have to connect to the cluster when you want to do an app deployment. You can just push some modifications to Git, and Flux running on the cluster will pull those from the Git repo. This means you don't have to expose your cluster API to the outside world. You don't have to place kubeconfig secrets in your CI system and so on. Roughly 2 years ago, we started working on Flux version 2, which is a composition of Kubernetes API extensions called custom resource definitions. And we have, I think, around 12 of those. And we also have created dedicated controllers for things like pulling manifests from Git, reconciling Helm releases if you use Helm, reconciling customized overlays on your cluster. Another thing that we have now built into Flux are notifications. So we can issue events to Slack or Discord or whatever when something happens on the cluster. And we also have a way to automate new versions of app releases into clusters. So that's the Flux project. I put here the link of the main repository is fluxcd flux2. So please open your browser now and click, start. A second project that we maintain inside the Flux organization is Flagger. Flagger what it does, it decouples the deployment of an application from the release process. So if Flux does the deployment, Flagger does the release, and how it does it is by looking at metrics, routing traffic from one version to another, and determine if the new version behaves okay under your service level objectives. I have some diagrams here. So Flux in its new version can span across multiple clusters. You can run it on a management cluster, or you can run a Flux instance per cluster. And these Flux instances can synchronize your cluster state, your fleet state, if you want, with various sources. So Flux is moving beyond Git and GitOps. Flux can now synchronize the desired state from an S3 bucket, from a Minio cluster, soon from OCI repositories, of course, Helm repositories, and Git itself. And it kind of is a reactive system. You can, it issues events for everything it does, and it can also receive events from outside, from CI or from a container registry or from a Git provider in order to do its job faster. Okay, Flagger, as I said, it works with various service meshes and gateway providers. The idea of Flagger is that when you have an ingress controller or a service mesh, Flagger can take advantage of those and route traffic between app versions. So basically, Flux will detect, oh, there is a new version to deploy. It will apply that new version inside your cluster. Let's say you change on the container image tag of an application. Then Flagger sees that change, and instead of letting Kubernetes roll out the deployment to all your users, it does a gradual rollout based on traffic. So it moves 1% of your traffic, then it looks at Prometheus and other monitoring systems, checks if the new version behaves okay. And if it doesn't automatically roll back and allows you to fix it and, keep deploying without fear. So, you can also deploy on Fridays. Okay, that was the overview. It's the agenda for today. I'll be giving you a status update on Flux. What are the latest and greatest features that we released last week? Philip will talk about managing Kubernetes jobs with Flux, running database migrations and stuff like that. And then finally, I will do a demo of observability for GitOps pipelines, where I'm going to show you how I'm structuring my repo, how I'm installing Prometheus, Loki, Grafana, how I can look at metrics and see what's happening inside my cluster, and also with Flux. And finally, I'll give you a demo with GitOps Core, which is an open source offering for Flux Web UI. Okay, so we have released Flux 0.31, which comes with, let's say, one of the features that was most requested in the last year, getting Helm OCI support into Flux. What we currently offer right now, if you install the latest version, is you can use Flux to pull charts from OCI compatible container registries. So I don't think Docker Hub works for this right now, but many other registries already have this support for OCI types. So Helm uses a specialized OCI artifact type that not all container registries understand. So Flux is able to, connect to these container registries, find your Helm charts there, and how we have shipped authentication right now is through either Kubernetes Docker secrets or basic authentication with username and password, and of course tokens for GitHub and other GitHub container registries and other registries that support tokens. What we want to do in the future, we want to support OEDC authentication. So for example, you can use an IAM role binding for ECR, give the Flux source controller service account access to your ECR repos, and Flux will automatically connect to it without having to set a static authentication through Kubernetes secrets. And we want to do this across the board for AKS, GCP, EKS, and so on. We already have implemented all of this into image automation controller and image reflector controller, and we have to refactor a little bit our code and get that into source controller for Helm as well. Other to-dos here are, we currently don't support self-signed certificates. So when you host your own container registry, let's say with the Docker distribution, you can generate a self-signed cert, but currently Flux will not be able to connect to that container registry. We have opened a pull request on the ORAS project, which is it's a project in CNCF, which abstracts away. It's a library for working with OCI artifacts. And Sule, a member of our team, one of the Flux maintainers, had opened a pull request there to add support for passing custom TLS certificates to the client, so we can get this in. And lastly, we want to support dependencies inside charts. So when you build these umbrella charts, you can host an umbrella chart in your Git repo, right? So currently what Flux does when it detects an umbrella chart in your Git repo, looks at its dependencies and goes to those Helm repositories to fetch the dependencies. Now, you can add dependencies to other Helm charts which are hosted in OCI. So we need to figure out how to extend the dependency resolver to OCI as well. And this is in the works. There is a draft pull request for this task already. So I would say soon, in the next month, we'll solve all these issues and we'll fully ship Helm OCI support in Flux. How does this look? I have here two Helm repository definitions. The first one is how you used to use Flux with HTTPS repos. So you give it the URL of your HTTPS Helm repository. Then you give Flux a reference to a Kubernetes secrets, which contains the basic authentication for it. And if you want to migrate from HTTPS Helm repositories to container registries, the changes to your Flux definitions are minimal. What you have to do is specify a different type, OCI. You have to give it a different secret. The secret has to be image pool secret this time that contains the Docker authentication that can be generated with kubectl very easily. And of course, you give it the URL to your container registry. On the Helm release side, how you define Helm releases from charts and so on, nothing changes. Everything that used to work until now for HTTPS Helm repos also works for container registries. So for example, if you want to automatically upgrade a Helm release to the latest patch version, let's say in production, you want to fully automate this and you want to say every time there is a patch version for a particular chart, I want Flux to upgrade that Helm release. This works fine with OCI. What we do, we depending on the interval that you set. We talk to the OCI, the container registry API. We list all the tags, and then we do a semver filtering on those tags, ordering, and that's how we decide which is the latest stable version to be deployed on a particular cluster. So why would you switch from HTTPS Helm repositories to OCI Helm repositories? Well, there are a couple of bottlenecks in the HTTPS Helm repository implementation. The major one is the fact that, okay, you have to maintain your own HTTP server, you have to store all the charts in there, but you have to maintain this index file, which is a YAML file with all the chart versions ever pushed to the repository. And this doesn't quite scale. If you look at what the Bitnami team did recently, so Bitnami maintains this, I think it's one of the most popular Helm repositories out there. It's free. A couple of days ago, they said, we have terabytes of transfer just for our index YAML because it's huge. We have thousands and thousands of versions in there. So in order for them to reduce the traffic, they've deleted, I don't know, 1/3 of the index file. So for example, if you were using a Redis chart from Bitnami, which is 2 months old or 3 months old, that chart is no longer available in the index. So yeah, that's quite an issue. Also from a Flux perspective, the more this index file grows, we have to download it every time to see if there is a new chart version. So if your Helm repository has hundreds of applications with thousands of versions for each app, for each chart, we have to download all these huge files every time. We have to parse it, load it into memory, and so on, just to detect if there is a new version for a single application, right? So people see Flux source controller using, I don't know, 1 GB of memory while they have a single chart deployed. Well, if your index file is hundreds of megabytes, we have to parse that, load it into memory, and so on, right? So the fact that everything has to be stored in its index file is a huge bottleneck at scale. Switching to a container registry and using that as your Helm repository eliminates completely the index YAML problem. There is no more index YAML. We just fetch the tags, as I said, for a particular chart. So we don't query all the charts everywhere, only the one that you want to update. And we don't have to store that file. We don't have to do anything about it, right? It's just an API call to the container registry. We find the latest version that you want to deploy, and then we download that particular chart. So if you are a Helm user and your organization deploys hundreds of Helm releases and so on, I highly recommend you to look into OCI and try to migrate from HTTPS repositories to container registries. That's my current recommendation. Okay, next. So we have adopted OCI for Helm, but what about all the other things like plain manifests, customized overlays, I don't know, Terraform configuration, and so on? We want to make Flux work with OCI as the source of truth for everything inside your cluster. So there is a RFC opened, a proposal on how we want to expand OCI support for everything that Flux does. And I've put the link here to the pull request. Please go there, add your input, vote, thumbs up if you think this proposal will help you. The idea behind it is that we want to introduce a new API type called OCI repository that looks like a Git repository with small modifications. instead of doing the verification with OpenPGP, like we do it for Git commits, for OCI artifacts, we want to do the verification with cosign, and all the things should work the same. Like you can use Semver filtering, you can follow a mutable tag. Like right now with Git, you follow a particular branch. When you use OCI, you can have for each branch in your repo an OCI tag, and you move that tag to different versions and so on. So that's the current proposal. What will change on the Flux customized control and Helm control side? On the source ref, instead of having a Git repository, you'll be able to reference an OCI repository. But everything will work the same, it's just a different source. We also want to make easy for users to push OCI artifacts from plain manifest to container registries. So Flux, the CLI, will offer two new commands. One is Flux push for a particular, you push a particular repository content or a particular directory to the container registry, and Flux will do the bundling of the OCI artifact, the authentication, and the actual push. And another command will be Flux tag. So you can say tag v100 as latest, right? If you want to follow a particular immutable tag. Okay, that was it around what we envision for Flux and OCI. And the last thing I want to talk to you about what's new in the latest Flux release. Someone contributed, an external contributor, integrated Flux with GitHub repository dispatch API. What this means is that you can build promotion pipelines, and you can, for example, set Flux on the staging cluster to always install the latest available Helm chart. You can configure Flux on staging to run Helm tests and so on. When Flux determines that, okay, this new chart version is fine, the tests are running, the application is running on the staging cluster, it can send an event to GitHub. And inside GitHub, you can have a GitHub action which promotes that chart version from staging to production by doing a Git commit. And I'm going to show you later on how that looks like. We have created a documentation page, especially for this. The link is here. It's on the Flux CDIO website. Okay, so those were the Flux updates. Now I'm going to leave Philip explain how Kubernetes jobs can be managed with Flux. And I want to give a heads up of what Philip did in the Flux project and what he's currently involved to. If you are, for example, using Terraform to install Flux after you bootstrap your clusters with Terraform, well, Philip created that Flux Terraform provider. If you use Flux with Azure DevOps, well, Philip made that possible at the beginning for Flux version 2 to connect to Azure DevOps repos. He helped a lot with, he came out with the idea of doing status commits. So Flux can write back to GitHub, GitLab, Azure DevOps, and so on. And for a particular commit, it can mark that commit if it was successfully reconciled or it failed on the cluster. So it adds observability to your repository. You don't have to look at dashboards or anything. Philip created that first in Flux. So thank you very much, Philip, for everything you did and what you are currently doing.
And I will probably make you even more sad with the things that I'm going to show you in this presentation. I tend to always come up with interesting ideas, I guess, that not everybody agrees with, and then eventually when you put it out there, you can't really like take it back. So I haven't really. I'll show you a bit in the end. So I'm just going to talk about managing Kubernetes jobs with Flux and the challenges and different solutions that you can come up with. So historically, Flux and job triggering has been a challenge with literally every GitOps tool. So within Kubernetes, a job resource represents a pod that is supposed to run to completion once. When you create a new job in a Kubernetes cluster, it will spawn the new pod, but then it's done. To trigger the job again, you have to create a new job resource or delete the job and create it again, basically. This obviously doesn't really work too well with the way that Flux is set up, where it will try to reconcile the resource, and then, for example, if you commit a job today into a repository that is reconciled to a cluster, it will create the job will run, and then Flux will go, great, I'm done. So there isn't really, at least initially, there hasn't been that great of a support for running jobs intermittently or for different types of events. Why this is interesting? Well, my background is really, I work with a lot of developers who are Flux end users. And traditionally or historically, most of these developers have been .NET developers. So they've come from the C# world with some sort of traditional continuous delivery pipeline, and I'm moving them over to, or trying to get them to accept and to move over to using Flux instead of their traditional Azure DevOps, GitHub Actions, Spinnaker solution, Jenkins, whatever it can be. The first question, or a very common question that I get when you introduce them to Flux is, well, where is my deploy hook? It is a big challenge because a lot of development teams might have built very complex solutions around like post-deploy jobs or pre-deploy jobs, and the continuous delivery pipeline is so much more than just kubectl apply or some sort of roll-up mechanism. So when you're working with these types of developers or introducing new people to Flux, you can't really argue by saying, I'm taking away features that you have today. So you can't, it's very difficult to argue for Flux to say, Flux is great, it's a lot better than whatever you're doing today, but you can't do this. So that's been one of those challenges for me throughout maybe the last or the last year at least. Yeah. So the types of jobs or workloads that works today or has worked since forever really, within Flux has been cron jobs. So cron jobs as like basically defines a cron tab or a schedule to run on. So that resource, when you apply it to Kubernetes, it will the cron job controller, when it sees that it matches the schedule, it will create a job which creates a pod. So that works totally fine. Another thing that works with the Helm controller is Helm hooks, which seems to be the go-to solution for developers who want pre-deploy or post-deploy hooks within while using Flux. So the Helm controller fully supports that. So it allows you to, for example, define resources like a job or a pod that is created at different stages throughout the life cycle or the deployment life cycle of a Helm chart. So these types of use cases already work today. The issue with Helm hooks really is that you have to be a Helm user. So there isn't really an option there out there for you if you're not using Helm. So what types of potential use cases are there really out there for these types of tasks or pipelines or whatever you want to call them? The typical things that I tend to hear is questions around database migrations. So you might have your schema defined as code together with your application, but you have to have some sort of consensus if you're running multiple replicas, where one of the applications is supposed to do the actual schema migration, or you want to do the schema migration before your applications start running and receiving traffic. There are different types of use cases around post and pre-deploy jobs. So running something that makes a web request somewhere, or there might be some organization rule around doing certain things beforehand, or you want to run like complex end-to-end testing solutions like Selenium or other types of tools that Bash commands kind of don't really fit into there. So there are like legitimate use cases where people really want to have this type of feature. So in the context of database migrations, generally what I see, or what most people do, is that they have a single image with an application or the application logic and the schema migration tool or code or library or whatever they're using in the same image. A release might update 2 image tags. We'll get into that a bit later. And what I've seen before is that most people, and I think even the official Kubernetes documentation talks about using init containers to do this type of thing. So the idea is that you have a deployment with an init container. It creates multiple replicas, and then the init container will run, do the actual database migration, and then the application will start after that. This has a couple of downsides. One of them is that you're actually forced to create the new replica set before you know that your schema migration has actually passed. So that's one of those challenges. The other one is that there are a lot of schema management tools. For example, Entity Framework, which is a .NET tool that doesn't have built-in database locking support. So you actually have to manage to make sure that you're only running the migration workload once. And in the case of init containers, you have 3 replicas in an application, that you're going to start 3 init containers. And you have to then implement some other kind of consensus or database locking mechanism to make this type of thing work. And what I'm going to talk about now is the other option, which is to use 2 separate customizations. So the idea behind this is that you have 2 customization or Flux customization resources. One of these customization resources has the force flag set to true and waits for all resources to complete. And the only thing that it does is it deploys a job. That job will run some sort of migration, connect to the database, do the schema migration, all great. And the second customization is the one that's actually deploying your application. It's depending on the first customization, and it will block until the first customization is completed. The reason this works is because the customization is going to wait for the job to complete, and the customization is not going to be marked as ready until the job is complete, which blocks the first customization to actually deploy. This is how it looks in manifest form. So you have your database migration resource. It sets wait to true, force, and it defines your database migration job. And then you have your second customization that depends on this, basically. We can show a quick demo of how this would work. So let's do like this. So here we have a couple of already run jobs, and we have our deployment. So we have our deployment here, and we have a job here. So in this kind of type of scenario, we have already run our job. So the job is run to completion, and the pod is completed. If you were to deploy the application with the job at the same time, you couldn't really update the job. So, but if we look at our database, we see that, yeah, it's a simple job. It runs an Alpine image, just simulating something. So a job within Kubernetes, the parameters within the container are not mutable. So if you try to change it afterwards, the Kubernetes API is going to say that you can't really do that. So this is why we've set the force flag to true. So let's simulate some sort of schema change. So in a proper scenario, you would probably update your image tag in your migration job and inside of your deployment. So in this case, we're deploying Nginx just to have an example, but in a real world scenario, you'd have the same image in both the job and the deployment. You'd update the same image tag, but let's see what happens when we just change the sleep time in the job. So just gonna make a commit of this change. Gonna push the changes, just gonna force a reconcile to get this done quicker. We can see that hopefully we have our customization. So the application is going to say dependency pre-job migration is not updated yet. What we're going to see hopefully soon. Oh, so what's happened here then is that because this customization is set to force, so it ran a lot quicker than I expected. What it's done is it's deleted the job and it's recreated again. So that's why we're seeing a new trigger of this database migration. You probably don't want to do this with your application customization, because that would mean that it would actually delete the whole deployment if you'd make a change where Kubernetes wouldn't allow you to make that type of mutating change after creation. And if we check our customization, we see that, yeah, now it's applied. We could also do like this and say, for example, we exit with 1, so the job is going to fail. And we do the same thing. Same great commit message. Reconcile our source Git. We see that we've started our database migration here. It's gonna, in a couple of seconds, fail. And we can now see that any changes to our application is not going to pass until this job fails. So this kind of simulates a scenario where you have a database migration or some other kind of pre-deployment job that fails. So this job is just going to block any kind of progress for changes in this application. So that kind of gives you the type of use case where we're using jobs in this sense, and it kind of solves at least the most basic use cases of, I want to run something or this even works as a post step. So you could flip this around, have the application deploy, have a separate customization that depends on the application with a single job and force set to true. And you could run this after a application is considered fully ready with health checks and everything. So this type of thing works both ways, basically. And I think this solves the majority of complaints that you hear today around job triggering and Flux, really. So Kubernetes jobs are slightly limited in the types of use cases that you can have. For one, it is individual jobs with containers that run. There's no ordering of the types of steps that you want to do, so you're stuck with a single image or building some sort of custom solution around this. And this is kind of where Tekton comes in. Tekton is another, I think it's a CNCF project, don't quote me on that. I hope it's great that this is recorded, so if I'm wrong.
TDF.
It's, yeah, okay, it's not. I think I remember that it wasn't. But what it is, it's a Kubernetes native CI/CD framework. It allows you to define more complex types of resources as within the KRM solution or resource model with tasks and pipelines, and you can have pipelines that reference multiple tasks and have them in specific orders and specific failure conditions. There are a bunch of different, very, very complicated things you can do with Tekton. So it can be as complex or as simple as you want to. But it really solves this types of use cases where people want to do, well, more types of traditional continuous delivery solutions or systems within Kubernetes, really. another thing that it can do is it can be triggered with webhooks from event listeners. One issue with Tekton in its current state is that the way that we're doing, the way that we're health checking the job is that Flux has to be aware of the job that is created. The difficulties around running Tekton today is that you have a task and a task run resource. So the task run resource is what's created once each task is supposed to run. And Flux, having Flux detect specific tasks runs and understanding that the task run is supposed to complete is very or slightly difficult today. And there are different types of solutions around this. So there is it's a pretty old post now, 2 years ago, or yeah, something like that, by Kevin McDermott. I think he works at Weaveworks now. At the time, he did not. He posted early on a example where you could integrate a notification controller together with Tekton's event listener. So the solution that he came up with, or that you can come up with, is that you have a alert that looks at, for example, in this case, a Git repository and a provider that is, I think it's called generic Git provider. And the generic Git provider, what it does is it just posts a webhook with the event source, in this case, the Git repository. The event listener is then configured with a trigger binding and a trigger template. What these types of things do is that they define, the trigger binding converts the input data to specific data that you then can pass into the pipeline. So you can pass in, dynamic data into your pipeline configuration. And after this webhook is called, it spawns a pipeline run. Very simple, or maybe not. This works today, and I think that there are specific use cases where you actually want to do these types of things. The biggest issues around building these types of things is that it's difficult to get health checking working, where what you're interested in is, for example, the pipeline run completion. But the pipeline run in itself is going to be a resource with a dynamic name. So it's difficult getting, because Flux, the way Flux does health checking is very specific. It becomes very difficult to get it to dynamically point to the specific pipeline run and telling it that this has to complete. But this is another option if you're looking into like doing event-based things where it's more of fire and forget. I highly recommend looking at his blog post. It goes through most of these, or explains how you implement such a triggering system. So we haven't really talked about Flagger that much, but Flagger has or within the Canary resource in Flagger, there is a concept called webhooks. Webhooks in Flagger can be used to extend, for example, running Helm tests or starting load tests. It's, for the most part, originally meant to generate, or Stefan can probably correct me on this, but meant to generate load for applications that kind of don't have the amount of traffic into the application to determine if a new rollout of the application is successful or not. So that's kind of the initial idea of these sorts of things. But what webhooks allow you to do is that there are different types of webhooks that are called on at different stages during a Canary progression, where you could, for example, in one case, the start gate, you would this would be called before any work is done, and the HTTP request has to return a 200. If it's not returning a 200, what ends up happening is that the Canary deployment is not even started. So there are different types of scenarios where you want to use these types of things. Most people use, I guess, use them for generating load, really, or load testing applications. And this is the presentation that I'm calling, or the part of the presentation I'm calling, I am sorry, Stefan. I just want to preempt this with nothing that I'm going to show is open source yet. It's more of things that I've been working on with a customer that I think is interesting, but I know and I'm aware that it misuses some Flagger functionality, or it doesn't. We'll have to see. A lot of things I do tends to either or bite us in the ass in the end, and I tend to build things for people comment that was never meant to work in the first place. So I have a tendency of doing this. So just want to say I'm sorry. You tend to build good things, and then I come with very interesting use cases. The developers made me do it. That's what I'm saying. So one thing I missed there was that Flagger has a load tester. So as a part of enabling the type of workloads or the type of webhooks here is that you're supposed to deploy your own load tester together with Flagger. Flagger then makes a webhook call, and the load tester has more functionality than just responding to 100, where you can start Helm tests, or you can run. I think there are a couple of different tools that you can run basically as part of the webhooks, where it will start running functions, and you can push in metadata. But what I haven't seen today, and that's kind of interesting, is that people not building their own load testers. So because of the webhooks are very standardized in the type of data that you actually get from Flagger, there's nothing really stopping you from, well, building your own and implementing more features in this. And I see this as a solution towards people working with, for example, wanting to extend the load tester and add more functionality and come up with new ideas. So what you can do is you can build a load tester or a webhook that triggers Tecton. So this enables you to build very complex Tecton pipelines as a part of a pre-rollout. So instead of depending on like Helm tests, for example, you could build and this part that spawns the task is not open source yet. We might discuss if it should be, but as a pre-rollout stage, so in a pre-rollout, what happens is that the application or the new replicate deployment is created and it's deployed. The pre-rollout webhook is called, and you want to do something. You might want to start verifying or start running some sort of test before you actually start shifting traffic over. So what happens here is that we have our URL. This is just the service name of a separate application, and you're passing in some metadata, in this case, the task ref. And you have a task deployed. So this task is not going to run because it needs a task run resource to trigger the actual task. But what we're doing here is that we're saying the canary, we're referencing the name of this task. And what we don't want to do, and this is obviously the most simple use case, but what we can do then is that we can get a nice solution where we trigger task runs. So if we look, for example, we have our deployment here, and we say we make this super important change in pod info, and we say, let's just change the color here. So push the changes. Reconcile changes. We should probably, hopefully, see our canary. Hopefully see the canary. What? No. This is not. Did I push my changes? Did I make the correct changes? Yeah. Let's do that again. Or sorry. Let's make some other change.
I think it went through. It's just that Flagger does a bunch of stuff before it continues. Can you look at the canaries again?
Oh, now it's running.
Yeah,
So,
it usually has a 10 seconds delay.
Yeah, okay, yeah. So what we see now is that we are actually, in this case, we have a very quick task run. But what we see here is that as part of the canary, we're actually starting a task run. In this case, we're just sleeping pretty quickly. I have another example where we can trigger this, but it fails. So in this type of scenario, we can see that our canary is not going to progress, or it's the webhook here is saying the potted for good task run is supposed to run. And that's going to obviously pass through the canary. So what we see in Flagger is that, let's look at the Flagger Tecton, the custom load tester, is that we are getting post hooks from the Flagger instance, telling it that, okay, so what am I supposed to do? In this case, what we're doing is we're using the timeout functionality and waiting for the actual task run to complete before we're saying it's a 200, and this is good. So in another scenario, let's just reset hard and do canary, change the canary to run the, I think it's called bad. Yeah. Change the task. We can show that in this case, we're simulating then that you have this very complex Selenium job or whatever you're doing to validate that your application is actually being deployed. We just want to reconcile that. I'm not sure how Flagger handles changes to the canary at the same time. We can then do like this, make the actual changes to check bad. Yeah, so that's now going to the bad webhook. I'm guessing that it's going to, in the middle of the task run, it's not going to run because this was a pre-check. So what we can do then is that
it will restart everything because
yeah.
The deployment has changed.
Exactly. So in this case, now we're going to do a new deployment, but we're telling the canary that, check the bad task run, that if you want to see the bad task run, we can see that it's just exact same thing. It echoes hello world, but just exits with 1. So in this case, we expect it to fail. So I don't know how I'm doing in time, but this is like the last part of my presentation. So the idea here is that we can build custom solutions to run other types of complex jobs. And this is kind of like the presentation is going through the different types of use cases or the different types of functionalities that you might want to look at when running jobs, basically. So at the simplest, you have the solution where you have 2 separate customizations that one triggers the job, the other depends on it. That works pretty great, but it doesn't work with this types of use cases where you may want to deploy your job and then run complex solutions at the same time. You could technically do this with Flux, but you'd have to solve health checking. So you could set up the solution that Kevin has with triggering with the event listener and then triggering a task run. But in those types of solutions, you'd have to have a way for Flux to know when the task run has failed. And that's kind of where that solution kind of got stuck. So this is another type of look at using Flagger together with Tecton in a way that might not have been the initial idea, but I think is a possible solution. And yeah, we see here that it failed. We can also see that it's giving a 500. So it's saying the task runner has failed. And we can then see that hopefully that the canary is stuck or should be stuck at least.
It will retry for however many times.
Exactly.
Set it.
Yeah. So,
Flagger has these toleration thresholds they can set. I mean, maybe the task failed once, but you want to restart it, and you can tell Flagger, hey, wait a little bit, give it another chance. Or you can say, if it fails once, roll everything back and stop it.
And the benefit of using Tekton for these types of solutions is that because Tekton as a run result is stored in the Kubernetes API, no matter how many times that Flagger calls on your webhook to run this job, it won't rerun it. It's just going to check that, well, I get my hash of the last promoted version, and it's going to recheck and see that, oh, I've run this task run and it failed. So no, here you go back 500. So that's kind of the type of solution that the current load tester, because it's all in memory, this type of solution solves. So that was my I am sorry moments to Stefan, and then Stefan can rip this solution. You always have to come with at least something, new and different. Yeah, that was all from me. So thank you very much. I hope you learned something about running jobs with Flux in Kubernetes.
Thank you very much, Philip.
Let's stop sharing here and get over.
Yeah, over. Okay, so next we are going to talk about Flux observability and how we've built all sorts of things into Flux to make your GitOps pipeline observable. One thing that Flux does today, and Philip talked about this in his presentation, is health checking, right? So if Flux deploys something, it can also look after the things that it has deployed, and it can let you know if they are failing. And this works by the magic of a library called kstatus, which comes from Kubernetes, which is smart enough to detect the readiness status, not only of Kubernetes native kinds like deployments, jobs, cron jobs, and so on, but also custom resources which subscribe to some particular conditions that they have to set, and kstatus, the library, will look for that, right? So those that build Kubernetes custom resources, if they implement the kstatus standard, then Flux can, hold, wait, and report back the status of a particular custom resource. So that's one of the main features that we've added to Flux version 2. And health checking works very great together with depends on what Philip said, right? Where you can have this condition. So run this only if this other workload was successful and stuff like that. Going back to observability, we publish everything that's happening with inside Flux as Kubernetes events. And you can do kubectl get or kubectl describe for a particular Flux resource. Let's say you can do a kubectl get helm release, I don't know, Loki, and in there, if in the events, in the status of that custom resource, we report what we did last with it. Did we upgrade it? At what version? If it failed, why it failed, and so on. And as I said, we issue these Kubernetes events for everything that Flux does. So if you have an event sync, you can take those events and forward them to, I don't know, CloudWatch or Elasticsearch or whatever. And we do the same thing with logging. We all the Flux controllers are logging in a structured format in JSON. So you can detect errors, you can detect the time it takes for a thing to happen, and so on. And we are going to make a breaking change in the future Flux release around our structure logging. We are Kubernetes recently also got JSON structure logging into Kubelet, KubeAPI, and those controllers. And we are going to align with how Kubernetes, what are the Kubernetes tags that it uses for logs. So we are going to change a little bit our logging structure to align with Kubernetes. But I think it's all for the best. You can have a log query that works for a Kubernetes native controller, but also for Flux in the same way. Another thing, we have instrumented our controllers with Prometheus, and we expose Prometheus metrics, and you can build alerts based on those metrics using Prometheus Alert Manager. And in our documentation, we have examples on how you can get alerted when something fails and so on. We also provide Grafana dashboards for the Flux things, and I'm going to show those to you. Next, Flux also comes with a controller which is called notification controller, which can it listens to the Flux Kubernetes events and can forward them to Slack, Microsoft Teams, Discord, Google Chat, Sentry, message queuing systems, and so on. This small component of Flux has took over from external contributors perspective. A lot of people have added over time new integrations and so on. It's different from Alert Manager in many ways. For example, with Alert Manager, you get a notification when something fails, right? Based on some metric, some number. But why it fails, you have to look into your Kubernetes cluster, tail the logs or whatever, right? Flux Notification Controller captures the error stack that Flux sends, and it sends that to Slack, Microsoft Teams, Discord, whatever. So in your Slack channel, you'll actually see, oh, this hand release failed, and also the error in there in the same message. So that's why we built notification controller, and we couldn't just rely on Prometheus Alert Manager. There are two different things made for different purposes. And finally, part of our observability story is the commit status update. What that means is that every time you do a git commit, Flux will do whatever it needs to do based on the changes that you made to the repo, and then Flux Notification Controller can write back to your Git repository and update the commit status with the result of what happened on the cluster. So you get instant feedback. If something failed, you can see there in GitHub, GitLab, Azure DevOps, Bitbucket in their UI. And I want to give you an overview of how to set up Prometheus stack and Loki. So we have here a guide on the docs website on how to set up monitoring with Prometheus and how to set up a log aggregation with Loki stack and how to install the dashboards and so on. So what I did was I created a private repo with Flux Bootstrap GitHub. Then I've added to this repo a monitoring stack for my cluster. Now I'm going to walk you through a little bit inside the repo and see how I'm setting this up. So I've bootstrapped Flux on this path cluster base. This means in here, there is a Flux system directory with all the Flux components, right? If you want to keep Flux up to date, you can use the Flux GitHub action that will update the components every time there is a new release and so on. So you can fully have Flux up to date without, applying things on the cluster directly. Flux knows how to update itself and so on. So, okay, I've set up Flux for this path. It synchronizes everything in this base directory. And here I have a thing called the monitoring YAML, which are two Flux customizations, which are applying things from inside this repo in a particular order. And what I'm doing here, I've defined in my directory add-ons monitoring, I have I have two groups of manifests that make my monitoring stack. One group is the monitoring controllers, and we'll see what's in there. And the other group is my monitoring configuration. And the configuration depends on the controllers. So first I'm installing the controllers and all their custom resource definitions. And then after that succeeded, then Flux will install on this cluster the monitoring configuration, which are Prometheus operator custom resources and other things like that. So let's look inside add-ons monitoring and see what we have here. So in the monitoring directory, I have, as I said, controllers and configuration. Let's look at controllers. And inside controllers, I have, for example, Helm release that deploys the Kube Prometheus stack chart inside my cluster. And this sets up Prometheus, Prometheus operator, exporters for core DNS, Kube API, and so on. And it also configures a Grafana instance that watches for config maps that can store other Grafana dashboards. So this is all set up through this Helm chart, which is maintained by the Prometheus community. Then inside my configuration directory, I have, for example, I have here my JSON file with Grafana dashboards. How can I get these JSON files to actually be loaded into Grafana and have all my Flux dashboards in there? Well, I'm using Customize here with a config map generator, and I'm telling Customize, hey, look at all these JSON files and make from all of them a config map. And what's important here, I'm also telling Customize, when you create this config map, add this label to it, Grafana dashboard 1, which tells the Grafana sidecar, hey, this is a config map which actually contains dashboards, so you have to load it in real time into Grafana. It doesn't have to restart Grafana or anything like that. So this is how I'm setting up my my custom Flux dashboards. And this is already running on my cluster. Let's look at monitoring. So if I do Flux get all from monitoring, let's see what we have deployed in here. So we have all these charts and Helm releases. And I have this Kube Prometheus stack, the Kubernetes dashboard, the Loki stack, some other UIs. And I also have specific Flux objects for Grafana. I'm going to show you right away. But if we look in the monitoring namespace for config maps, we'll see here a config map named Flux Loki dashboards and another one Flux Grafana dashboards. And here is the checksum of the files in my Git repo. So every time I'm changing something in my dashboard definitions, when Flux will rebuild the config maps, it will generate a new config map name, right? So I'm treating these config maps as immutable. So with every change, Flux creates a new config map. Then Flux also patches the Helm release that uses these config maps and triggers an update of that. So, and at the end, it also deletes the old config maps, right? Through garbage collection. So this is how I'm making sure that any change to my config maps are reflected in the cluster as unique objects. So let's see these dashboards and what they do. One dashboard is showing the Flux control plane, all the controllers, how they are doing, CPU usage, memory usage, how many API requests they make to the Kubernetes API. And I recommend a lot this dashboard when you deploy Flux at scale, when you have hundreds of Helm releases and customizations and Git repositories and so on, you have to be careful and monitor how many Kubernetes API calls Flux is making, because Kubernetes API has a rate limiter, right? To not get overwhelmed, Kubernetes API will rate limit Flux if it does thousands of calls. We are very careful how we perform these calls. We use caching for all our get operations and so on, but this is one way of seeing how many objects you have. Maybe you've set the customization interval to, I don't know, a minute or a couple of seconds, and you're basically DDoSing your Kubernetes API without even knowing. So this dashboard is great for that. It also gives you an overview of what things, how many resources Flux is using. If you have huge Helm repositories, index files, you'll see here that source controller uses gigabytes of memory instead of 10, 20 megabytes like it should use normally. So if we look here at source controller, this is his memory, it's like nothing. Flux is meant to be run on edge devices, on Raspberry Pis and so on. So we made Flux use as little resources as possible, but Flux is very influenced about what you have in your sources, right? How large are the Git repos? How large is the Git history, Helm, the size of the Helm charts and so on can influence Flux resource usage. Okay, so this is one dashboard. You also can see timings, how much it takes to reconcile each Helm release, how many operations is doing, and so on. Second dashboard is called cluster stats. And here is all about having an insight into Flux custom resources and their statuses, right? We have here the average duration of each type, like, okay, for reconciling all the Helm releases in my cluster, the average duration is half a second. For customizations is larger, it's close to 1.5 seconds. Why is this happening? Why are always customization more expensive in terms of time than Helm releases? Is because Flux is able to undo any kubectl edits on the cluster. So if you connect to a cluster outside of GitOps, outside of Git, and you start editing random objects that are controlled by Flux, what Flux and the customized controller does, it continuously monitors your cluster state, and when it detects a drift, oh, you change this container image, but in the source it's a different version of that container, it will automatically undo that change. So in order for Flux to detect drift, it needs to do a server-side applied dry run. So depending on the interval that you've set in your Flux customization, what Flux will do will ask the Kubernetes API, hey, for all these objects, are any changes inside etcd? And Kubernetes will respond, oh, this object has changed. Okay, so Flux will actually apply that object, undoing all the manual changes. So that's why customized controller is more heavy than Helm controller. And we also want to solve the drift detection for Helm charts as well, for Helm releases. A lot of people are saying, hey, I'm doing a kubectl delete of some deployment, which is part of the Helm release. Why isn't Flux recreating it? Well, because we in the Flux Helm integration, we look at the Helm storage, not the actual objects which are there in the cluster. If you do a Helm upgrade, we roll back that immediately. But if you change objects which are created from Helm, we have no knowledge of those. And this is what we are working on next, is detecting all the things that come from a Helm chart and doing a similar dry run action and detect changes and undo it. Okay, so this dashboard shows you, errors, if you have Git repositories or any kind of source that is failing. And here are tables with which one is failing. What you'll not be able to see from this dashboard is why it fails, right? These are Prometheus metrics. You only see that they are failing or not. If you want to see why it fails, then you have to look at, oops, let's see, too many outstanding requests. Yes, I have this problem with Loki. I haven't figured out what's going on, but it will recover. Okay. So if you really want to know what happens inside the cluster with this solution is, first you'll see here, okay, something failed. Then you have to go here. This is a dashboard built on top of the Grafana Loki data source, and is particularly made for Flux. It filters by the Flux output and so on. So here you can search for your application that is failing. You put the name here, and in here you will see the actual reason why it's failing and so on, looking at the logs. And if you are using this Helm chart, the Kubernetes stack Helm chart, it comes with a bunch of other Grafana dashboards for monitoring Kubernetes in general, not only Flux. So you can see deployment status, pods, and so on. And here is how Flux is doing. I'm filtering only the workloads in the Flux system namespace. And I don't know, let's look. Past 15 minutes. I'm reconciling a bunch of apps inside here. It should be some activity. Yeah, not much is happening. Flux is quite easy on CPU usage. From time to time, when it does something, it uses something like 0.000 something from a CPU. So yeah, I wanted to share this to showcase that Flux is very, very light compared to its competitors on your cluster. Okay, so this is one solution on how you can drill down into Flux and find issues and eventually debug the problem by looking at the logs. Now another solution to this is, instead of using any kind of dashboards or any kind of UI, you can, of course, use the Flux CLI, which gives you an insight into everything that's happening. It can also print all the logs. You can filter the logs based on things like custom resource definition names. You can only print the logs of the customization for a particular name in a particular namespace. You can follow logs, you can filter logs based on errors and so on. So this is the CLI experience, right? For, I don't know, Linux people which are love CLIs, this is the best way to, dig and debug Flux. But what about all the other users that, they want a user interface? And especially a web user interface. Well, for this, there is a nice, great, awesome open source project made by Weaveworks, the company I work for, and it's called with GitOps Core. It's an open source web UI made especially for Flux. There is also a paid version of this. We have to, sustain Flux development somehow. We are, I think, around 10 people working full-time from Weaveworks on Flux. So yeah, someone has to pay for all of that. And there is, as I said, with GitOps Core, which is the open source UI for Flux, and it's also with GitOps Enterprise, which is the paid version, which comes with cluster API integration, multi-cluster deployments, and a lot of nice things when you run Flux at scale. And I'm going to show you how easy it is to deploy with GitOps Core on a cluster. Going back here in my repo at add-ons, I have a directory called with GitOps here. And with GitOps, the UI is published as a Helm chart. So I can define a repository coming from Weaveworks. Then here is the actual release. And I'm setting here all sorts of values. I'm creating an admin user, and I'm setting here the bcrypt hash of my password. So let's look at how this is. This is the login interface. You have two options here. For testing, you can do it like I did. You can hardcode an admin username and password in your Helm release, or you can use DEX and log in with an OEDC provider. For example, you can log in with your GitHub credentials and allow your GitHub teams to view some cluster by logging in directly into with GitOps with their using GitHub authentication. Going to log in as admin, the OEDC setup, and let's see what with GitOps shows me. So there are two views here. One are applications, which are a generic thing. There is no application in Flux. There are customization, there are Helm releases, there are all sorts of things, but you can make those into, you can use these low-level concepts to, create your own application idea. So that's why everything here in terms of any kind of object that reconciles something on the cluster will be listed here under applications. And we also have sources, and here you can see all your Git repos, Helm charts, Helm repositories, and so on. I have deployed the demo app, which is, let me see here. I created recently this repo, which is called microservices demo. It's very different from the Weaveworks microservices demo or Google microservices demo and so on. It's specifically made for Flux. Each microservice is controlled through a Flux customization. And the actual instance is a tiny app I made in Go, which is very light in terms of resource uses. So we can run 20 Kubernetes deployments, which are making the whole microservices demo with just 300 megabytes of memory. And it works on Raspberry Pis, it works on Graviton 2, and so on, because like Flux, all these containers are multi-arch. Okay, so I have deployed, I have used this repo, the microservices demo, and I have a reference to it from my own cluster repo. So if we go back to my cluster repo here, okay, I'm going back here. I have in my cluster base, I have this microservices demo where I'm defining a Git repository that points to where all my microservices are defined, and a customization that bundles all the microservices into an app, right? So here is how you can build apps with Flux custom resources. And here inside my app, I can do all sorts of things. I can change a particular microservice, or I can update a particular image, and so on. And all my apps are running in a service mesh because, yes, I want to use Flagger for continuous delivery and so on. If we look here at microservices demo, let's see how this looks like. Okay, this is, let me go to applications, MS demo. Okay, so this is the top object that contains my app, which is made of all these microservices. So let's see how we can, visualize that in GitOps. We have this customization, it goes to my default cluster, it has this source, and it has this revision. Now, if I click on it, it will bring me to this details page, where in here, I can see all the other Flux objects that are, reconciled on this cluster by this one. And I have here all my microservices, admin, advert, authentication, frontend, and so on. Now, if I want to drill down in a particular microservice, let's look at the front end. I see with GitOps shows me all the things that were reconciled from this customization. Deployments, replica sets, pods. I can also see the version of each container image. I see my Linkerd proxy. I see my app, which version is, and so on. Also, I can see all the Flux events for this particular app. So any kind of errors or anything like that, you'll see it in here. You also have graphs where you see how, from which source a particular application originates in. So here is my Git repository. This one is used by the demo front-end customization, and the customization, what it did on the cluster, it created deployment, replica sets, pods, and so on, right? Then you can fully drill down into what's happening. If you are doing an update of a particular application, here you'll see in real time if it works, if it fails, why it fails, and so on, right? So with GitOps tries to give you that insight, visual insight, if you don't want to deal with CLIs and Grafana dashboards. Another nice feature of this is the fact that it gives you the YAML definition of a Flux object, but not the one you have in Git, is the one that it's in the cluster. So you actually have access to all the conditions. You see the Flux inventory, which objects Flux controls, and you also see how Flux does the service apply, which fields Flux manages, which other fields other controllers are managing, like horizontal pod autoscaler and so on. So this is really nice for debugging because you don't have to do qctl get and look in there. You have all of this here in the web UI, and it's this project is early on. There are many more things coming to the with GitOps UI, like showing this Helm chart is from OCI, this version, and so on. So Weaveworks is improving the web UI by the day. I'm very excited about it. Even if I'm not a UI user, I use Git and the CLI with Flux. Okay, that was it. I went over time, like always, but it was great showing finally a UI for Flux.
Awesome. Thank you so much. Seeing the awesome comments on Slack. Thank you to Philip and Stefan for this. And if you joined us yesterday, then hopefully you know the drill. We'll just shift over to the Slack channel where we've noticed people filling it up with questions and conversations, and we will have our speakers there, and we'll continue to do that. So like if you're watching a recording late, we'll just ping the speakers if anything comes up and they don't notice it. So thanks again to Philip and Stefan, always fantastic, always learn a lot. And yeah, we'll see you on Slack. Enjoy the rest of your evening. Thanks for joining us late. So we are about to take a break, but before we go into the awesome musical break and to kick off the keynotes with DJ Desired State, we have an announcement from the Flex Your Flux campaign that would be ongoing. But for this one, we had sort of solicited people to join us at KubeCon EU to fill out the form that Vanessa had put together, and the prize from the drawing that Vanessa do the drawing from is a 1-hour meeting with a Flux or Flagger maintainer. So lots of people filled out that form. We will share the link to the form because we'll do another drawing in the future. So if you didn't win this time, you can always try again. And then we'll keep the people who filled out last time. But you did have to put your contact information so we could reach you to let you know that you won. So Vanessa will be announcing some of the winners, but we wanted to make sure to protect people's privacy because, you know, it was under the aegis of KubeCon. We're just going to announce the countries from which people won. And so hopefully if you hear your country, which like could be quite broad, but make sure you keep your eye out for your email because Vanessa will be reaching out to you to let you know, hey, when would you like to schedule 1 hour with one of the maintainers? And as you may know, besides Philip and Stefan, there are many other maintainers of these projects, and they have all agreed to help out with this in various time zones. So it's very generous of them to provide this time. And so we'll be, as I said, ongoing. So Vanessa.
Ooh, say it makes it easier because we're just announcing countries. Okay, guys, don't be angry. Again, you still have a chance to win. As we said, we're going to put it in the Slack channel. So there are two. I'm going to announce by countries where your companies are based. So there are 2 US companies, 1 Canadian. Is it Canadian? Am I saying
Canadian.
it right? Okay,
Yes.
good. Portuguese and a Portuguese company or a company based in Portugal, France, and Germany. UK people, I'm so upset. You should have done better. I'm super upset.
Well, they can't control the drawing. So
Oh,
yes.
it's fine.
So yes, so we'll remind people, we had many people fill out this form. Of course, we made the contact information optional. But if you did want to be entered the drawing and you remember that you did not put your contact information, you're like, oh, wait, I didn't catch that I could maybe win an hour with a maintainer, then yes, please feel free to fill out the form again, like I posted it in Slack and on YouTube. And there's also a survey that follows up with that. So that was the other thing. We asked people to fill out a survey. And yeah, it's all pretty quick, but I think the opportunity is fantastic. And yeah, we love chatting with the community, and we've been reaching out in general as well, hearing from people's user experiences, and that's what led to many of the speakers that you're seeing during this event. So again, thanks. Again, 2 in the US, 1 in Canada, 1 in Portugal, France, and Germany?
Germany.
Yes.
Yep, correct.
Okay, yes. And yeah, again, we will continue to do this for as long as, you know, we hope is helpful for the community. So please check out those links. So with that, we will take a break until the top of the hour with DJ Desired State, who will come on in a second. And I was just looking at Daniel, who is DJ Desired State, the unofficial name, had found out that there was, I guess, a Desired State, somebody shared on Twitter. I don't know if this is the band or the name of the, I guess it's the band. And they had an album out back in the 90s or something like that. So
Cool.
But in our case, I have a feeling they might not have had the GitOps nerdy reference that we do today. So let's check in with Stacy. Let me double check. Can I see Daniel here? Oh, sorry, that's right. We have. Thank you. We'll be back in 10 minutes. See ya.
Yeah.
It's like gold dust. You hear me coming through your speakers. You see me plugging up your airwaves. I know you can't get enough of my sound. It's like gold dust. You hear me coming through your speakers. You see me plugging up your airwaves. I know you can't get enough of my sound. I don't know where you are from, what you're running from. Oh, I don't know where you are from.
Hey, Vanessa, are you there? Woo!
I am so here and ready. Sorry, I was in the middle of dancing. I didn't know what was going on. I was having a great time.
Absolutely. And it's well, late afternoon getting into evening for you. So you're
Yep.
in that mood. I'm here over at 9 a.m.
It's 5. Everyone is done with work. I'm having a great time.
Yes. I was thinking I probably would be more productive if I kicked off every morning this way. Which actually I have. There have been
Ah,
times, yes, there have been times that I have gone to the previous recordings. In fact, we should share that
yeah.
Stacy has posted all the playlists from all the past GitOps days, and
Wow.
they kind of and put them all together. So that makes it very convenient that Michael Bridgen, who's the creator of the original Flux, was also posting like, oh, totally working to Daniel's music. So
I
definitely,
can see people's stuff, like pictures on Twitter. It's so great. I love it.
absolutely. Sorry, I was just doing a time check because yesterday things were exciting. We kind of fell behind schedule. So today we are going to keep track, but it's hard because all the talks are really great, and some talks only go over like a minute or two, but then that added up. So we want to make sure that today, glad to see everybody here. Thank you for coming to GitOps Days. Vanessa and I will be emceeing here this morning. Vanessa is our newest community manager here, helping out the Flux community. And if any of you were at KubeCon EU, you got to see Vanessa in person at the Flux booth and tweeting all the amazing photos of everybody sharing their shirts and chatting with the maintainers and the contributors. And I definitely was feeling FOMO here out on the West Coast and really enjoing all the
Yeah.
photos.
You should have. It was Fluxtastic. I
Yes.
loved it.
Oh, I think that's going to be your next hashtag.
Yep.
We'll have to
Yep.
have a Fluxtastic campaign. So on that note, welcome if this is your first time to GitOps Days. This has been an event that we had been thinking about starting to put together, and then COVID hit, and in a way it made it very convenient that we could do these live broadcasts. If you look back at our past recordings, the first year, the very first GitOps Days, in fact, we kicked it off very excitingly with Kelsey Hightower, who is, of course, always very exciting and really great to hear the continued level of speakers that we've had throughout these years. It's been just so humbling and really gratifying to see. This time, we're really showing more and more Flux users, companies that have added themselves to the adopters list to Flux and or Flagger, and are here to share their stories. Hopefully yesterday you heard from Orange and Crayon and State Farm, and then Crayon and State Farm are some of the people who will be rejoining to go into a little bit more of a technical deep dive today, together with other companies such as OSO, Zscaler, Safaricom, RingCentral, and many, many more, who are on various ranges of their journeys, and we hope that that's very useful for you. So if you are, even if you're early on your journey or advanced and you would like to speak at a future event, please reach out to us, because yes, we are engaging more and more with our Flux users, and it's really exciting to hear what people are doing and how they're contributing and building upon Flux. So with that, I'll reiterate that in past GitOps days, we've done a call for papers, and we've had a range of technologies. We've had friends from many other projects, and we will continue to do so. For this particular one, it was just so jam-packed with these Flux community members that we thought, well, instead of creating a 4-day event, as Vanessa was joking earlier, who knows, GitOps Days will be a 1-week thing at some point. But right now we're keeping it at 2 days, and so we felt like, well, we do many GitOps Days events, so maybe this particular one we will focus on Flux. But yeah, stay tuned. We always want to grow the ecosystem, not just for Flux, but for GitOps in general. There's really many, many great practices, but we thought we had so much to celebrate, hence the fireworks, on just the advancements on what's been happening with the technology. So if you missed the talk with our two maintainers just before this, everything's recorded. And I'm not sure how YouTube streaming works, but you might be able to rewind and be able to see those. But we'll have these open for several days, including the fact that yesterday we kicked off with a 90-minute intro to Kubernetes and GitOps tutorial. So that will continue to be open. So if you registered, you have these links and you can get the additional information you need to follow along with the tutorial and the recording. And very generously from the Codespaces team over at GitHub and Microsoft, they are keeping open access to that environment so that you can actually follow along with the hands-on. So make sure you join the Slack and get all that information so that you make full use of this wonderful event. So with that, again, an overview. I said there's tons of community speakers and we're really, really excited about that and appreciative of their time for sharing what they're doing. Another thing we have to emphasize is just how many of the major companies such as cloud providers that are providing GitOps to you in case, I don't know, your company maybe is a little nervous about open source, or you're already using a platform and it would just be much easier to use the GitOps options that are made readily available. It was just so exciting to hear from Microsoft, AWS, VMware, D2IQ, Red Hat yesterday on how they've made that possible. And they've made that possible using Flux. And I bring that up because I was actually just talking to one of our major companies that's just started on their Flux journey. And I said, oh, by the way, did you know that these companies are using Flux and in some cases almost exclusively leaning on Flux for GitOps? And they said, wow, that pretty much just seals the deal for me. Like that is immense validation for the maturity of this project, and you know, just the smart design that our fantastic maintainers have put into it. So it's great to see people on that journey. If you have any questions about that, and especially as you'll hear today, security obviously is security and scale are massive, right?
Can't wait for Anais's talk.
Yes, and we've got Anais who will be talking about that as well, and you'll be hearing from the users. You know, these are major companies like Orange yesterday, right? Security, scale, velocity, all those things are just at a different level. So if you're at a smaller company or you're at a similar level, you can rest assured that these technologies are really being tested and being able to expand. And hence, as we talked earlier, Daniel Holbach, our GitOps Days period DJ, puts out a monthly newsletter on the updates on Flux, and there's so much there, and you know how much it's been engineered and in some points redesigned for that enterprise level capability. So it is really, really fast moving, and as one of our users has shared, there's always the idea that, well, maybe we might build something. And then when you see how dynamic the community is on Slack and how you know, dedicated people are working on the technology, it just makes sense. They're just like, well, why would we build something when there's a whole bunch of people who are very knowledgeable making this happen? So it's really, really exciting. So hence, we are focusing on Flux. And the final mention is Flux working with many technologies. If you've heard our talks in the past, we've definitely had Kingdon on our team talking about how, for example, Flux works with Jenkins and almost all the CI tools. We know that if you're brand new to GitOps, some people are concerned, oh, well, I've set up my whole infrastructure. Are you telling me I have to tear it all out to move over to GitOps? Well, no, not at all. Flux works with many of the tools that you already have. And increasingly, you know, supports the other tools that you probably have in your kit, like Terraform, HashiCorp Vault, of course, Helm, Customize already. And now yesterday we had the soft launch of Visual Studio Code, which Kingdon has also been working on. So if you use Visual Studio Code and you're excited to be able to engage with Flux through it, well, check it out. We put the link in the Slack. I'll put it in again. And it's a pre-release, so if there are any issues, please talk to us. And yeah, no need to give stars quite yet because it's very, very alpha, but it is working, and we're very excited, and we've got people dedicated to making it better. So with that, we talked about all these great, exciting users. Vanessa, would you like to introduce our first user speaker for today?
Oh yeah, I'm like super excited about this one. He was on yesterday, am I correct?
Yes.
Okay, so you guys know if you were there exactly what you're looking for. So Robert Strand is on today. Robert,
Hello,
hi.
welcome back.
Hello.
Welcome back. And we can't wait for your talk. Are you ready?
My voice is weird, and I'm home alone with the dog, and the neighbor is, doing something into the concrete walls. So yes, what can go wrong?
What could go wrong, I guess. Well, I don't hear anything now, and
No, neither do
it'll be
I.
good.
It sounds
Wait.
great. Okay, take it
Wait
away.
and see. All right, thank you.
Thank
Let's
you.
see if I actually can share the screen as well. That's also a good idea. There
Yes.
we go. Yes. So again, my voice is kind of weird. So I'm just gonna hope that it sticks with me throughout this talk. And also I'm a little bit pressed for time on this one, so it's kind of hard to wrap everything up. I tried a couple of times and I had to remove a bunch of slides. So some of these things are gonna go a little bit fast, and then I'm gonna slow down on the more important things. But like mentioned, my name is Robert. I talked yesterday, so it's really nice not only to have my first GitOps days presentations, but having two of them. I'm still the head of platform engineering at Crayon. I'm an Azure MVP and also a HashiCorp ambassador. So the topics that we're going to talk about today is related to my new job as a head of platform engineering, and where we try to go when you think of cloud native, and obviously GitOps is part of that. So that's what I'm going to try to talk about in 20 something minutes. Anyway, before I start with that, we kind of have to talk about what Crayon is, because there's some very specific things that are happening because of who we are. So Crayon is a relatively anonymous company for most people, but it's actually 20 years old, and it was 20 years old this May. It's a company that started in Oslo, Norway, but are now we literally have offices everywhere. So everyone who's watching now probably has a Crayon office in their country, or maybe even right next door, for all you know. We're spread from the far west to the far east and everything in between. We have some of these numbers. I'm not even sure if they're correct, to be honest, because I just stole this from a marketing slide, and I think they are outdated before they managed to update it themselves. So we have a lot of people doing a lot of things. I should say that. What we are focused on four what we call service pillars. We mainly are doing what we mainly did was license reselling and cost optimization. That's where we started, but we added more things like services department that are doing like the typical advisory, cloud advisory and consultancy things. Help people migrate to cloud. We also do a lot with data and AI and everything in between. And like I said, I have a dogger, so hold on. She doesn't understand that I'm doing stuff. So these are like the four pillars of Crayon. This is what we're doing. And then we have Crayon Group on top, which is where I'm currently at. I used to be in Crayon Norway in services, so I was out at clients and did things. Now I'm trying to help everyone in Crayon to do things in a better fashion. So we're gonna start, talk about like the cloud native journey, and like where does that start? It might sound like I'm complaining, but it's not. It's not complaining, to be honest. It's just like this. This is how it is, and it's probably the same in a lot of organizations. So, like, where did we start? It's like seeing where we need, like, where do we start, like, doing some changes? one thing that kind of crept up, or we saw, which to be honest, I've seen at basically all the companies that I've been with and that I've had like some sort of advisory role with, it's silos, right? That's like the famous thing, like everything, you know, we're trying to remove all these silos, but everyone has them, so there must be a reason for that. And I think this is just part of like natural growth of a company. The things that we do now is nowhere near the same as what happened even 5 years ago in many cases, and it's like totally natural that it ends up in this way of fashion, because some of the decisions like take time to implement, obviously. So you know, these always just happens by themselves. So we have all our consultants and services. They are doing things in their pace, and they're doing things with their own code and everything like that. All the different subsidiaries, so all the different countries, they have initiatives that they're doing. And even internally, like our in-house development team, who's doing many of the bigger products that we're doing and services that we have, and the operations were also split into two. So on one end, we're trying to do modern IT things. At the same time, everyone has to like reinvent the wheel over and over again. The reason why it's like that is probably because there's no simple solutions to what we do, because we're not a like one customer facing product like a social media or a certain service. There's no one thing that we do. We have 4 or 5 different customer facing services, and we have internal services. We have products that are specific just for internal use or just partners. So there's no one way of dealing with all of these things. Like, how can you solve everyone's issue on all different types of architectural models, and like it just doesn't work, right? So that's partly the reason why everything is the way that it is. And we need to solve things in such a flexible way so that we not only allow people to do what's the best for the things that they're developing, but we also need to have some sort of control, right? And when I pull this quote up, I'm sure most of you are aware of what this is. This is Conway's Law. And it's one of those things where it's really funny how Melvin Conway in 1967 could speak these words, and it seems to be still actually true today. And it's one of the few things that are considered a law or a principle or things you reference to when you're trying to explain things to people that is actually accurate, it seems. And the quote is, organizations who design systems are constrained to produce designs which are copies of the communication structure of these organizations. And obviously this is written in 67, so it's kind of like weirdly put, but I think it still holds true. So if you have a team structure that kind of seems like this monolithic big thing where with little flexibility in between, that's what you're going to end up having. If you have much smaller teams doing different parts of a larger system, you're probably going to end up with something that looks like a microservice architecture, or just design driven design. It doesn't obviously have to be correlated directly in that sense, but it seems to ring through, and we see that also in the systems that we have now developed. They kind of resemble the teams that have designed them. So, what do you do with this? Well, when we're starting to move away from this, we're trying out something called inverse Conway maneuver. And so instead of letting Conway's law define our systems, we would rather see that this, like, where do we want to go? Where do we want our systems to be, and how do we want them to look? And then rather design the organization based on that. So, we don't have these like restrictions that we get from something like Conway's law. And this means creating more teams, perhaps smaller teams, more autonomous teams, all the buzzwords at the same time. We need to do DevOps, we need to do cloud native development, etc., etc., etc. So obviously, if we give people the responsibility to do their own operations on their own developed software, they also need to have both the flexibility to choose wherever they want to go, but they need help to do some of the decisions. But they also need some tools. They need to have some sort of, for instance, you have SREs that are doing monitoring and everything related to scalability and stability to help these teams to be able to operate their own software without having to, everyone again reinventing the wheel all the time everywhere. And a lot of these like internal services would have to come from somewhere, and that's kind of where the platform engineering team comes into play. So it is a brand new team. This type of team hasn't existed at Crayon in its 20-year history. And it's and currently it's a team of one. So hello, I am platform engineering, but I'm happy to say that we're hiring people and we're gonna do a lot of cool stuff. But obviously it needs to start somewhere, right? So we need people that have different types of experience than what we already have inside of the company, because we want to do stuff like creating the internal developer platform, which people probably know about. There's going to be API for a lot of things and a lot of internal services, and we're going to help. One of the things that we're doing is structuring the architecture. So we're using Azure. We're following the Cloud Adaption Framework and the enterprise scale architecture model. This means that basically you set up all your platform services in its own part of Azure, and for instance like the identity, connectivity, and the management parts, have that under control under the platform landing zones. And then for each team, product, or however you want to slice it, you have landing zones which they get access to, which they can do whatever they want, but obviously through policies and everything like that, you guide people in the right direction, but you give them that flexibility. For these landing zones, we don't want people to sit literally in the portal just like clicking new subscription and do everything manually. So people should be able to, whenever there's a new project, whenever they need a new landing zone, they should just say, I want a new landing zone, and go through an API, and all the automation will solve all those issues. So we're doing some of these internal tooling, and we're doing some of the architectural, like guiding people in the right direction. Obviously, always facilitating collaboration between the security and the infrastructure people, and so on and so forth. But also doing like general guidelines and frameworks. And one of the things we're going to do, and one of the ways that we're going to do this internal developer platform is not just through Terraform, which is very much used from a Crayon perspective, but also GitOps. So the way that this is going to work is, and again, this is a little bit more, it's a more advanced model. So most people will say, all right, Terraform, let's do Terraform, let's create these different root modules for different deployments and child modules for different resource life cycles, etc., 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 and then let's do all that deployment. Now, what we want to do is also put in GitOps into this, because GitOps for me is literally the future of like true cloud operations. This is what will make us leap forward from where we were, like efficiency wise, and there's a reason why we are very much behind GitOps as an operational model. But at the same time, since we aren't one team that's going to do things, and we don't want to have like explain to all the developers that are all different types of developers that are doing all different types of things how to do GitOps, we need to have that abstraction model. So we're going to use GitOps as part of our technology stack for our automation platform, and it's going to be supported by the TF controller from Weaveworks that I talked about yesterday. These will be the basis for how everything gets deployed, and then we're going to use Terraform as an integration tool. the nice thing about Terraform that all the integrations against all the different cloud vendors are there, and it's a really well-known tool in Crayon, and we use it externally against customers. And we are doing all of these shared. We are doing like public facing modules. We have code that is out at customers that we all collaborate between, both us and like internally and the external facing architects and consultants. And in that way, we can have this one shared way of doing infrastructure as code. So, by utilizing that, we have like this, get this culture of collaboration and knowledge sharing, which is really important to do stuff. Next part of the puzzle for this will be what I call rolling production environment. It doesn't sound that fancy, and it's not really a new idea in itself, and most people probably think that this is the way to go now, as far as I can tell. I see a lot of people talk about this, but the idea here is that everything that we are doing is going to be run in a Kubernetes cluster of some sort, and instead of having dev, stage, test, etc., we're obviously going to have dev environments, right? We need somewhere to do some of the dirty work and get stuff working. But if there's a major new version of the services that we are running, or if, for instance, we want to do new versions of Kubernetes, etc., we want to do, instead of having two environments running, a stage and prod, and making sure that the stage is always up to date, and then pay twice for something which we don't need, we rather want to make set up that new cluster, do your application deployment, and obviously, again, since everything is GitOps, everything is going to be deployed in the same fashion all over and over again. We're going to do our testing, and then either do some sort of canary or just like straight over crossover deployment and promote that cluster to production. At that point, obviously, you can just delete the cluster that existed, because again, it's one of the great things about cloud native, and that's also one of the reasons why I'm thoroughly, like, I'm pushing forward for Crayon to be more cloud native, because these things make sense. Now we don't only have immutable infrastructure, but we also are now going to have immutable environments. And just with that, like, as a basis, it just makes so much more sense. It makes sense at a cost level, because if we don't have to run a exactly like production environment that we are only using to do small changes to make sure that stuff isn't broken, if you don't need that, that's half the cost, and it's not only half the cost, like, for us, like, money wise, but obviously it's a less cost for both the environment and the pressure from on the cloud vendors to have stuff up and running. So it's better not to use as many servers, obviously. So basically, this went a little bit more faster than I thought. I think my voice kind of like slipped into gear. So I just want to end with a thank you. Here are some links. If you want to talk more specifically about platform engineering, cloud native, even DevOps and infrastructure as code or GitOps, feel free to reach out to me. And like I said, we will be hiring platform engineers, so that's always a good thing. Do we have any questions on this?
Thank you so much. It's really great to have you on both days. There is obviously a little bit of the delay for it to reach YouTube, so we'll just see if anybody has questions as your talk is wrapping up.
I am also in the Slack, so if people want to reach out, you can do it there as well.
Absolutely. Oh yeah, and when I meant YouTube, I meant the stream is delayed, but in the YouTube chat, we have reminded people, and I just posted right now, to ask your questions in Slack because yes, many of the speakers will continue to monitor the Slack or will alert the speakers about questions. So, if you're registered and you got the link, we have the stream open. So if you're watching this a couple days later or whatever, or actually I forgot to mention earlier, for accessibility reasons, we choose YouTube streaming so that I know we have short breaks, but if anybody wants to just pause and has to go to a meeting or needs more time, we want to provide that flexibility. So if you're catching this even 30 minutes later or a couple hours later, Slack is the best place to ask your questions so that we can monitor them. So one person asked, have you looked at Crossplane instead of Terraform controller? Great question.
Yes. So obviously Crossplane is a really good way of doing things, and it's more Kubernetes specific, because that's its venue. And Terraform is not. But the reason why we're going with Terraform is just that we are a Terraform first company. We are creating a lot of we're doing AWS landing zones design there. We're going to do a lot of accelerated kits for customers, and everything is going to be Terraform. And it just makes more sense as a company to kind of have that one approach rather than us then splitting off again and doing Crossplane. Crossplane is excellent and is really good, and it's very, very easy to get into that GitOps operating model. But again, since we have the TF controller now, it's just as easy just to have what we already are using and can reuse that, but in a GitOps manner.
Yeah. And I will take this opportunity to plug two things. One plug is, yes, as mentioned, the Terraform controller, and we are soft mentioning that it works with Terraform Cloud and Terraform Enterprise. Our team has been working with that, and we'll have a full official launch about much more of what's going on there a couple months from now. But yes, officially it works on those. And then on the Crossplane side, plug here. So my time, Pacific time, 11:50. We are very happy to have Victor Farsick from Upbound, who will be talking about Flux working with Crossplane. So yes, many, many options, and we are excited about all of them.
It's one of those things, like I said, one size doesn't fit all. It never does. And there's a lot of reasons to consider many of these tools. We're just lucky that basically all these different tools, for some reason, all seem to work really good. So we're in a good spot in our ecosystem. So it's really good.
Absolutely. And then we have, I guess, just a comment. Really helpful. Thank you again. People saying, thanks for sharing your journey. You not just shared what you're doing, but how things, what the next steps are. And I think that's really important for people to think about what they're doing. And then also clues on what's critical. So thank you for that as well.
There's a lot of things to talk about in a short amount of time. I could probably have a 2-hour seminar about these things. But yes, there's a lot of these things that I see or have seen at a lot of customers, all these types of trying to continue to have continuous improvement when you're kind of stuck in that old type of structure is really hard. And unfortunately, the only good way to deal with that is to start breaking it up. Like I said, I could probably talk for hours about that topic alone and without mentioning any technical things.
Yes, and we'll keep that in mind for future things that we want to do. What's the difference? What's the difference between a platform engineering squad, which is hybrid, versus the DevSecOps squad, which is CI/CD with security by design mindset? Platform engineering sounds to me like old ops squad.
So the way that I see it is that platform engineering is kind of the new term of umbrella term. So what would be kind of like a cloud platform mixed with SRE, mixed with et cetera, et cetera, et cetera. All of these things are part of the act of platform engineering. So you could have a specific DevSecOps team if you want to call it that. I wouldn't use DevOps as a team name, but so I would see cloud engineering or something like that. But it would all fit into the umbrella term of platform engineering in the way that I see it. So it's really just it's one of the things we kind of have to deal with in our line of work. Things change and things get new names, even though it's kind of the same. I think platform engineer or platform engineering as a term is something that's come up relatively recently, and it's I think it's a more like holistic like approach to what's now modern operations. So it could mean a lot of things depending on where you're at. Let's just say that.
Absolutely. So great. We are at time. We want to move on to our next speaker. So thank you so much, Robert. Thank you for your questions. And I still see people typing. So check it out and you'll be able to continue to chat with Robert. So thank you so much. Vanessa and I will introduce more speakers coming up. And on a quick note, Robert brings up a good topic that this is still very dynamic. Your team names might change a little bit. I think Robert yesterday was presenting with Pinky, who said like at one point there's the delivery team was a name in a previous company. I don't know if they're called platform team now. And then plug, I'm really excited that in a couple of talks we'll be talking with Winnie from Safaricom. And Winnie was sharing all these stories about their shifts in names as well. And I kind of lost track. So I will be asking Winnie again. Could you remind me again what the team names are today? Because there's a lot of evolution. So our next speaker, Vanessa, would you like to introduce?
Yeah, so it's Marco Amador. He's next. He's from a company called Anova, right?
Yes.
I can't wait.
Hi there.
Hello, Marco.
Hi. Hi, Marco. You just appeared like a god, and we can't wait for your talk.
Yes.
Okay,
Take it away.
Let me share my screen. Okay, so hello everyone. I'm Marco Amador.
Are you sharing your screen?
I'm trying to.
Okay. Just there you go. Yeah, just giving you confirmation. Yes, thanks.
Okay, so I was saying I'm the chapter lead for data and SRE at Anova. And Anova is the leading global provider for IoT to remotely monitor and manage assets. Anova is a 3-year-old company, but it's the result of the merger of 5 well-established companies. And with that, we suddenly have 5 different platforms, 5 different ways to build and release software. So we need to find a unified way to do that. And we created the platform that we are using for the whole company. It's called Unify. Unify has a pretty dope tech stack. We are running everything on Kubernetes, on Istio service mesh, and we are using a bunch of other tools for observability and so on. So when we were creating this unified platform for all of our projects and onboarding new customers, we had a few concerns when we were creating the platform. So about scalability, our platform would need to scale horizontally the cluster or the clusters themselves, and the workloads need to auto-scale accordingly to the load that we were getting. And another concern is that we need different geographies because we have customers from different continents that need their data segregated accordingly. And in multi-region as well, inside a geography, we have multiple regions, mostly for redundancy and data replication, for instance. In each of those clusters, we have, or in each of those regions, we have multiple environments as well. Production staging and sandbox for some experiments. And Again, we also need to have security in our minds, building the platform from scratch and to enforce the security policies that we wanted to have in place regarding infrastructure as code and workloads and that. Our platform would also need to be multi-tenant because we have multiple teams or products that we want them to have completely ownership on their releases. So we have multiple namespaces inside Kubernetes for multiple what we call tenants. A tenant can be a product team or whatever. They have their own namespace where they can deploy whatever they want. For that, they will have GitOps, their own GitOps repositories, infrastructure as code repositories. They have complete ownership. And for the operations teams or the platform team, there's as well multiple namespaces that we need to manage somehow. And to manage all of this, we decide to go with GitOps. That probably you already heard of, or we wouldn't be here. So it's a way to declare our desired states through manifests, YAML manifests inside some Git repositories. So we decided to go with Flux. Firstly with Flux v1, and about a year ago we started using Flux v2. So Flux has multiple controllers, each with its own responsibility. The source controller manages the Git sources or the Elm sources, basically synchronizes our Git repositories, and the customize controller, which customize basically against those sources to render and apply those manifests in our Kubernetes clusters, and the Elm controller, which handles the Elm releases that we might have created inside our cluster and deploy the workloads themselves. So for that, as I told you before, we have multiple GitOps repositories. The one that we call main is for the platform team, where we define what environments and what regions do we have, and each of that region represents a Kubernetes cluster, and where we define everything in our tech stack, the Istio service mesh, our observability stack, everything is configured here. And most importantly, the tenants that we have, or our product teams. And each of that tenant, again, has its own GitOps repository where they can, again, reflect all of our clusters and environments and regions and declare or create their manifests for their services. So with so many regions and with so many environments, it would be very easy to create a lot of duplicated code. So we are using Elm releases or Elm, a templating tool that prevent us to repeat or create duplicated code as customize. Customize as the concept of overlays, like we can describe in a generic way what our workload or our service is, and then apply specific overlays with the small difference that each region and each environment has. So we prevent drift and duplicated code as well with customize. So you can see some demo repository that we have. It doesn't reflect 100% what we have in production, but it's a good start to look at it. I can show you a little bit. So we have our platform repository where we define our environments and regions that we have, and basically all the workloads that we have for operations, which can be the Istio service mesh and all the tools that we have in our observability stack, like Grafana, Loki, whatever. And then we have for each tenant their own repository as well. So in this case would be the tenant data, where as well they will have all the environment that we might want to have, the base where they can create all the what a Helm release is, and then the small difference for each region, and like the tag, the image tag or the image policy will be different in production that would be on staging. Okay, so how do we do continuous delivery? We use image automation, another pretty cool feature from Flux v2, which bring two additional controllers, the image reflector, which keeps fetching the image tags from any container registry that we have, and based on some CRDs from Flux, we have image policy where we define for each environment what kind of policy or what expression do we want to automatically update a workload. And if that image policy matches any tag that was fetched by image reflector, then image automation controller automatically updates our Git repository, and then we'll have a new version rolling out in our clusters. So this talk was about progressive delivery, and we are talking about continuous delivery. Why do you want to take or deliver things a little bit slower? Because a lot of things can go wrong when we just roll out a new image. We can be introducing regressions, we can be introducing errors, the integration text might not be as good as they should, and probably everything is okay, but the latency increased, and then our cellular will not comply. So for progressive delivery, we are using another tool from Flagger, from Weaveworks, sorry, Flagger, which has multiple deployment strategies, canary, A/B testing, and blue and green, and from which we are using mostly canary deployments. So the canary deployment principle is very simple. When we detect that we have a new version of our workload, we spin up a new container beside the one that it's already running and start progressively sending traffic to that container while monitoring the metrics to see if everything is okay or not according to our SLO for that specific service SLO. If everything is okay, we might increase the traffic to that canary until some kind of threshold. If everything is okay, the canary will be promoted to the primary, and then we have our new version completely roll out. Here it's a little bit more explicit. We start starting just a few amount of that traffic to the new version, and keep monitoring the metrics. If at the end everything is okay, the primary version will be replaced by the new image tag. So sometimes during this canary analysis, we might not have real traffic coming from outside, so we wouldn't have metrics to know if everything is okay or not, and then the canary wouldn't progress. So we can define during the canary analysis some traffic for the canary. For instance, we can use a tool called A, or even perform load testing with K6, for instance, where we define specific test case for that specific service that we want to test every time we release a new version. While that canary analysis is being performed, we have a lot of dashboards that we can monitor K6 metrics themselves and how the canary progressing is doing. We can see the latency, the network, and everything, or the resource consumption. So the canaries are ephemeral, meaning that they only last while the canary analysis is being performed. Sometimes we want to release a new completely version, which might be from a completely different architecture, and we just don't want to release that soon. So we are using as well dark launches to release a new version only to a specific set of users. And for that, we are using Istio virtual service feature called delegation, where we can have our workload as before with canaries and so on, but we create by side another primary deployment with its own canary and a new virtual service, and create a different virtual service that delegates the traffic to the dark launch if the request has a specific header, for instance. So in this case, if we have the users that are performing the requests have this specific header called side dark, the traffic would go or would be forwarded to these deployments with canary or not. And again, we could use K6 to generate traffic and create load tests and monitoring with Prometheus, for instance. At the end, we have this, or we would be able to test the new version, not if for a short period of time that would happen with the canary, but as long as we want. So I think I could show you a little demo about how this works. So let's say I have a cluster here, and let me see, I have a few pods. Sorry? Yeah. So I have a few pods here, and I have here a canary. Okay, and here I'm going to simulate some requests to this application. Right here, all the requests are coming from a container from a version 1.0.0. So if I push a new container or a new image tag for my container registry, let's say 1.1.0, the image reflector, if you remember, will fetch the new tag that I'll probably have already here. In my Docker registry, I have now two tags, 1.0.0, it's the one that is running, and 1.1.0 that I wanted to release progressively right now with a canary deployment. I can make things fast. Flux will do all of these automatically, but I can just make this a little bit faster if I reconcile myself. So here I'm trying to find or to fetch new tags. He already found 2 tags, and now I'll reconcile the image, update. So if is there any image policy that matches, it will push a new commit to my GitOp repository. So here, I guess that the canary is already progressing, still receiving 0% of traffic. So here we only see 111, but in a few seconds, it will start to forwarding new, okay, I have here the 110 that has a cow in the response. So right now, the canary analysis is being performance and analyzing the metrics, and we'll forward or we'll progress the amount of traffic to the canary as long everything goes well. Okay, 20%. Now we're going to see a lot of cows, increasing the amount. Okay. And I'm already making some requests here by side. No, not real. Okay, 30%, 40%. Usually takes longer, but for the demonstration, I create the interval pretty slow, pretty small. So when it reaches 50%, the canary will be promoted to primary, and all or 100% of the requests will be already receiving from the new version. Okay, 50%. Okay, and now the canary is promoting to the primary. So all of the requests will be now the new version. So I think I could also demonstrate, if I have a few minutes, the dark launches. So I'll just push my new completely new version, let's say, to one, I can be to 0, which will not be available in the normal requests. And I will need to activate, sorry, the dark launches. Okay, not here, not production, staging, not here of, okay. I'm going to activate dark launches with a new image policy that will fetch the new tag starting with 2. Okay, and okay, so now I'm going to have to just reconcile the source, just to make things faster. And here I'm going to make the request for the small set of users that know that there's the header that accesses the dark launches. So it's side dark. Right now it's not in place yet, but when okay, here is already starting the new dark launcher, and both of these windows are using the same request, but this is now accessing the dark launch instead of using the normal, which has here a little dark cow. Okay, and as well, I can just trigger canaries for the dark, the same as the main version. Okay, so this is how we are doing canary deployments and dark launches. Okay, we still have a few challenges to solve in our cloud native journey, like unified observability, because we have a bunch of environments and regions, and we have different observability stack URLs. And that was it. Thank you very much.
Thank you, Marco. That was great. I'm just
Thank
going to
you.
check and see if we had any questions. I loved all the images. What a well
Thank
done
you.
presentation. I think we don't have
For my
any questions.
time.
Yeah, for your time. Thank you so much. I think some of the questions will be in the Slack channel. Guys, if you have
Okay.
any questions you need to answer, Marco will be there for like a couple of minutes, or will you have
Sure,
some time
sure.
to answer questions? Thank you so much.
Thank you. Bye-bye.
Take care. Bye. Great, guys. Guys, if you're enjoying it, please let us know in the Slack channel. Let us know on Twitter as well. I wonder where Tamao is. Is there music going
No, I was waiting for
on?
you to introduce me
And there's Tamao.
because I'm technically a speaker with our next guest. We'll be in a fireside chat.
Yes, you do. I'm looking forward to this one. The five-a-side chat with Winnie Gakuru, right?
Yes, Winnie,
Oh,
can you join us? Hello.
hi.
Hello, hi.
So
So
nice
great,
to meet you.
so
Nice
great
to
to
meet
see you again.
Well,
And
I
we're
like.
yes, we're so excited to hear your story about Safaricom. I know you kind of have a presentation. Do you want to kick off with that first?
Yes, I'll start by sharing the journey. I decided to choose something unique, not to have any presentation in terms of a slide or maybe a demo, but just to give an overview of how the experience it has been for me and even the company.
Okay, awesome. And yeah, I did prepare like a bracketed slide that I can share later if that helps to guide the Q&A part. So I will be in the background and I'll rejoin when you're done. Thanks.
Okay, so I can proceed. Okay, so hi, my name is Winnie Gakuru from Nairobi, Kenya. I am a DevSecOps engineer too at Safaricom PLC. And today I'll be sharing my experience and journey using GitOps for continuous delivery within Safaricom PLC. Of course, while using OpenShift and AWS AKS clusters. I am a software engineer, bachelor holder, graduated a few years back with aspiration to further my studies in a few years to come. I have been privileged to work for various companies, and most of them were startups. And I would like to mention one particular fintech company that actually exposed me to various market demanding skill sets and other exposure. And that actually inspired me to kickstart my journey towards DevOps. Safaricom PLC is the leading telecommunication company in Kenya and has already extended its roots across East African communities. And Safaricom PLC has a vast number of products and services that are heavily consumed by the targeted market. We have been in operation for more than 20 years now, and recently just transitioned into a technology company, which is popularly known as a tech company. Well, flashback, while we were still a telecommunication company, we were big consumers of third parties or vendors software services. But with the potential, the vision we had as a company, we began the journey to transition into a technology company. And amongst other reasons, one was to also promote and utilize local talents like me. This technically meant that we will have to do most of our software in-house as opposed to paying for them. And culture like DevOps, Agile adoption were among the pillars that could gear and drive the transition. Well, whenever I mention or anyone mentions the term DevOps, the first thing that usually storm in people's mind is usual pipelines. Well, we all know that it is DevOps, it's more than just pipelines. And like in my team that I work with, we have various thematics or sections, GitOps being one of them. And actually the reason why we are here, we also have things like security, we have tooling, licensing, just to mention but a few. And today being a GitOps day, let me focus on GitOps within Safaricom and how we practicing it. So for you to practice GitOps, or how we really approached it, in this case with pipelines or continuous delivery, then you must know continuous integration and continuous deployment. Well, don't worry about the cool words. Those are some of the cool words that rose up while DevOps rose up also. So, but in a layman's language, CI/CD, as per their popular abbreviations, is basically how you automatically ship your code from your local machine to the intended server. It could be a UAT environment, staging, security, or even a production environment. So the basic workflow in achieving this will be you just have a source code. In this case, it could be Git or maybe GitLab, GitHub, depending on the provider you will choose. Then you need to have a CI tool. It could be Jenkins, it could be GitLab CI, it could be Travis. Again, depending with the tool of your choice to perform for you. The third thing you'll need, it will be a Kubernetes orchestrator. So we have various providers also, OpenShift, Vanilla, EKS. For me today, I'll focus on OpenShift and EKS. So it's worth mentioning that us back at Safaricom, we give priority to open source projects within the team. And the reasons for this actually extends to the benefits that we get from using the open source projects. And when doing continuous integration, abbreviated CI, either using GitLab or Jenkins, we must integrate security tools like Veracode, SonarQube, just basically to do the SCA, Dust, and even SAST scans. We also have Ancha or maybe Anchor, depending on how you pronounce it, that will assist actually to do even image scanning, among other integrations that will integrate with our CI pipeline. So for us, shifting security to the left by doing the tests and scans as early as at development stage is key. And this means we have enabled and even encouraged our developers to integrate these third-party tools with their day-to-day IDEs. Well, of course, the main IDE is VS Code. And then again, we want to achieve end-to-end automation. So integrating these tools with our pipelines helps us to achieve that goal. Well, without any assumption, let me mention that we do cloud-native applications that runs in Kubernetes orchestrators. That means we use microservice principles and guidelines, which are popularly known as the 12-factor principles when doing software development. Well, I hope now you can see the process and how they are actually related to each other. Well, back to our goal of doing end-to-end automation, there was need for us to practice or adopt GitOps. Well, GitOps is just a way of implementing deployment for cloud-native application, and it focuses on a developer-centric experience when operating infrastructure by using tools that are already familiar with the developers. These tools like Git and other continuous deployment tools. We can all appreciate that DevOps has a variety of tools encapsulated towards it. Yeah, when we identified Flux, which is an open source software to fill in the gap, and we started with Flux version 1 as most or almost everyone did, which quite gave us good service. And with Flux, this is generally what happens. You just follow their official documentation on installation, you do the setup and bootstrap your cluster. Then Flux will deploy its operator. In the case of Flux version 2, it's known as GitOps toolkits. So these GitOps toolkits will work together and automate deployments for you. Just imagine just declaratively defining the state and requirement of your services. This, which is also known as Kubernetes manifest, and commit it to a Git repo. And you don't have to worry how it will be deployed. So this actually improves governance because you will be able to know when and who made a change and what change it was, which actually it will make it even possible to do a rollback or maybe mitigate in case there was an issue. It also reduces the manual hours spent maybe to deploy a particular service or maybe deployment. Flux leverages on Kubernetes API, and it makes it easier for you to enforce things like cluster policies, secret management, multi-tenants, and many other things. Multi-tenancy setup was prudent for us since we have various teams with different requirements and policies, but also we work with vendors who would like to manage their resources in an encapsulated manner. Thus, we required tenant isolation. I know there has been several hands-on demo on how to set up Flux on various clusters, but just in case you need any guidance, I will also be happy to help. Well, as a DevOps team, the company, we are happy to say that Flux has played a very important role for us towards achieving end-to-end automation. And these goals and tools helps our engineers to focus on key areas within their crafts and on innovation. I'm thrilled and proud to mention one of our products that usually attracts a lot of innovation from our engineers. This product, known as M-Pesa, is a mobile money service that enables our customers to send money both locally and internationally. With the development of a mobile app for the product, it has made it easy for innovations around it to be embedded on it. This has accelerated. This was accelerated through the automation and use of tools like Flux. So automation allows new features to be tested, deployed, and even delivered to the customer faster and frequently. So this gives us a competitive advantage over our competitors. We want to scale, increase in terms of velocity, release faster, but also release market-ready product. As we usually do these automations and setups, it's usually important for us not to break anything in the process. Rather, we make the process more efficient and thus reducing the number of incidences within the IT department. Well, without digressing much, practicing GitOps with using Flux has been a very interesting journey for me and my fellow teammates. And with the introduction of Flux version 2, which we are currently and parallelly piloting, we see the potential of scaling up. There's security and policy enforcement, there's clear observability and even monitoring, amongst other benefits that we have already observed. So Flux ability of integrating with third-party open source tools like Kivano, Mozilla Source, and KubeConfirm helps us to set up secured pipelines that are not easily broken. So I am grateful and must appreciate the effort by the Weaveworks team on ensuring automatic cluster synchronization using Flux was possible. I would like also to appreciate Weaveworks again with the partnership with Terraform HashiCorp. Having a Flux provider for Terraform is a game changer for enterprises like Safaricom PLC that does a lot of repetitive tasks. So this means you can now fully practice. We can now fully practice GitOps on both pipelines and even through ISC, that is infrastructure as code. So this works well for us towards achieving tool standardization, since we are already using Terraform for our infrastructure provisioning. Well, of course, there are usually challenges encountered in every journey, but be it complex documentation, poor infrastructure, lack of capital, language barrier. Yeah, I'm laughing because most of the above mentioned points were generic reasons as to why our ancient forefather could not do most of the industrialization. Well, it's hilarious, but it's very sad at the same time. Well, one of the challenge I faced was at first the concept of GitOps was not as easy as Stefan and my boss usually portrays it. It gets more complicated when you are explaining it to someone who is hearing it for the first time. There are so many underlying concepts that are necessary and act as building blocks for GitOps. But frequent practice and trainings make it easier with time. And after several demos, trainings, I'm improving on how to simplify my demos and trainings that can be easily understood, well, even to a 2-year-old person. Secondly, people usually believe by seeing. My first encounter with Flux was purely through command line, popularly known as CLI. You must be familiar working with the CLI tools and basic understanding of Linux commands. But if you have been practicing Kubernetes and using kubectl commands, nothing much changes. So, but if you're a strong believer of believing by seeing, well, Weaveworks also has a Flux UI version for that. But for us, we have maintained on the CLI version. Well, I may not give the actual statistics or numbers in terms of the software releases within the company, but I can mention that since we adopted the automated deployment or the end-to-end automation, our numbers in terms of the releases has been up. The graph has been growing up with time, and also the number of incidences has reduced. And we really appreciate the effort that Flux is really playing within the organization and on a personal level. So I would like to stop there because clearly I can go on and on speaking on the GitOps journey, but for the sake of time and reaction for the audience, I'll stop here and allow reaction and question from the audience. Thank you.
Absolutely. And thanks for joining us for sort of this hybrid talk and fireside chat. So I will share my slide just as a guide for us to chat a little bit. And I will repeat a little bit because your talk was just so rich with so many things. I kind of just want to go in and highlight, and it really highlighted so many things that we've already been kind of talking with the other Flux users yesterday and today. So again, I really appreciate your willingness and your company's willingness to share what a unique transformation that you talked about Safaricom, right? And how technologically interesting it is that, you know, you're shifting from, as you shared, sort of more of a mobile company to a technology company, and how serious your team is about taking on these technologies and really moving forward. So it's such a great use case, and I will be also monitoring questions because I'm sure people really appreciate sort of the concrete way in which you were talking about it. So I do have one basic question, because we chatted a couple weeks ago, and the topic came up with the earlier teams or the earlier speakers, is that you know, the team names, right? The team names might change or mutate because it's very modern, right? It's very evolving. You know, people are saying, well, is it a platform team? Is it a delivery team? Is it, you know, and I think with you, I'll be honest, I got a little bit confused because you talked about DevOps teams and DevSecOps teams, and maybe there was some evolution and there's like one is inside the other or side by side. And it may change, right? So I was curious again, you say DevSecOps, but could you clarify again, like who's servicing whom for what, and how do things work together?
Yes. I think these are among the cool names that come every day, but the key and underlying thing is the KPI, like what's the goal that the team wants to achieve. So if I want to identify myself as DevOps or platform or whichever the cool name I want to identify myself with, the key thing at the end, are we really serving the goal? And one of the goal within DevOps or DevSecOps, of course, there's that aspect of security, which has proven to be very costly for most of the companies if well ignored. But on top of it, we want to automate. I can say the other key thing is doing that automation. Remove the aspect of manual deployments, manual setup of servers and all that. So in my team, we started as identifying ourselves as DevOps, but then we thought security is very key for us. Let's identify ourselves as DevSecOps.
I see. Yeah, that makes sense. You know, as you talked about, and I say priority 1, 2, and 3, but I'm kind of listing here. I'm sure maybe from week to week the priority might change. Obviously, security is the top one. So I really loved how you shared. First of all, in the case of Flux, right? You said leveraging the Kubernetes API, which I think will be dear to many of the maintainers because they have made that commitment, and to have you then reaffirm, right, that not only helped with, you know, having the cluster policies, secret policies, and all that, but also being connected to the multi-tenancy that's so important to your business, right? It's great to hear that, as you were sharing, you have a very concrete request from your vendors that they need multi-tenancy. So it's great that Flux can do that, and to see how you're using it. So I was also taking some notes. It was really exciting. You're talking about your app that is built for sending money, and how leveraging the GitOps practices has really helped you to be competitive, primarily in the area of velocity. And I was wondering if you could share a little bit more, like, you know, how were things before? How much more they improved, and then what are your thoughts, like what's in process to continue to improve velocity? And as you share, it's a crucial part of your being able to be competitive, to release faster.
Yes, yes. So I hope I'll operate within my allowed jurisdiction.
Yes, yeah, yeah. Don't share anything private.
And confidential, of course.
Yes.
Yeah. So we have this one product. We call it M-Pesa. M for mobile money, and Pesa actually is a Swahili word for pesa. So that is one of a product that Safaricom is usually proud of, that we currently have. So before actually we shifted to DevOps and even the agile and automation things were more of manual. So before a change, and you can imagine, before a change could be done, there's a lot of manual, and there's that aspect of time wastage. And with such setup, it always discourages innovation. So one of the things that when we compare then and now, it's in terms of, actually the key thing is in terms of innovation, the end goal or the end benefit, it has been on the innovation. So currently, developers are being given that exposure, and they can now be able to come up with ideas, and within weeks or even months, that idea can be live. And of course, with the automation and security in place and everything in place, we are sure whatever we are delivering, it's of standard and it's bringing value to the community. So in terms of velocity, you realize again, manual wastes a lot of time. So when it's automated, you deploy faster and frequently.
Fantastic. Thank you so much for your time. And it was really great. I think we met because you were actively in our Slack channel asking questions about Flux, and we've been reaching out to community members. And you know, it was really great to see people like you very actively and hopefully getting all the help that you need. And I really appreciate your taking the time to share your story. So it was so great meeting you. I hope we'll chat again. And thank you so much.
Thank you. Thank you also.
Thanks for
Great
joining
to be
us.
here.
Yes, thanks for joining us a bit late as well. All right, so we are on time to be introducing our next speakers, and I think Vanessa is going to join me, I think, or should I just introduce Hello.
Hi. I like popping up.
Yes.
No, go for it. Introduce.
Well, I got the timing wrong for a second because I was like, okay, I need Vanessa here to pronounce those French names, but then I realized, oh wait, no, right, we got
No,
Josh.
it's Josh next.
Yes, we can pronounce. I should have started taking French classes. Cool. All right. Well, we've got Josh, who mentioned several times from OSO.sh, correct? And hello, hey, good to see you. Were you able to chat at KubeCon EU? I can't remember. Or you were online? That's right.
No.
Yes. So hopefully we'll meet at future events and KubeCons as well. But thanks for joining us for GitOps Days. And you are one of the many users who actually we need to thank you. We had many users step forward to be added to the list of people who are happy to testify to the TOC in the CNCF. You know, we put it in our application because Flux is very close to graduating in the CNCF. We've just a final few steps. But a key part of that was people coming forward and saying, yes, I would love to share how I use Flux. And so thank you so much to Josh and the many others who've been on the list. And I think that process is actually coming up maybe just around the corner. I think they'll
nice.
start reaching out to people. So you may get a call. So with that, thank you so much. And we look forward to your talk.
Oh, amazing. Thank you for having me. I'll just share my screen.
Yes.
Brilliant. So we're all good. Oh, there we go. There's a good start. So yeah, thank you for having me. It's great. So today I'm going to be talking about the key learnings that we went through for migrating from Flux 1 to Flux 2. A bit of an introduction before we get going. I'm Josh. I'm a DevOps engineer at OSO. We manage infrastructure and create infrastructure for clients. And earlier this year, we migrated our clusters from Flux 1 to Flux 2. And today, I'm going to go through the process of what we discovered and of what we set up, etc. So just before I get into the crux of it, I'll give you a bit of explanation on the agenda. So I'll start off with discovery, then move on to design and reflection. On discovery, I'll give a bit of a background and we'll get to know a bit about Flux 2, and I'll talk about how we built out a solution and the processes we went through that. Then I'll talk about our design, how we now manage client clusters centrally, what upgrade process we use to move our clients from Flux 1 to Flux 2 and ourselves internally, and of course the cut-off process involved. And then I'll finish on reflection, so what we learned along the way and ideas for the future improvement really. So I'll move on to the discovery. So before we can really get into it, I'll give you a bit of background. So previously, as you could guess from the title, we had Flux 1. And with that support coming to the end back in the day, it really did give, we were hoping, and it did, bring an opportunity for us to benefit from the toolkit it provides. The toolkit I'll go into a bit more detail in the later slides. And the opportunity we're really hoping for was that it would allow us to scale, allow us to update our infrastructure more easily. And really, we're hoping that that we now know, it would give us an organized and repeatable structure. So if you look on the right-hand side, previously what we had, well, when we're managing clients, of course, with Flux 1, for anyone that hasn't actually used Flux, I should mention it very quickly. So Flux offers continuous delivery. So it helps automate the deployments of containers and your infrastructure in the cluster. So, for example, if you make a change to your commit on your Git repository, for example, or your version control, and you push that up, Flux as the tool that can automate those changes to be applied to the cluster. So there's a little bit of a background if people haven't used Flux before, so I don't want to just assume, but I'll get back to it now. So previously we had a cluster, a repository per cluster, which is okay to begin with, but as it scaled and there's more and more clients to manage, it did become difficult. It did become difficult to manage, and there wasn't much repeatability there at all, really. So if we bought a new client and there's some similar, say, infrastructure to a previous client, we couldn't benefit from that existing infrastructure as such. We had to sort of copy and paste it over, and when updates needed to happen, it became difficult. We had essentially a list of the repositories, the code in there, and it wasn't particularly amazing. Still great with the automation side, but the app and infrastructure code was cut into one. So really, the approach we wanted, you can see on the right-hand side, is we really wanted to take benefit of what Flux 2 offers, where you can have multiple repositories per cluster. So that was the goal we wanted to achieve. But to be able to do that, we used our internal OSO discovery framework, discovery and design framework. And I go into a little bit of detail about that now. It's a shortened down version for the talk because I've only got a limited amount of time. But just to go through quickly, generally we come up with a problem. We think of a definition for that. So we generally come up with a list of questions, for example. We then think of the solution for that. So we go for a discovery phase. We determine if it's a valid concept or not, and then we implement. But we always take an iterative approach. So there's some steps in the bottom left. We, as I said, normally gather requirements. So the toolkit I'll come into a bit later. We, of course, of that needed to learn a bit about the toolkit, then design phase of how we would implement it, refine it, etc., until we're finally happy with a solution. So it's a sort of very watered down version. So within our discovery of when we were doing it back in the day, we weren't very familiar with Flux 2. It was of course new. So one of the first things we wanted to discover were what the differences were, so we could compare them. So previously within Flux 1, there was a sync methodology, a sync command, a command, not a methodology. And when you, say for example, installed Flux 1 previously, you could set an interval that generally be 5 minutes, etc., and apply those changes and wait. But occasionally you wanted to force those changes, so you would use a sync command, so it wouldn't wait, and you would force them yourself in the CLI. And when you're adding new infrastructure, so on a test and staging environment, it does happen occasionally. You're introducing it, your manifest might be slightly wrong, might have an indentation wrong somewhere, etc., and it wouldn't apply to the cluster. So we'd have to go into the cluster, look at the Flux logs, tell them, and check the process, and then go back, which is okay, but you've got an extra step with that. With Flux 2, they've introduced something called reconcile, which is great, really good actually. And the great benefit of that gives you instant feedback. So when we're applying, say for instance, a new harm chat, a certificate manager, for example, that manages certificate for domains, and we've got an indentation wrong, so the YAML definition's wrong, it will tell us straight away on the CLI, which is great. So we say customization. I'll talk about what customization is in a bit as well. It would say something wrong, indentation wrong on line 4, and that feedback would be instant. So you could go fix it. So you no longer have to go into the cluster, into the pod, into the logs and tell, which is great. And of course, within Flux 1, mentioned it earlier, you can have 1 repo per cluster, and it did make it difficult to scale and manage. We found from a certain size, but now you can have multiple Git sources, so that's multiple repositories per cluster, which is great. And you specify a path. So what do I mean by that? So when you install Flux, there's a command called Flux Bootstrap. I don't really have enough time to go into too much detail now, but their documentation is great on it. You would use Flux Bootstrap to install your Git source, so that could be infrastructure repository. You then specify a path. So it could be staging / clusters / client 1, for example. Cluster / staging / client 1, that would be a better order. And then when anything that's applied inside of client 1, those changes would be applied by Flux. So it uses the path to add a context. You can only have 1 context per cluster. And then if you wanted to add another repository for an app repository, you would add a Git source and specify a new path, which could be staging client 1 application, for example. Probably not the best directed examples, but hopefully you get the idea. We can add an infrastructure repository and an app repository, specify different paths for each. So when we update the Git repository, we'll apply it only to that. And previously with Flux 1, you couldn't suspend the sync. And occasionally we have stakeholders that want to update an application environment variable, for example, and they don't want that automated. They want to have the control to do that. So what we had to do was a bit of workaround. We had to set the interval to, like, say, a year, so it wouldn't automatically apply it every 5 minutes. And the client then in the evening, or when suits them, would apply it manually, be happy and check it, etc. But the problem with that, it meant if we needed to make infrastructure changes around the same time, we would have to force the sync as well, because we set the interval to such a large amount, which loses the automation side, isn't it? The whole GitOps principle, the flow. We're having to provide it sort of messed up the whole process. Where now you can, with reconcile, which is now called, you can suspend them, and you can do that across multiple sources, which is great. So say, for example, the client wanted to update an environment variable in an app. We could suspend it specifically for their app. They could then apply that when they needed to, and we can do infrastructure changes. And Flux would, automate, keep the automation side of that, which is really, really good. Patch management wasn't available, so patch management gives you more control. So within that, you could have a pod, and then we could patch, say, for example, increase the CPU and memory of it, which is great. So quick example I'll leave that, just remember that patch management. I'll go into an example when I talk about the toolkit in a minute. Image automation used to be an annotation per pod, where now, so you do your manifest and you specify an annotation, where now it's changed to image repositories and policy. So you could have multiple repositories, so from your container registry, and then the policy would essentially say, this is a semvar 1.0, etc. If anything changes, within our container registry with this semvar, i.e. this policy, update our image. And what's really good about the image repository is actually it tells you all the tags and all the repositories you've got available, which is really useful for debugging and really homing in if it's going to get the right image or if it's got the right image, because it tells you what repositories it's grabbed and what tags are available, which is really, really good. And there's a lot of flexibility now. So compared to Flux 1, Flux 1 was a bit of a monolith, which is, hopefully I'm saying this right now, which I imagine would have been more difficult for the maintainers to maintain because it's so large and invite people to do it. Where now it's been broken up into the GitOps toolkit. So really in a nutshell, Flux 2 we discovered, there's more differences, but we thought these are the most notable and were interesting to us to make a decision to continue to move to Flux 2. It enables more control of the infrastructure and processes. So now I'll just briefly go into the GitOps toolkit. The documentation here, I've never mentioned it, and people do mention it, but it is really good, and I'd recommend checking it out if you haven't seen the GitOps toolkit, because I've only got time to briefly go through it. So what it offers is these essentially 5 components, essentially. A source controller. So as you could imagine, it provides Git sources and manages and validates those repositories. So this will actually pull down when you do the Flux bootstrap or the Git to add a source, another repository, it will actually clone the application for you and validate and make sure that's okay, etc. But it'll clone it, and the source controller will be responsible for that. So I mentioned earlier about the patches where you could increase them, which is great because we have a client that had a very large repository and the source controller timed out essentially, wasn't able to pull the repository down. So we added a patch to the source controller and upgraded the CPU and memory. And then it had enough resource and was able to pull down the repository. So that was really good. Where before it would have been a bit more of a difficult situation, which we was able to fix. Customized controller is responsible for configuration of manifests, patches, of course, overlays. I'll come into overlays at the end of the presentation, which is something we want to use more of. And obviously responsible for the reconcile, making you customize objects, so i.e. your if it's to let you know if something's been fetched successfully from your repositories, etc. There's a Helm controller, of course, manages and installs Helm upgrades. Notification controller, so real-time feedback, incoming and outgoing from the cluster. So for example, you can get it to tell you if it's successful or unsuccessful deployments via Slack. And now there's an image reflector and automation controller. That goes back to how the image automations change. So these essentially are responsible for the authentication and the automation side of pulling images down. So when you have new images on your container registries, pulling them down, making the commits to the manifests, etc. So it's really useful. And the good thing about the toolkits is you can decide what components you use. So say, for example, we have a client that didn't want Helm, we could just leave out the Helm controller, which is great. So you're quite flexible. And if we had a client that didn't need the automation side for whatever reason, we could just not include those components. So it's really nice how you can be granular with it, which is really nice. So within that, just before I go into the design phase, what we really liked was the flexibility, the scaling options Flux offered, and we're happy to move then to the design phase, which was coming up with a repository that could manage multiple client clusters, which is great. So to do this, I'm just moving my Zoom icon because it's just gone in the way. There we go. So just before I touch on how we did this, you notice earlier we used the OSO, our design methodologies, a set of questions. We had many, but these are the multiple ones we came up with back in the day. So what we wanted to discover was how could we manage multiple clusters from one repo? How can we retain independent app repo access per client? So how can the client own that? How can we use it? Can we use our existing monitoring permissions? And how can we migrate with zero downtime? Those are questions we wanted to answer. So what we ended up coming up with, we took influence from the multi-tenancy back in the day, which we really liked, but didn't quite offer what we needed, but we definitely like the concept. So within that concept, the multi-client multi-tenancy, you would have a single cluster where multiple teams could have their own namespace and be responsible for their own infrastructure. But what we needed was one repository to manage multiple client clusters. So what we came up with, if you can see on the right hand side in purple, also, we have a demo essentially directory attached to a cluster, and any Helm chart configurations that our clients have or new clients have, we add there. And the reason for that is, if we need to make updates to a client's Helm chart for whatever reason, say for instance car main staging, I could refer back to Cert Manager because I think it's a nice easy example, and we need to upgrade their version, we could check it in our own cluster first, validate it's okay, etc., then put a pull request then for client A, for example, change the version, check with the client, and we could merge that in for the changes to be applied. We really liked how that potential, that solution there would, give us safe as such, and being able to do it within one repository. And then if we could repeat the process, then for example, client C, they needed to update the same Helm chart for them, they could confirm it. We can merge that in. And people could be happy. And then when new clients come on board, etc., we can put them within this repository, etc., and just create a directory for them. So in a nutshell, when a client comes on board, we'd create a directory specific for them for the production stage environment, install Flux with Flux Bootstrap, install that, set the path, and then add a Git source separately. So the great thing we really like about the app repos that you could have now our infrastructure, which is managed here, as you can see, and then the app side, which is a separate repository which we'll create for the client, where they can manage specifically their app code. And really, to us, that helps improve security as well, because we give access to those that really need it. So, for example, the client or the developer etc., needs to update environment available in application. They could do that in the app repository, do the pull request, get it merged in, and it's all happy. They don't need to see the infrastructure. So back previously, we did have some issues where an engineer would make a pull request to change some app code, but for some reason put a pull request to change some infrastructure, which obviously we didn't want, and it was tricky. Where now they don't even need to worry about that, don't need to see it, so we really like the concept. So that's what we ended up going with. Lovely, thank you. Almost finished. Yeah, thank you. And then we managed now. Yeah, we decided that we could use Datadog to manage clusters. We could still use our rollback and, of course, notification controller. And the way we came to migrate with zero downtime is we came up with a few approaches. We set up a fresh cluster of Flux 1 and 2, and a separate cluster with Flux 2 installed. And ultimately, we came up with the migration approach. I'll speed this up now because I've got quickly, because I'm probably coming towards the end of my time. The migration approach we ended up coming up with the clients was creating a separate cluster with Flux 2 installed, migrating all of the manifests and applications over there. The clients could do the regression tests on the separate cluster, make sure it's okay, etc., whilst leaving the production cluster as it is. And then when the clients were happy, we just did a DNS switch over to the cluster of Flux 2 installed, and just left the old cluster idle for how long the client needed it for. So the process was nice and smooth. So quick reflections in summary, we can get instant feedback on deployments now. Multiple Git sources helps us a lot. Upgrading Flux 1 and Flux 2 in a production environment, does carry risk of downtime. We recommend a separate cluster. Flux 2, fresh installation, doing your regression and your testing, allowing the client to be in control, and also ourselves for our own stuff, etc. And I'll quickly go on to looking forward. So what we want to do is create a pull request, so within the ecosystem, it does move very quickly. So for example, I upgraded a client yesterday to Flux 0.30, and about 2 o'clock, Stefan posted on the community that 3.1 was available. So it moves quickly I manually have to change that. We want to create a pull request that looks for those changes and creates a PR for us to automate that. And just a quick one on overlays to finish off. At the moment, we have Helm chats duplicated. With an overlay, you can have one, say for example, Helm chat, say the cert manager, in a directory called bases, and then in client A staging, you could refer to that cert manager base, just reference it. And with overlay, we could just change the namespace. So we can take, and then client B could just reference that as well. So what we can end up with is when we need to update versions, updated in one place, and with the overlays on the different client directories, which is great, we could just merge, change it in one place. But at the moment, we have to do a pull request on each one, but it's tricky because we might have client A and client B, for example, may want to have the updates added in different times. So we're still working that out, but we would like to take influence of overlays more. And that is me. So I had to rush the end slightly because I'm just conscious of the time. But yeah, really, that's our learnings from migrating from Flux 1 to Flux 2. Thank you.
Hi, Josh. Thank you so much for that. Can you hear me?
Yeah. No, thank you.
Great.
I talked fast at the end. Sorry about the quick talking, but
No,
I've got
it's
I've got a
fine.
clock, and I was very conscious of yeah. Oh well.
No, loads
But
of
only
people were
human.
enjoying it. It's okay. Loads of people were in the chat there. I think if you go over to the Slack channel, you're going to realize that there's a lot of questions. We were seeing a lot on YouTube as well, that you were getting really good praise. So thank you so much.
Oh, lovely. There was more I'd like to say, but hey, yeah, we're human. We've got the time frames there. So no, I really appreciate allowing me to talk as well. And I love the work you guys are doing. Please keep it up. I'm
Oh,
sure you
and
will.
thank you so much for supporting us.
That's great. That's great. Shall I drop off now?
Yeah, go.
Yeah,
That's it. Go to Slack, answer some questions,
lovely
and
stuff.
have a
Thank
great
you.
day.
And you. Thank you very much.
Take care.
Brilliant.
Hi, guys. So I hope you enjoyed that talk. Like I said, interact in the Slack channel. Next, we have Laurent Grangeau and Ludovic Piot. I hope my French pronunciation is good. I'm trying.
Yeah, that's perfect. Thank you.
Oh, merci beaucoup. So, guys, ready to have a conversation? Are you guys ready?
Yeah, definitely.
Perfect.
Yeah.
Take it away.
Thank you.
Thank you.
So first and foremost, we would like to thank the organizers, of course, for giving us the opportunity to share this talk with the community. It's a pleasure. And this talk is a very compressed version of a 3-hour-long step-by-step hands-on workshop we used to perform in several conferences in France. And you'll get GitHub link, GitHub repo link at the end of this talk. Yes, thank you, Laurent. So here we are, Laurent Grangeau from Google, and myself, Ludovic Piot. I'm a contractor, and here are our tweet handle. You can go further. Yeah, thank you. So when it comes to deploying onto Kubernetes, ops teams might use the kubectl CLI or Helm deployment tool. And even if these tools are very simple to use, they come with several issues when you want to use them to deploy at scale. First, you don't have a consolidated traceability. Just the slide before, please, Laurent.
Yeah.
Yes, thank you. So you don't have any traceability throughout thousands of deployed resources and several clusters. You don't keep an history of the deployments you've done. Of course, you've got the variables log, but it's not so easy to drill down into them. And finally, you have security issues. You have to pass credentials to your tool. Either kubectl or the Helm tool, the Helm CLI tool, in order to connect this tool to the cluster. So you have to store this secret onto your laptop or into your CI/CD pipeline tool, and you have to. By the way, you have to establish a network connection between the computer holding your CLI tool and the API server. So in a nutshell, you can do better. Next slide, please. So here come GitOps. And when you may know how GitOps put the way to deploy upside down. You keep a single source of truth, which can be a Git repo. And since it comes with Git, you may leverage on every collaboration patterns that come with Git. So pull request, branches, tagging, and so on. And then the tool inside Kubernetes is going to watch this source of truth and detect any change. And the magic of the deployment will come with it. Next slide, please. What we do love with Flux is that it relies on the keep it stupid simple Unix pattern. So it mainly relies on what is the main power of Kubernetes, that is its reconciliation loop. It feeds Kubernetes with a desired state, with a resource desired state, and then it lets Kubernetes do what it masters the most, make the resources converge to their desired state. It also relies on customize and Helm. The customized features it relies on is used to consolidate the full tree of desired resources get from several files from the Git repository, from the source Git repository. And since Flux is mostly Kubernetes operators, watching external sources and so on, it works from inside the cluster, and then it is quite heavily secured by default as any Kubernetes resources. Can we switch to the next slide for the Flux architecture, please? Yeah, thank you. And so Flux, the first part of Flux architecture is its CLI that install Flux resources and that bootstrap the Flux configuration Git repo. So yes, Flux is configured through Flux, and yes, that's dog fooding. And then we have several operators. You've got the first one, the source controller, that watch Git sources from GitHub, GitLab, and so on, and even generic Git repo. And we have the Helm controller that will watch any Helm repo. And the last one is the one that leverage on customize to consolidate all the files detected by the source controller or by the Helm controller and the Helm charts manifest in order to consolidate these resources in a single Kubernetes resource tree.
Okay, so yes, thank you, Ludo. So Ludo already told you that it's a condensated version of what we are used to do at a 3-hour workshop. And for this workshop, we have 3 different personas. The first persona is the developer. So the developer deploy and iterate on their applications autonomously and in isolation. So they want to deploy only applications with either Customize or Helm. And they don't want to create or manipulate some Kubernetes YAML file. So it's really about applications. The second persona is operations, and operation standardize how teams are onboarded inside the cluster. And what we have found in different companies that we have worked with is generally they are not multiple clusters, they're not multiple small clusters, but they have big clusters with multi-tenancy available. And basically there's lots of different applications and different developers on this cluster, and one for production side and one for non-production side, with lots of environment like staging, deployment, development, integration, stuff like that. So operation wants to standardize how teams are being onboarded in the cluster. And of course, the third persona is security, and they want to secure as hard as possible the different tenants, so the different environment, and they want to integrate and propagate policies and authorization from a central place broadly to all the team. So we have 3 different personas. How do they collaborate? So developers have their own app code repo, and they're just doing some continuous integration, building images with the application inside the images. And then the operation teams have their own repo with shared config and best practices, of course, and they are all deploying application config or deploying application with Helm or Customize. And of course, it's being made through the Git this Git repo, and the security, of course, have their own repo for having like policies, for example, key value policies, or the other one is OPA, Open Policy Agent. So there are 3 different repos, and of course, all of that repo are Git based, and it's all the single source of truth. So how to bootstrap Flux? So for each slide, we have the persona at the top of the slide. So the first one is the operator. So the operator will create a new cluster to be able to have like multiple applications and multiple developers team. Sorry. So the first things to do is to bootstrap Flux. So we have a command line like Flux bootstrap with GitHub, and in this workshop we are creating from GitHub, and Flux will create the different YAML file, so GOTK components, GOTK sync, customization, and of course tenants from the repository, and apply them to the cluster. And then so here is the content of the file. So in the GOTK sync, we have like the source of truth from Flux system. In the GOTK sync, we have the customization files that Flux is based on to be able to install and upgrade automatically Flux, because it's only based on YAML file. And of course, we have the customization file that reference the GOTK components and GOTK sync. So I've already told you that, but in the cluster, we have different tenants, one for production, one for staging, and different namespaces. And of course, in these namespaces, we only want dev1 team or dev2 teams to be able to deploy the application, but not touching the other namespaces. So for example, dev1 team can only deploy on their own namespace, and dev2 team can only deploy on the dev2 teams, but not on the dev1 team. So we have to create the Holbach model, and to be able to, for the different developer teams to be able to deploy that application inside their own namespace. So we are creating the tenants here with Flux create customization tenants, and we create a tenants.yaml file that will have a Git repository, and we tell the Flux here to watch the path /tenants/staging inside the repo to have some modification. For example, if I want to create a new tenant in the staging space or a new tenant in the production space. And of course, that is done by the ops team. And then we create the tenant dev1 team. So we create with Flux create tenant dev1, and we tell Flux that it will live inside the dev1-ns namespace. So we have to have like a Holbach YAML file. So Flux create tenant will create this Holbach YAML file with the namespace dev1-ns, a service account dev1-ns also, and we apply a role binding with dev1 Flux dev1-full-access to be able for this service account to only deploy on that namespace. So with that, we have created the tenant dev1, and of course, each time we create a new file or modify a new file, we have some Git command line like git add YAML file, git commit, and git push to be able for Flux to apply this YAML file inside the cluster. So once we have created the dev1 tenant, we have to create the dev1-full-access that is not being created part of the Flux CLI. So we create that cluster-full-dev1.yaml file that creates the dev1 full access cluster role, sorry. And you see that we allow the use of every verbs from Kubernetes to be able to apply that inside your own namespace. So because we have like this namespace linked with this service account linked with this cluster role, so we will see that the dev1 team can only deploy the application inside of the namespace. And of course, for the dev1 team, we are creating the application with customize. Sorry. So we have to create a new source control based on the dev repository where lies the application. So for this, we are creating the Flux create source, and we indicate that the URL of the GitHub repo is github.com/1kubernetes/dev1 as Piot application. So it's a little application based on Pokemon. So we are deploying the first application based on as Piot, and we are creating a sync YAML file inside the path /tenants/base/dev1/sync, and this path is based on what customize are using. Let's say the base of the dev1 team, and of course we will in the future could deploy a patch, so patch 1, patch 2, patch whatever, to supersede the parameters here on the sync.yaml file, because you know that we are in the ops team, and developer doesn't care about having like resiliency, scalability, security, of course. So they only create their applications, and the ops team will just supersede the parameters like number of replicas, having some request and limits defined on the patch level, and so here we create the source, and we create a new Git repository that will apply and deploy new application. Here we create the customization. So already on the sync.yaml file, so we create the customization, and we only show that the path is slash, so it's a root path, and it's a reference the Git repo that we created before. And we've seen that in that sync.yaml file, in that customization file, we are deploying this application in the namespace dev1-ns with the service account name dev1 to be able to deploy that application, because if we lack the namespace or the service account name, it will not, it can't be deployed because of the Holbach model we have been made before. Of course, with customize, you can apply patch. So if you want to apply patch, so you see that the first one is the dev1-patch in the staging environment, and the second one just refer. So the second YAML file just refer the base name and the patch that has been applied. So here we are doing nothing new, because we are specifying only the path, and just Flux can deploy the application in the cluster. Ludovic, you can explain us.
So to sum up all these files and how they interact with each other, we've got the red boxed files that are the Flux configuration. And each time we have an entry point that is the customization file. And this Flux configuration will lead to the tenant YAML, which configure multi-tenants on our cluster. And this tenant is pointing onto the staging tenant, the staging/dev1 tenant, which is the environment which is dedicated to the dev1 team onto the staging cluster, which is just a slice of a single cluster. which is here the cluster 1. This customization file will call the dev1 patch that overrides the base configuration, the base file configurations, which are upper on the upper side. Okay, and these files will target a third source, a third configuration source, that is the green source, which is the configuration that is dedicated to dev1. And here it's in a separate Git repo. And the entry point is of course a customization file. And this entry point is just deploying a deployment resource and a service resource that will deploy our ASP.NET application. So the tricky part of configuration with Flux is this waterfall of inheritance of legacy, but beside this tricky part, it's really simple, as you can see. Of course, by using these several sources, you can have one source for multiple clusters, or elaborate a very complicated strategy. For example, a branch for a specific cluster, and you can have a specific strategy like canary strategy, thanks to customized patches. So you can have, just like we've done before, a base configuration, and on top of this base configuration, you will have patches that derivates this base configuration, that derivate this base configuration into a configuration for staging cluster, for production cluster, and so on. And of course, you can install any operation component like Istio, Prometheus, and so on. For example, a Prometheus installation, Laurent?
Yes, I will speed up because we have 2 minutes left.
Yeah.
If you want to, for example, install Prometheus, you can do that. Here, I create a new source based on Helm, the Prometheus community. And I also define some values.yaml file, like alert manager enable equal false, Grafana dashboard, so stuff like that. And it apply the new configuration inside the cluster. And of course, you create a new Helm release, so it will be sourced inside the Prometheus community repository, but we can install a new chart version. For example, here I installed the 31.0.0 with my values.yaml file to be able to install a new configuration of Prometheus. And this is really useful when you manage hundreds of clusters and you want to install like the same version of Istio, Prometheus, Grafana, whatever, on every cluster in the same company, because all of this cluster will point to the same Helm release and Helm repo. I can just with one git push away install a new version of Istio, for example, inside all of the cluster, without having a separate version on separate clusters. And to finish this talk, and of course, we can install, for example, Kyverno, which is a policy enforcement application. Here, I create a new customization based on Kyverno. I can create a new service account policy. Here, I enforce the creation of the service accounts. And if someone wants to deploy a new application without a service account name, Kyverno will say that the service account is required before deploying that on the cluster. And of course, as the same as before, I create customizations in the tenants with Kyverno policies inside the tenants, and I say the Kyverno policies depends on Kyverno, so Flux can just deploy Kivano before applying some policies. And it's really, really useful. And of course, when we talk about security teams can create the YAML file and just open a new PR on the ops team. So it really brings also collaboration between 2 or 3 different teams, the developer, the operations, and the security teams. And that's bring with GitOps, you can bring like a DevSecOps pipeline live. Thank you very much for Flux and Weaveworks to have us on this talks. If you want to have like the repository, the main repository, you can go to github.com/1-kubernetes/workshop. We have a step-by-step with a Flux multi-tenant that reproduce what we have shown you, and you have the more complete version of the slides. Thank you very much.
Thank you.
Awesome. Thank you so much.
Thank you.
And as usual, the YouTube stream is wrapping up, and I've let people know, please post your questions to the Slack channel because we will continue to monitor those questions over the coming week. And we'll alert you in case there's any that you don't catch. But I'll just share that one person was saying, this is a user testimonial turning into a crash course. So they found it very, very useful. So thank you so much for joining us. I know it's a bit late for you, so appreciate it very much. And we will see you.
Thank you so much.
We will see you in the Slack. All right. Well, we are about to kick off our nice music break with DJ Desired State. Vanessa has been emceeing with us in the mornings my time, but the evenings in afternoons and evenings in the UK. And Pinky has been emceeing with me in the afternoon. So we wanted to all join this break as we break into the music. To thank you, Vanessa, for emceeing with us.
Thank
Tons
you,
of fun.
guys. I've had tons of fun. I'll be backstage watching everything. So good luck with the rest of the evening.
Absolutely. And
Thanks,
Pinky, thank
Vanessa.
you for joining me. I look forward to the rest of GitOps Days with you. And with that, we've got Daniel ready to go. Yes, I'm ready to have another coffee break. See you all after the break.
جنتي 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 وناري 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 جنتي 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 وناري وناري كيف تكون الحياة كيف تكون الحياة إذا لم يحرق قلبي المشتاق إذا لم يحرق قلبي المشتاق بالهوى يا حبيب الروح يا هاجري يا جارح قلبي يا هاجري يا حبيب الروح يا هاجري يا جارح قلبي يا هاجري يا حبيب الروح يا هاجري يا جارح قلبي يا هاجري جنتي في بعدك نار وناري في قربك جنة جنتي في بعدك نار وناري في قربك جنة جنتي 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 وناري 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 يا حبيب الروح يا هاجري
Eller keser demedim mi dimmi. Ve ala gözlü dilber dilber. Vaktin geçer demedim mi dimmi. Harami olmuş gözlerimlerin. Eller keser demedim mi dimmi. Eller keser demedim mi dimmi. Eller keser demedim mi dimmi. Eller keser. Eller keser. Eller keser. Eller keser. Vaktin geçer demedim mi dimmi. Harami olmuş gözlerimlerin. Eller keser demedim mi dimmi. Yana gözlü dilber dilber. Vaktin geçer demedim mi dimmi. Harami olmuş gözlerimlerin. Eller keser demedim mi dimmi. Eller keser. Eller keser. Eller keser. Eller keser. Yana gözlü dilber dilber. Vaktin geçer demedim mi dimmi. Harami olmuş gözlerimlerin. Eller keser demedim mi dimmi. Yana gözlü dilber dilber.
istediği yerle giderim yani. Sırtındaki sepetin ben olayım hamali, ben olayım hamali, ben olayım hamali.
Dangerous. It's almost the best part of the show, really. Well, the speakers are the best. Then the music. Then our jibber jabber.
Thank you, Daniel. That was awesome.
Yes, it was awesome.
I liked the vibes of that one. It was like Middle East. It was cool. Yeah, it was fun.
I know. I was thinking I want to learn what the lyrics were about. Very cool. Well, thank you, everybody. Thanks for this lovely break. I hope you enjoyed it. Again, reminder for accessibility, we stream to YouTube, so anybody can pause and come and go as works for you. You know, I don't want people to feel constrained to tighter breaks because we are jam-packed with material. And speaking of jam-packed with material, we're going to get right into it. Pinky, would you like to introduce our next guest?
Yeah, so our next guest is Anais Ehrlichs. Hopefully I said that right, from Aqua Security. So thank you so much. She's going to be telling us about security with GitOps.
Hi, everybody.
Good to see you again.
Did I say it right?
You said
Hopefully.
it correctly. I was waiting for the moment, like the, you know, like the expectation, like, whoa, is she? Yeah, thank you so much. Amazing. Okay, so I'm gonna share my screen and get started. I have to share my entire screen, however. So you have it, right? You can see everything. Awesome. Hello, everybody. Thank you so much for joining me here. I'm really excited to speak at GitOps Days. This talk is on security first, the benefits of integrating security tools into your GitOps workflow. Now, before I get started with my presentations on security tools, and I hope I can, yeah, here's the next slide. I like to ask people what comes to your mind when you're thinking about security. Maybe those are specific tools that pop into your mind of like, oh, I'm using this tool, or I've heard people talk about that tool, or specific processes, maybe any buzzwords, anything that comes to your mind. It's maybe a rhetoric question. If you want, you can post in the chat. I probably won't see it until afterwards. But ultimately, when I ask people this question, they have different types of reactions. And usually those reactions are not too much on the positive side of experiences. So a lot of people would tell me that security in the cloud native space adds to a lot of confusion. It's irritating. They don't know where to start. It's difficult. Maybe it's focused on specific teams, specific people empowered to use security focused tools and similar. So there's really usually it's not like a yay security kind of answer that you would get. And this is exactly why I like talking about integrating security into your existing workflows, such as if you're using GitOps tools such as Flux, CD, you could focus on integrating security tools alongside your existing tools with minimal effort. So this presentation is really on the why, when, what, who, and how of security, very briefly. Then how security relates to your GitOps workflow, what are the similarities between your GitOps workflow and your security workflow, and the goals of both of them and the overlap between those goals. And then I'm going to show you how you can integrate your security tools into your existing workflow with a hands-on demo as well. Now, why am I talking to you about this? If you don't know me, I've been working in this space since 2020. Before that, I was working in different roles in the blockchain space, in the open source blockchain space. Then I joined the cloud native space as developer advocate. Last year, I worked as site reliability engineer. And now this year, I got back into open source developer advocacy at Aqua Security. Now, I also just reached 10,000 subscribers on YouTube, which is really exciting. So if you're one of them, big shout out to you. Here's my YouTube channel. As you can see, one of my previous video before all of the conference started was on Flux. So check that out maybe if you're interested. I also have a weekly, right now not weekly DevOps newsletter, so maybe you're interested in that. But let's talk more about security since I have only limited time and I want you to get the most out of the presentation. So why, when, what, who, and how? Ultimately, it depends so many other things on, on your team, on the different tools that you're using. And a bunch of different factors. So for instance, depending on the size of your team, depending on the nature of your project, you will want to use different security tools. Depending on what tools you're already using, you want to use different security tools. Depending on your company's goals and objectives, you will want to use different tools for security. So there are really multiple areas that you want to keep in mind before you start integrating security tools. Ultimately, the cloud native space is a very complex area. If you're already familiar with different cloud native tools, you might know that there's lots and lots going on. It's a really fast moving space. And whenever you're adding a new tool to your existing stack, it will be another tool that you will have to maintain. So you'll have to keep that in mind before you add new tools. Yes, you should focus on security for your stack. You should be establishing a security first culture, but not on the expense of people having to do more than they can actually handle. So which tools should you use? Again, the type of tools that you will choose will depend on those factors. So there's not really one right answer. However, there are different aspects in which security tools really differ, and that's something else you want to keep in mind when you're choosing a tool. So once you decide, okay, you want to focus more on security within your workflow, for example, within your GitOps workflow, you want to integrate security tools that are running within your cluster or beforehand, and you start looking at different security tools, you want to look, for example, at the installation. So different security tools will have different installation options. Some of the tools are CLI first, meaning they are while they maybe have ways to install the tool within your cluster, the tool itself and the maintainers will focus on enhancing the CLI experience. So anything that goes on for security scanning before you do actually the deployment in the cluster. So before anything touches maybe even your CI/CD pipelines, And that's something you want to keep in mind, because then maybe the tool running within your cluster will be suboptimal for your use case if it's not focused on that use case, right? The other part is the Kubernetes resource type that those tools use, right? Some tools will use operators, some tools will use just jobs running within your cluster, or other Kubernetes resources. So you want to keep in mind, what type of resources is the tool actually using? Is it beneficial to us? Is it achieving our goals? Also, you want to make sure that if you're using cloud-native tools, if you're running all your workloads on Kubernetes cluster, then you want to make sure that the security tools you're using can integrate with your existing stack inside of your cluster, inside of your cloud-native application stack. The next thing is, and that's something just to keep in mind, is scan coverage. When you're comparing different tools, they pull from different data sources the information. So for example, when they check for vulnerabilities, so you want to make sure that you know where the information coming from and kind of what is the experience that other people have with those tools and the scan coverage that they provide. Then the next thing is the integrations. So we're talking here solely about open source tools. Like, I am the open source developer advocate at Aqua. I'm not talking about any enterprise tools. I'm talking about the open source tools similar to Fluxity. We're talking about open source here. And the more mature open source tool gets, the more integration it will have within the ecosystem, right? So either those integrations are built by the community or they are built directly by the maintainers. Now, the last thing is, which kind of relates also to the installation, is the focus. Like, which user group does the tool focus on? Is it focused on cluster administrators, or is it focused on engineers using the tool within their terminal, right? It really depends. So you want to keep those differences in mind when you're choosing a tool. Now, when I got started within site reliability engineering last year, we were using different tools. Now, at the time, we were trying out GitOps in our staging environments. We weren't using it in production, I have to say honestly. But we use those different tools on a day-to-day basis. The thing is, then when I got started looking into security tools, and then ultimately when I got started at Aqua Security, I was like, where are the security tools, right? So there are just some tools that you kind of want to use as part of your stack. And at Aqua, then I discovered Trivy and Tracy. Now, I'm going to focus on integrating Trivy within your GitOps workflow in this presentation, and I'm going to show you why and how. Trivy is our open source security scanner, and Tracy is a runtime forensic tool that uses eBPF under the hood. We are not going to talk about it in this presentation. It's a whole other topic. But you ultimately could also integrate Tracy into your GitOps workflow. It works similarly. I'm just using Trivy as like the example, and they're the Kubernetes resource relating to Trivy. Now, why Trivy? Well, Trivy has lots of different functionalities, and I will go into detail when to use which in a second. But ultimately, within those different functionalities, we just added in-cluster scanning with Trivy. So you can install Trivy within your cluster, and that's ultimately what I'm going to focus on in this presentation. Let me just check the time. Okay, so when do you want to use scanning tools? Well, before your deployment stage of your development lifecycle, for instance, of your different processes, before you want to deploy your workloads, you can do a lot of different scanning for your resources. You can do file system scanning, you can scan Git repositories, container images, the base images that you're using to build your Docker file, then you can scan your infrastructure as code, and so on and so on. And that can all happen, everything you see here, I hope you see my mouse, can happen within the CI/CD pipeline. So before you trigger any deployments for your GitOps workflow, they can all happen beforehand, and you could stop the pipeline, you can stop deployments if you, for example, discover critical vulnerabilities or misconfigurations that you should pay attention to within your workflow beforehand. And that workflow might encompass on local development machines, somebody scanning a third-party library packages for vulnerabilities, and it's like, oh, maybe we shouldn't use that. We have to like go back and like see what else is out there, or it could happen later on in the development lifecycle in your pipeline. Now, the thing is, once you go to the deployment stage, you want to make sure that you can actually deploy a security tool also within your cluster that is running within your cluster. And the thing here is that ultimately, once you go past it, like to the deployment stage, you want to automate everything as much as possible. And that's also one of the goals that I'm going to talk about more in a second, that also GitOps is addressing, right? You want to empower engineers and you want to not give them additional, like more work to do manually, right? You want to automate things. And that's only happening if you can actually integrate security tools within your cluster and automate the information that they filter for and that they give you. So why Trivy, or like how does Trivy really work in your cluster? If you're new to Kubernetes, this might be one of your clusters. Just imagine it as like different sections within the cluster, different environments, and they're your different tools. And the Trivy operator is basically a Kubernetes resource that runs within your cluster, and that will scan for example, vulnerabilities of your workloads. It can do lots of different scans within your cluster automatically, like on a 3-hour or 6-hour time in between. It will scan all of your resources. Now, how does it relate now to our GitOps workflow? So I kind of talked about some of the goals that we have with our security tools, but also with our GitOps tools. So let's dive into that in a bit more detail. First of all, we want to empower engineers. And a lot of times when we talk about shifting left and empowering engineers with tools such as Flux or security tools, we might miss the point by like giving engineers more work to do. Like that's not the goal, right? We want to keep in mind that we don't want to give engineers just something else to do in their day-to-day job, right? Yes, we want to bring security and continuous deployment closer to engineers, but not on the expense of them having to actually invest more and more time into tools and processes that is just in addition to their day job. The other thing is that we want to provide visibility, and that's really a goal with GitOps, that we want to know when was deployed what, where was it deployed, by whom was it deployed, and how was it deployed, right? And this is really correlating to security ultimately, because when we find new vulnerabilities in our cluster, or when we discover new vulnerable deployments within our cluster, we want to know those things as well, right? Like, yes, my auditing tool can tell me, hey, Trivy detected X new critical vulnerabilities of this new deployment. But then I want to know, okay, there are new vulnerabilities of this deployment. Was there any update that happened since like X time, right? Or who made those updates, right? All of this information can then help me debug of like, okay, how did the security issues actually enter into my environment, into my infrastructure? And how can we address kind of the workflow from there and prevent it from happening in the future, or make our workflow more secure, or mitigate the vulnerability as fast as possible. And the other thing is, which I also touch upon, that ultimately with GitOps tools, as well as with security tools, you want to make sure that you have Kubernetes resources, because that allows easy integration between the different tools. And that's something that I'm also going to show you in my demo in a second, that if everything is Kubernetes based, it's really easy to combine different tools with each other instead of having to use a complete separate platform. Because you have to think about it, if you're using a separate platform that doesn't integrate, then you will have to look at the platform, you have to configure and maintain the platform separately. Versus if everything is running through one common tool, such as Flux CD, then you can ultimately monitor everything through the same tool. The other thing is, we want to have automated scanning, such as we want to also have automated deployment based on predefined rules. And then the last thing is, you want to have lots of different integrations, like I already mentioned. You want to make sure that new tools that you're adding to your stack is ultimately integrating with your existing stack. So here's again how it kind of would work, and at really high level. If we have Flux running within our cluster, within a separate namespace, and then we want to install the Trivy operator within our security namespace. So we would ultimately connect Flux running within our cluster. We tell it about our different repositories. Now, those repositories could also be external Helm registries with Helm charts that we want to deploy, for instance. And then Flux is there responsible to do the continuous reconciliation of those resources and make sure they are deployed accurately within our cluster, right? So it's really not us interacting with the cluster. It's just us telling Flux, like with any other tool that you want to deploy through Flux, of like, hey, here's our security stack, please make sure it's deployed. So it's really not something else. It's just, you can use the same kind of tools that you're already using to, for example, configure and make your deployments happen for your application or for your observability tools. You can do the same for your security tools. So how do we actually go about it? Well, this is just another slide to demonstrate, like, you can use Trivy at multiple different areas. Now, again, we will focus on Trivy Kubernetes operator and to perform ultimately in cluster scans. And you can also use Trivy directly, like the CLI, to do in-cluster scans, but this would again be the imperative way of scanning our resources. It wouldn't be an automated declarative way if we use the CLI. Like this would be the CLI commands that you could use to, for example, do cluster scanning, namespace scanning, and so on, for example, vulnerabilities and misconfigurations. Now, you can also use Helm, and in my demo in a second, we're ultimately using Helm or like the Helm deployment, but through Flux to deploy Trivy, the Trivy operator inside of our cluster. So here's the demo. I have here a multiple node Kubernetes cluster, and I'm just going to connect it through a tool called K9s. I hope it's opening up. Let's give it a second. The demo gods are not with me. So while this is trying to open up, and I hope it's going to open up. Here we go. I would show you the other resources, but it already opened up, so that's great. So here are my different namespaces within my cluster. Now I have here my application namespace where my application deployment is supposed to will happen. Then I have here my Flux system namespace, and here I have Flux through the bootstrap command installed, just normal Flux controllers running within here. And then going back, I have my monitoring namespace with Grafana and Prometheus installed. And then I have my Trivy system namespace. Now in the Trivy system namespace, I want to install, first of all, Trivy as like the Trivy operator, as well as the Trivy exporter to also access the vulnerabilities from the Trivy operator itself. Now, how do I do that? Well, if you want to deploy an application through Flux, for example, you could either do it through the Flux CLI, or you can define like a Kubernetes resource, which is like a custom resource to Flux, where you, for example, specify the repository, the Git repository that you want to use, and then which part is going to get deployed. So I'm just going to give this manifest to my cluster, to Flux, and then Flux can go ahead and install the application. Now here I tried to play around with it, that's why this deployment is right now pending, but ultimately here's the other deployment from before, running within my application namespace. Now I want to do exactly the same thing with my Trivy operator and my Trivy exporter. Now in this case, you would define two resources with Flux. You would define the Helm repository that you're using, and then the Helm release that uses the Helm repository defined up here. And you're defining like basically where is the Helm chart actually live? Where's the Helm registry that we're pulling the chart from? And then you define, okay, you want to use a Trivy operator chart. And the same would go for the Trivy exporter. And I can give, again, those two different resources. I can give it to Flux, and then Flux knows where to pull the information from and install my resources within the cluster. So those two are managed through Flux, the Trivy exporter pod and the Trivy operator pod. Now I can go to Helm release, and then I can see the two Helm releases up here, and Helm, what was it called again? Helm repository. I want to say Helm registry repositories, and I can see my Helm repositories as well. Now, once you have installed the Trivy operator, and this is just again like through another resource, right? Through another Kubernetes resource that you give to Flux inside of the cluster, it will then do, for example, vulnerability reports. So you can scan for vulnerability reports like any other custom resource definition within your cluster. So I'm just saying, okay, kubectl get vulnerability reports, and basically across all of my namespaces. And I can see here, these are the different vulnerability reports. So I, for example, have my different deployments for my application. And here I have installed, for this application, I have installed the React app with the image 9.0.0 and 7.0.0. Now it scanned both of them for vulnerabilities. So as you can see, the old deployment had 5 critical vulnerabilities. The new deployment has 3 critical vulnerabilities. So you can see the number of vulnerabilities that those deployments have through the vulnerability reports, which is just done automatically through the Trivy operator that's living within your cluster. So anything like once you define the resources that Flux has to know about and you give it to Flux, Flux will ultimately make the deployment happen automatically. And from there onwards, you can look at it, but you don't have to look at it, right? Like this all happens within your cluster. However, obviously, right now as it is, you will have to look at it directly. Like you would have to query, for example, for the vulnerability reports and the other reports within your cluster. So what you want to do instead, and something else you want to think about as like last point, is the different integrations that you can make happen. So I'm not going to show this in this demo, but I set it up in another demo, is Grafana dashboard, which basically accesses the metrics from the trivia operator and then visualizes the number of vulnerabilities in the application namespace, like the total number of vulnerabilities for that deployment, and then the number of vulnerabilities defined by severity, and then also the entire vulnerabilities inside of our entire cluster. So through visualizing everything within our Grafana dashboard, we can then, for example, set up alerting, and we don't actually have to look at it all the time. We can just look at the alerts of, for example, our critical vulnerabilities, or if things happen. And again, this is all post-deployment stage. Like everything pre-deployment stage is obviously like you configuring your infrastructure as code, you defining your resources and everything. And then, but then once you deploy them, you don't want to have to do things manually again and set up things manually. The same you could do for Tracy. Now, I'm not going to show you Tracy live in this demo, but Tracy is ultimately also something that you can deploy through a Helm chart, and then you can gather the logs that are posted from Tracy that's reporting the different processes that are happening within your cluster. And then you can also visualize Tracy and the logs that you get from Tracy within, for example, your Grafana dashboard. And that's it. Awesome. Thank you. Yeah, so just the takeaways. Ultimately, security goals are GitOps goals. There's a high overlap between like making our deployments visible, seeing whether or not, like how secure are your deployments, or how is our security change of our cluster, of our resources, like the number of vulnerabilities changing over time. And that's something like visibility that you want to gain into your deployments and through using additional tools. Now, getting started with security tools has long-term benefits. You don't have to be an expert from day one. If I can get started with security tools, so can you. Let me know if I can help, or we can help with anything at the Aqua open source team. Now, Trivi is a really comprehensive and versatile security scanner. Now, there are other scanners out there, so I suggest you take a look, see what works for you. Yeah, I think questions, you can just reach out to me on Twitter.
Awesome. Thank you so much. And thanks for being on time. So yes, and speaking of questions, we already have some in the Slack channel. So I will remind everybody, yes, if you're watching on YouTube, which you would be, please make sure you join our Slack channel, because we and our speakers will continue to monitor your questions throughout the day and throughout the week. And yes, there's a pretty interesting question there. So Anais, if you have a second, you can go and answer that, and we really appreciate it. Thank you so much for joining us.
Thank
and
you.
It's so great to see you again.
Thank you. You too. Go ahead.
Yeah. So with that, again, just want to reiterate, you know, security has come up so many times with our user talks. It's so critical. So we really appreciate that Anais was also able to join and share a perspective, as well as a really useful project out there. And I have mentioned our upcoming speaker, Victor Farsik, because many times cross-plane has come up, and one of the categories of talks that we have here at GitOps Days is Flux, working with many projects such as Terraform, Prometheus, Vault, Helm, now VS Code, et cetera, and so we're really excited that Victor has joined us today, and we'll talk about crossplane. And I definitely want to promote, if you haven't seen any of Victor's videos, hey Victor, it's great to see you. Love the shirt.
Hey.
Yeah, if anybody hasn't seen Victor's videos, I think you've been living under a rock, because you should definitely check them out. You've been doing years of these very informative, detailed, fantastic videos. So we thank you for all the educational material, and we thank you for when you've covered Flux. It was very exciting, and they're very fast-paced and well edited, and so definitely happy to promote them here. So we're thankful that you're here to present at this event as well. So yes, lots of people are talking about Flux and crossplane, so take it away.
Thank you. Okay, so let's go for it. Let me share my screen. There we are, right? So, sorry for that. Let's talk about applying GitOps to everything, which I believe is very important, because we've been very limited in our usage of GitOps, and that's a shame. So you already heard, this is me. I work for Abound. I have a Twitter account. Everybody does. Foundations, books, not important. What does matter, especially since I don't have much time, is that I start my talk right away. And so let's talk about GitOps, right? What is GitOps? And typically there are two components in that story. First, we have a desired state in Git. That's where we store what we want the state of something, or more likely of a whole system, to be. And then we have a process that converges the actual state, what really something is, into the same state as the one defined as the desired state, right? So relatively straightforward. This is what I want, this is what it is, and then I have a process that converts what it is into what I want, and does that continuously, all the time, in a loop, right? There are certain principles, you already heard about them today. It needs to be declarative, it needs to be versioned, immutable, pulled automatically, continuously reconciled. You know that stuff, right? And you know that most of the GitOps tools, especially Flux, is based on Kubernetes operators, and that makes a lot of sense, simply because Kubernetes itself is designed to be extensible. It has an API that can be converted into almost anything. It has drift detection, reconciliation, and that fits perfectly into Flux, right? It's not a coincidence that Flux is designed for Kubernetes. But here comes the important question. Most of us are using GitOps principles as defined. Not kind of, when I say GitOps principle, I don't mean you have a Jenkins job that does something. I mean real reconciliation, pulling the desired state and all that stuff. Most of us are using GitOps for our applications. And the question is, why, right? And the especially important part to understand is that Kubernetes resources, what we are synchronizing into Kubernetes cluster, is not really the actual state. The actual state are your containers. The actual state are your lambdas. The actual state are your servers, your networking, your clusters. That's real. That's the actual state. Kubernetes resources are not. They're just describing something that helps controllers do something else and eventually get to something real. So the actual state inside Kubernetes is containers, it's external load balancers, it's storage, and so on and so forth. But that's only if we look at Kubernetes from a very narrow perspective. Kubernetes is sometimes the actual state. Sometimes what we want is inside of that Kubernetes cluster, but at other times, Kubernetes is just a bridge, just an intermediary between the desired state, which is what you store in Git, and what you really, really want. What you want could be Kubernetes itself, could be what's inside Kubernetes clusters, could be what's outside. So the actual state, what you really want to theoretically to manage are databases, applications that are not running in Kubernetes, servers, clusters, third-party applications, services, Kubernetes itself. All those things are your actual state. And if we focus on GitOps principles, not necessarily on how majority of us implemented GitOps, there is no good reason why we wouldn't manage those, everything, the whole actual state with GitOps tools. So the question is, again, why are we using GitOps mostly for applications? Especially since we know that if Flux is synchronizing what is in Git to what is in a Kubernetes cluster, and we know that Kubernetes cluster can be extended through CRDs to manage almost anything, then we really can easily extend GitOps to anything. All we really need, and when I say all, it's actually huge, is a way in Kubernetes to represent all the real resources that we're managing. You know, servers, databases, applications, this and that, everything. And that's where Crossplane comes into play, right? Crossplane allows us to install providers, and providers contain custom resource definitions with corresponding controllers that allow us to define through Kubernetes interface different resources like EC2 instances, ELBs, databases, servers, clusters, almost everything. So, and by the way, Crossplane is open source, CNCF Foundation project, and so on and so forth. The company and people who started Crossplane, that's where I work, Upbound. Check us out. This is not a sales pitch, so do it later. Now, with that very quick introduction, let me start with the demo immediately. I need to switch from slides, which I don't like, into my terminal. Okay, let me display how all that works. How I can use Flux to manage absolutely everything. So here's an example. I have this file that says, hey, you know what? I would like to define something called cluster claim. I will show later what cluster claim is. What matters for now is that this is a CRD in Kubernetes. We call it XRD or cross-plane resource definition. You can call it CRD as well. And I'm saying, hey, I want to manage a cluster. I want that cluster through labels to be in AWS, and I want it to be EKS type of cluster. I'm going to give you some very, very simple parameters, like this is the size of the nodes, this is the minimum number of nodes. Off you go. Now, I already have, because it would take a lot of time, I already created a management cluster. I have a cluster where Crossplane is running. I installed Flux inside of that cluster, and I told Flux to watch a specific repository. So all I have to do is push this file to a Git repo, and then Flux will synchronize this definition with my Kubernetes cluster, and it will make sure that it's always in sync. And then the second half of the story will be done with Crossplane. Crossplane, once it reaches the cluster, will take it over and say, okay, so you want a cluster, let me see what cluster means for you, and I will take care of everything else, right? Now, since I'm using AWS here, it takes 25 to 30 minutes to create a cluster and everything else that I might need. So I did that in advance. I already pushed that file to Git. And I will show you now the results. So I did a couple of hours ago, just to save you from waiting too much. I pushed it to Git, Flux synchronized it with my management cluster, Crossplane took it over and created. And the real question is, what did it create? And I can approach that question with a couple of ways. I can say, hey, let's see what is in Flux system namespace and get cluster claims, right? This is a completely new resource, and it says, okay, cool. You have your cluster up and running. It's called production. Its control plane is active, node pool is active, and it's ready. It's ready for you to use, and you can see that I did it like 2 hours ago, give or take. Now, that would not give it a lot of, it doesn't sound so great, right? I did something and synchronized it with the Kubernetes cluster, and then Crossplane did something. So I need to show you what Crossplane really did when Flux synchronized this resource. I can do that with this shortcut, which is get managed type of resource. Is actually essentially a shortcut that tells Crossplane, show me all the resources that you are managing right now. And this takes a few seconds to process, just enough for me to have a sip of my beverage. And while waiting for that actually to happen, let me show how I created all that. And to do that, I'm going to open a repository. Here we go. So how did I get to have that definition, that cluster claim, whatever it is, because it doesn't come out of the box from anywhere. So here's what I did. And this is partly to enable GitOps in my organization, partly to also enable simplify things for everybody. So I created something we call package, and I said, hey, I want to define a new custom resource definition. We call it composite resource definition. And I'm going to call it cluster claim, as I told you. I'm going to use OpenAPI schema to create the schema for that new service that will have some fields like version, node size, minimum number of nodes. And then I'm going to create an implementation for Civo, for DigitalOcean, for EKS, and for GKE, or whatever I want. Oh, there is EKS as well. So now, since I'm using EKS today, AWS, this is my, no, that's the wrong file. That's the wrong file. Here we are, right? This is the implementation that has typical things you see in infrastructure as code tools. I'm defining a cluster with a bunch of fields. I'm defining a node group and so on and so forth. I'm doing a bunch of things. But for my end users, that's irrelevant, right? They're using that cluster claim. And this is what I got as a result of pushing those 15 lines of YAML or 20 to Git repository, right? And Flux synchronizing it. I got role policy attachments. I got roles. I got some Kubernetes manifests were installed in that cluster because, let's face it, cluster by itself is not very useful if it's not operational and production ready. Some Helm charts, some node group and cluster and VPC and so on and so forth, right? So Crossplane expanded my custom resource definition or XRD into all the resources that are needed. And now my cluster is ready to use, and I can show how that looks like by pushing something to Git. So I'm going to create a directory DevOps, right? And then I'm going to say, hey, I would like to deploy a backend application with a database to that cluster. How would I do that, right? Now, one approach I can take is I could define a deployment and service and virtual service and ingress and RDS database and subnets and whole madness, right? But somebody already created those services for me, those custom resources. And all I have to do is define something like this. Hey, I want something called appclaim. And that's how Desiree in my company defined an application. And I'm going to choose that application to be a backend application with a database running in the same cluster. And I'm going to use this image for my application. And I want a database. So I'm going to say I want to claim a SQL. Again, completely custom resource created by people in my company. I'm going to use I'm going to run the database. No, this is boring. Let's do something more. Sorry. I'm going to do something better than that. This is really boring. Okay, let's do something better than that. Let's go like this. Let me retrieve the kubeconfig of my new cluster. Let's do this. And I'm going to define an even better application. I'm going to say, let's go production directly instead of development. Let's be brave. And let's use this definition, which is the same what I was explaining before. But instead of running local database in that cluster, I'm going to actually choose to run, where is it? Where am I? Yes, I'm going to choose to run a database in AWS, RDS database, and PostgreSQL. It could be MySQL or whatever. And I'm going to store that file, and I'm going to push that file to Git repo. Add commit -m something, and I'm going to push it, right? And I'm going to tell Flux to use that new cluster, right? Not the cluster where Flux is running, not the cluster where Crossplane is running, that new cluster, to use it and synchronize what I just created, that YAML, simple YAML with that new cluster. And I'm going to do that by using Flux create. You all know Flux. I'm not going to go into details of Flux. I will, however, have to change one file. Here we go. Because for some reason that I cannot explain, Flux does not allow me to specify kubeconfig that it should use to connect to a cluster I'm interested in. So I'm going to do that myself. Say kubeconfig should be stored in a secret that is referenced with the name production cluster. Now you might be asking, where does this secret come from? And the answer is relatively straightforward. Crossplane, when it created a cluster, created this secret. And I can just tell Flux, use the secret, connect to that cluster, apply that manifest, and really do whatever needs to be done. And I'm going to double check whether everything is fine. Yes, it is. I pushed it. I'm going to create this Flux customization. Here we are, right? And I'm going to monitor now what is happening in my newly created cluster, right? It might take 10 seconds or something. Okay, here we go. It's already there, right? Flux synchronized that manifest with that cluster. Here are the two resources that I got, application claim and SQL claim. They're false. The database is take like 5 minutes to create the RDS database in AWS. So let me take a quick look at what's happening in inside of that cluster. What's happening in the namespace production. Now you will see that that manifest expanded it to a deployment, a service, an ingress, and deployment, of course, created replica set. Replica set created pod, but this pod is failing. Now you can interpret this as Victor doesn't know what he's doing, or you can say this pod is failing because it expects, that's the application that expects to connect to a database, and it will connect to a database through a secret, but that secret doesn't exist. It will exist only after the crossplane creates the database itself. So I need to wait until the database is created, and then once it is, the secret will be there, and then the pod of the application that connects to the database will automatically start working. And I can see what's going on by listing the managed resources again. This will take a moment or two. I'm not patient enough, probably. Let's go. Come on. Don't fail the demo at the very end. I'm not even paying attention how much time I have. I hope that I have enough. Okay, here we go. So what happened is when I pushed that manifest to Git, that's a composition that converted itself into everything I needed for the database. And you can see that my RDS instance is being created right now. RDS instance needs DB subnet group, and that was already created. And it needed a VPC that was created, and a security group was created, and route table was created, and internet gateway was created, and all the things required to run a database were created through that simple file. The only thing left now is to wait for the database to come up, and I hope that that will happen soon. Now let me remind you one more time. What did I get? What are the things that I defined? Remember, all this, and where was the other one? And all this was created through this file, prod.apps backend YAML, right? I defined a new app claim. This is a new resource defined through crossplane, but which I defined through crossplane. Fluid labels to say which implementation I want, few parameters with the things that matter, claiming a database, again, a few labels, few parameters, and this is important part that I forgot to mention before. And this is telling it, hey, when you create the database with everything you need, create that secret, and that secret will be used by this application later. So let's see whether this is now running. Is it running or is it not running? Don't fail me at the last possible moment. It will run. Trust me, it will run. It probably takes 5 to 10 more minutes until the database was created. Oh, okay, here we are. Almost there. Almost there. Prepare your questions. There. Oh, the database is running. Look at it. It's ready. And if I go and open the pods, let's see. The application that was not running before is now running because it got the secret. It found out how to connect to the database. Huge success. It's working. And now I can say, if you have any questions, shoot them at my side. Thank you so much for watching. Thank you for listening. Check out Upbound, my company. Check out Crossplane because it's absolutely awesome. listen to the podcast, come to my YouTube channel, and now ask me questions if you have any.
That was awesome. I love your presentation style. It's just so fun to watch. You keep it entertaining. It's great. So there is a question. How should current Terraform users adopt this without rewriting their modules?
You cannot without rewriting your modules. I mean, let's face it. It never worked for any application. You could not switch from Ansible to Terraform without rewriting Ansible. You could not switch from your shell scripts to Ansible without rewriting shell scripts.
Right.
You will need to do some rewrites. Now, you can go step by step. There is a Terraform module provider that allows you to run Terraform HCL within Crossplane. That shouldn't be the end goal, but you can use it to transition partly, kind of like put first everything in Kubernetes and then start rewriting part by part. The way how it is organized and structured and those compositions, you will not need to rewrite literally everything. You will just need to rewrite the recipes. And then applying those recipes or compositions is very, very easy. But so let's put it this way. If you rewrite it to Crossplane, you will continue having jobs because somebody needs to do it. It's a good thing.
And you're right. I mean, HCL is a HashiCorp created language. So yeah, obviously it's going to, be a proprietary, right? I don't see any other ones coming in yet. And again, like Tamao mentioned earlier, there's a delay with YouTube. So probably there will be questions asked shortly. But if you could just keep an eye out on that channel and answer them as they come in.
Will do.
Thank you so much. It was awesome having you present
Thank
for
you.
us. Thank you.
Cheers, everybody.
Bye. All right. So next up, I am super excited about this one because these are friends of mine and ex-coworkers of mine as well. So next up, we actually have Race Per Se and Perry Wu from State Farm here to share with us the journey that State Farm has had. Hi, it's so exciting.
Thanks for having us back. We're excited.
Hi, Perry.
Hey, Pinky.
I saw Race yesterday, so now I'm excited to see Perry.
Okay.
I don't matter.
All right, take it away, y'all.
All right, let me share my screen. Hopefully y'all can see that. All right. Well, welcome to GitOps and Flux at State Farm. We had the opportunity to speak yesterday at a high level. We're going to take a technical deep dive today. My name is Race Per Se. I'm Senior Engineering Manager at State Farm. I manage our change automation team, responsible for kind of GitOps and Flux and the big picture and how we automate change for State Farm. And I'm honored today to be joined by Perry on my team. So Perry, can you introduce yourself?
Yep. So my name is Perry Wu. I'm a software engineer under Race, and we're responsible for applying, implementing, and promoting best practices for GitOps for State Farm in order to deploy on their pathway to production.
Awesome. Let's get into this thing. So quick background on State Farm if you're not familiar with us, but highly regulated environment with insurance. We have tons of compliance obligations we have to meet. We have extremely high standards for security. For every change that goes out the door, we have auditing requirements. And so we need a record of that change. And so then we need to be able to look back on that in the future. So very, very tough environment to be in sometimes, but I like to think of it as a fun environment. Our Kubernetes footprint, we're pretty large. I know this is not the biggest ever. I've seen some pretty crazy clusters out there in other talks. But our on-prem clusters, we have our own data centers. We have 400 nodes across test and production, over 1,000 namespaces, and really double that if you count like our clusters that are replicated, and over 7,000 deployments, just your normal deployments in those clusters. We're growing in EKS. We actually have a lot of new clusters being built there. They're mostly single tenant clusters dedicated to a certain area. But these are kind of starting to bridge together, and how we do GitOps and all that still works on no matter where you're at, because it's all Kubernetes. But that's our Kubernetes footprint as it exists today. So in this big environment, in this highly regulated environment, how do we check all these boxes for risk, compliance, and auditing and security? And at the end of the day, we really just want to offer an amazing developer experience. Like we don't want to bog down teams and reduce the speed at which they're delivering just because of all these things we have to hit. And so how can we do that? And GitOps to the rescue. And the reason I say that is really it was not until GitOps, when we learned of GitOps and we learned of Flux, it was really when we started to rethink how we thought about change and how we could change or take the tools we use today and integrate them with our existing patterns and systems that we needed to still hit all our requirements, but still make the developer's life enjoyable. I'm not going to explain what GitOps is. If you're at this conference, I hope that's clear by now. This is day 2. But number 1 on our list is to adopt a GitOps mindset to what you do. We got some questions on this yesterday about how we, in a regulatory environment, how do we actually enforce our requirements and how do we lock down things? And I'm hoping this today will answer some of those questions. And so we actually separate our source repos, like where you do your development, like the normal thing that when you check in something into Git, that's your repo where you start. We have a separate repo that is dedicated just for production. And those are highly, highly locked down. And I mean, the developer cannot see settings. You can't change the merge request approval rules. You can't rewrite the Git history. Those things are permanent forever. And that's extremely important, but that is how we're hitting all of our auditing requirements. We automate the creation of the production config repos with Terraform. And we're going to talk about that today. You also want to automate your Flux installation and how that's used, and we're going to dive deep into that. We have Fluxes installing Fluxes, which we always like to talk about. And then enforce your branch approval rules, like whatever those rules may be. We have quite a complex setup. It's not just branch and approval rules, but you want to enforce that on a cadence. And so what I mean by that is if someone were to sneak in, we've had it happen, where we have a great security team at State Farm that loves to just kind of poke things every now and then and see what they can do. And we've had numerous occasions where they've gotten us, and we've actually made our systems better because of their actions. But the enforcement on a cadence will always put things back to how they were. You don't want to just set these things up and forget about them. You want to be enforcing that as often as you can. And we're at a certain spot today and hope to get somewhere better in the future. So a lot of text, a lot of words. I like pictures. And so this is, I had to drop the great GitOps days background for this, but this is a lot of images I'm going to squeeze into one slide. But just to walk everyone through our flow of how this works with 2 repos, that's really what I'm trying to drill home here. So you still start today with the traditional CI/CD pipeline, just like you would for anything to deliver something out into an environment. So starting in the top left, I'll let you guess what our favorite CI system is. Starting in the top left, you have to build your app. You just got to compile your code. You got to push a Docker image up, whatever that may be. And this is a very abbreviated pipeline, forgive me, but trying to fit things on one screen here. So build your code, you want to deploy your code. This might be a kubectl apply if you're just straight up applying in your Kubernetes environment. We actually highly recommend that you use Flux in your test environments as well. So why not? You want to deploy and test just like you're doing in production, so use Flux and test. You probably want to do some security scans. We had a great presentation right before us on Aqua Security. Maybe you're working Trivy into your pipelines here. After that, you get to the very end of the pipeline. And so we've got 2 stages here. I'm going to talk about the bottom stage first. Upload evidence to test is what this stands for. And so we have external repos that just host your unit tests, your scans, things like that for a long retention period. So we can look back and say, this version of the code had this evidence of test to go with it to go out to production. The top box is more important. And so this is not an official tool. This is an internal State Farm tool. We built a GitOps CLI that all it does, it sounds fancy, but all it does, and I don't mean any disrespect to the guy that wrote it because he's an awesome engineer, but at the end of the day, it abstracts all of the complicated kind of Git commands, Git commits, opening branches, opening merge requests, things like that, and just puts it in one tool. And so we're trying to just make things really easy when you're interacting with Git. That's all it does. So at the end of that pipeline, you're all complete. You've gone through the GitOps CLI. And you have that separate production config repo that is locked down. The GitOps CLI will take care of opening that merge request on that repo for you, and it copies all the code that you want over that will go out to production. And so in the case of the Kubernetes deployment, these will be your deployment file, your ingress, your load balancer things, like whatever is required for your app to get out to production, copies that over to this config repo. This is where the normal kind of Git behavior can happen. You can talk about it in comments, leadership can approve it. we actually link the evidence attached to the merge request, so you can view this version of the code has all of this as evidence that can go out to production. And then finally, we enforce the merge approval rules where a member of the leadership team has to approve the change before it's deployed. And so until then, anybody can merge after that, but that approval has to happen first before any merge button can be hit. And so as soon as it is in the main branch or master branch, that's where Flux is watching. And so we talked about this a little yesterday, that you get multi-site, multi-region deployments with Flux, which is awesome. And so with one commit, with one merge and approval, you're deploying to every site at once, and whatever the cadence of Flux is, which is probably every minute. So you've got your deployments going out to both clusters, and Flux will converge on that state in both clusters. So that very high level, that is how our flow works. That's how that repo is separate. And so you might be asking yourself, well, what is a config repo? And so I'm going to hand it over to Perry to talk about what they are and then how we also set them up with automation.
Yep. Great. Thanks, Reese. You're able to hear me just fine.
Sound good?
All right. So we left off on that previous diagram on the config repos where leadership has approvals. So let's talk about that. So what is a config repo? As State Farm setup, config repos point to production. So we have to tightly control the config repo access. So people can't willy-nilly basically approve their own merge requests or pull requests, get them merged in, and have immediate deployment to production. There's certain rules to follow when it comes to that. So that's done by the GitOps team and also through Terraform. So I can show you in a diagram later in the next slide, but I kind of want to talk through it real quick. We have an onboarding app, and that onboarding app is basically a user interface, UI, where a team can onboard a new namespace and config repo. So from that, they would get into, that would kick off a pipeline to Terraform, and Terraform actually controls the user access and pull request approval rules. This will be the repository where deployments will be applied from. And this includes, as we may all be familiar with, Kubernetes manifests. And if you're thinking about GitOps and Flux, for me, Flux is a tool for deploying to Kubernetes, but GitOps is a mindset. So when we talk about the config repo itself, we talk about more than just Kubernetes manifests. If you think about Terraform Cloud with VCS integration or any kind of app you want to support, you want to deploy infrastructure, you want to deploy code out into production, config repo takes care of all of that, and that's where your source of truth is from our perspective. And again, as we saw in the previous diagram, it's not your source code repo. Your source code repo is what happens where you have kubectl apply, you have your build, you have your test, you have your evidence of test, and so on and so forth. So that's kind of our theory behind it, and what a config repo means for us at State Farm. So Race can go to the next slide, thanks. So provisioning config repos, like we mentioned, it's we try to have minimal user input to create because it's a lot prone to error. If you remember back to our previous slide where we talk about 1,000 plus namespaces, if you imagine maybe one team owns maybe 1 or 2 Kubernetes namespaces within a cluster, that's about like 500 teams. And coming from the GitOps, if we were to manually do that, it would be really hard to support. So that's why we chose Terraform to basically automate kind of that portion. So that's what a UI does. It requires minimal user input to create. It's tightly controlled with LDAP synchronization. I'm not going to let you guess what's our favorite CI tool because I call it out in the slide. It's GitLab. We have webhooks for internal reporting tools. So whenever a merge request gets opened, merged, closed, those are all events, and we have our own internal eventing tool. Behind the scenes, it's OpenSearch. So we can do analytics and reporting on basically our automated software change pattern. We have badges to signify it's a config repo, and then we use Terraform workspaces to tightly control access with infrastructure as code to provision exactly who gets to approve the merge request and who gets to be developers and who can see it. And the enforcement right now actually runs nightly, so that's actually not kind of a 100% good place that we want to be. because theoretically, malicious actor or a developer can just potentially add themselves or add someone else and then get their changes in and then before the nightly runs kick in. So GitLab has a really special tool called audit events, and we can kick off basically a webhook based on those events. So those events include changing the provider or changing the approval rules. And it also includes changing who has access and what level of access they have. So what we want to get to in a point is we want to be able to be immediately reactive. So whenever something changes, we want to immediately kick off the pipeline to take away their access and revert to what our infrastructure as code wants us to have. So next slide, please. So this is kind of what it looks like in if you can envision this. I'm not allowed to, we're not allowed to share internal state farm code or anything like that. But if you kind of envision this, Terraform, there's a Terraform GitLab provider out there that allows you to create and provision GitLab projects, GitLab groups, and approval rules, and so on and so forth. So these are some of the example modules. So like for example, in the middle, we have a GitLab project, and it's called Production Repo 1. We have a namespace ID, which signifies where it can, which group is that config repo nested under, and we have a GitLab group. And at the very top, we have approval rules on who can approve and what and basically our enforcement for managers. Our internal modules are a lot more sophisticated than this, but this kind of gives you the idea of how do we provision configuration repos, configuration groups, and enforce that visibility, that approval rules, and so on and so forth on behalf of teams automatically. So that's kind of like a big benefit for this using Terraform as our provisioner for repos and groups. So can we go to the next slide, please? So now that we covered what GitLab config repos are, let's talk about, like, from architecture perspective, how do we manage Flux for a cluster managing over 1,000 namespaces, and how do we enable Flux for individual teams, and preferably through an automated fashion, right? Because again, this would cause way too much toil for our small GitOps team for the foreseeable future if we have to onboard teams manually. So let's go to the next slide, please. So this is kind of the setup. Again, we have another UI pattern. So from the left, the user requests a namespace through a UI. It kicks off another GitLab pipeline. And that pipeline, we have a namespace folder, and this commits templated files. So if I don't know if Race has mentioned this, but we're actually in the middle of migrating from Flux v1 to Flux v2. So you'll notice inside of that namespace folder, we have Flux v1 deployment, which is the individual team level fluxes that I'll show in the next diagram. We have the limit ranges. So what are you allowed to provision? How many resources are you allowed to consume within that namespace? The namespace itself, and some labels apply to the namespace, and RBAC. So that controls user access and who's allowed to have admin access to your namespace in that cluster. That gets committed to the config repo, goes through a merge or pull request manager approval process again, because it's we treat it as production. And then in our container as a service cluster, and in this case, it's basically Kubernetes, we have Flux v2 on the cluster level to sync up with the config repo. And then that will apply basically whenever we do a push or merge the namespace itself and have them all set up as a tenant. All right, so that's a lot. Let's go to the next slide. So I mentioned, like, we're in the middle of a migration, so we kind of want to talk about that as well. So we started with Flux v1. Flux v2 wasn't a thing when we first started this GitOps journey. It's currently a mix of Flux v2 on the cluster level and Flux v1 on the team level. So they're two distinct things, and the cluster level is what we just saw on the previous slide. And the teams, however, can have their own config repos, like how we provision it through Terraform, through our Terraform modules. So we need to link that up so that we have individual fluxes within within the namespace that listens. It's version 1 again, so that's why it has to be separate deployments. That listens to the config repo and it applies on the team level, namespace level. It's initially bootstrapped with the Flux CLI, so I'm sure there's a lot of resources, especially the Flux website. That's public documentation on how to bootstrap your own Flux instance. And then we have the cluster level Flux v2 that manages each Kubernetes cluster in test and production. And again, the namespace level Flux v1 monitors the team's config repo for deployment and deployment changes. So can we go to the next slide, please? Okay, cool. So this is kind of the operations team view. This is another view of what we see as maintainers for that infrastructure within the Kubernetes cluster. So again, I'm sure you're all familiar with this, but we have Flux v2 deployed to both clusters. It applies to both clusters, and it listens to this cluster config repo. Notice in our setup we have 2 folders, one for cluster A, one for cluster B, so they can be drift. Inside of those cluster folders, we have a namespace A and a namespace B, and like we mentioned before, that's where those templated out YAML configs come in. The limit ranges, the Flux v1 deployments that listens to the config repo of the team, and then the RBAC that controls who has access to it. There's a lot more that goes to it behind the scenes, but this kind of gives you the general idea of like our overall structure. So if you look at the next slide, yeah, so this is where what the tenant will see, right? So remember that we deployed Flux v1 into the individual namespace. Now, teams can control which config repo to listen to as long as it's a production configuration repo. So that's where Flux v1 comes in right now as of this moment. Our goal eventually, obviously, is to migrate to Flux v2, provide a pattern for tenants to migrate. But in this instance, basically we have again, I kind of want to break it out to make sure that it's kind of clear. We have a cluster level Flux and we have a tenant level Flux, and this is kind of what the tenant level Flux is. It listens to a team's configuration repo. Teams can make merge requests, get it approved, get it merged, and then eventually have that Git source of truth within their own team. And then Flux v1 then will apply to the individual clusters inside the individual namespaces, right? So next slide, please. So in our Flux v1 to v2 journey, we want to talk about how State Farm benefits from Flux v2. So one of the biggest ones is multi-tenancy, right? So we talked about how it's we kind of see through those diagrams in the very beginning how cumbersome it is actually to maintain one deployment per namespace if we want to segment out teams. Each of the teams will have to create their own Flux instance and monitor that, make sure it's healthy, make sure your SSH keys are up to date, able to pull from that repo. So it's actually really a cumbersome pattern, but when we first started with GitOps. We have centralized management versus multiple deployments in each namespace, and that's kind of what I alluded to in the very beginning. We also have metrics, alerting, and notification providers. So I'm sure you guys seen previous presentations where we talked about Grafana and Prometheus, and also alerting tools that we have now with creating a Flux v2 alert provider and alert. So at State Farm, we use Prometheus to alert. So whenever metric is like too much, for example, cluster reconciliation time is over 10 minutes or something like that, we can alert based on that whenever there's a change in those statistics and performance. We can use OpenSearch coupled with the Flux v2 alert provider and the alert itself to debug all customization events. So whenever things get synced up, when's the last time we had a repo sync, and basically whether or not the reconciliation has succeeded or failed. So Prometheus and OpenSearch, that combined with the performance monitoring and dashboards with the Grafana, it just provides so much more compared to Flux v1. And I would say, however, the main thing is we want centralized management because if you might have noticed, 1,000 namespaces. I know we might not be the biggest one out there, but 1,000 namespaces across 3 clusters for about 500 teams or more or less is really cumbersome and needs to be automated. So that's kind of the lessons learned. So if you can, start with Flux v2. Because when we first started the GitOps journey, Flux v1 was the only thing. It wasn't kind of available for us then. Try to automate team onboarding as much as possible, as you've seen through the UI and kicking off a pipeline perspective. That's kind of our workflow for onboarding new teams and new config repos. And also you can prepare you can make try to make the process as seamless for teams. So if you imagine how much support we need for the teams, it gets kind of cumbersome. And if we make the process as seamless as possible through the UI and through API calls and through templating these files, then we get less support messages and we get less toil on our team. And the last one is you can prepare, but things do go wrong in production. We've seen an instance recently in our migration where we migrated in test just fine, but production, we kind of had an issue with secrets for Flux v1 on teams. So these things do go wrong, but we need to prepare for that. And that was kind of a lesson learned for us in our migration journey. All right, so our next steps, we really want to migrate tenants over to use Flux v2. They can use this. We have that centralized place for management. We have alerting, we have performance monitoring, and so much more with Flux v2. We really want to encourage education and adoption of patterns for Flux v2. So that's kind of our next step in order to encourage adoption, especially since Flux v1 is getting sunset. And that's kind of it. Create documentation, automated migration for Flux v2 for teams to migrate safely and easily, and in order to ensure a healthy production environment. All right, Grace.
Yeah, just to summarize, y'all, to wrap this up, we're almost at time. So really recommend to use a GitOps mindset on everything you do, and especially if you're in a regulatory environment, separate those config repos from your normal development environment to production and have them isolated with rules. And then Perry, I think you'll agree that using Git makes all this stuff easier.
Yeah, for sure. So Flux, I guess the core of it is enables Git as a source of truth. So whatever we have in Git, it gets applied to production. And we want to be able to easily provide multi-tenancy for teams as a cluster administrator. So we really want to be able to have that separation for teams to own their own namespaces and be their own admins in their little namespaces and kind of like a logical separation of concerns. And that's what Flux v2 provides. So the last one is Flux v2 greatly improves observability for all teams, especially with the alerting, the Grafana dashboards, and Prometheus stack that we can have integrated with Flux v2.
All right. And that is it, y'all. Thank you. So like the group's been saying, we'll be over in Slack answering questions if anybody has any.
It's a little strange being on this side of the presentation. I was telling you.
I bet.
There is one thing I did want to add, as weird as this is, but I just wanted to add that one thing that is cool, like a self-promotion, I guess, for my team as well, is that my team actually offers a migration workshop if you are having trouble migrating over to Flux 2, and that is actually something that we took advantage of at State Farm.
Yeah. Okay.
And it really helped out. So if you are trying to move over to Flux 2 from Flux 1, you can take advantage of that option.
Yeah, I think the design of what we're doing came from that workshop, really.
Yeah, exactly. Yeah, it was super helpful. Thank you guys so much. Always a pleasure to see you guys, and that was a great talk.
Thank you.
Really glad y'all are carrying this on. It's cool to see the changes that are being made. So awesome. Thank you guys.
Thanks everybody. See you later.
Thanks. So now we are going to move on to Zscaler. And Tamao is going to actually join on this one too for the end of it for a fireside chat as well. So we have Nita Rathi and Josh Carlisle joining us now. Take it away, you guys. Thank you all.
Nita and Josh, thanks for joining us. Yes, so Nita and Josh have a great presentation prepared, and then I'll join at the end to guide a little bit of a fireside chat. So take it away.
Awesome.
Well, thank you for having us. Looking forward to kind of telling a little bit of our story, a little bit of our journey, right, with Flux at Zscaler. So, as was mentioned, my name's Josh Carlisle, and I'm a principal architect at Zscaler. Nita, do you want to say hi real quick?
Yeah, and I am Nita. I'm a staff software engineer here at Zscaler, and we are super excited to talk about our journey and how we accomplish multi-tenancy with Flux CD.
Awesome. So where to begin? So really kind of, every journey really kind of starts somewhere, right? and for us, it really started with the development of really a new SaaS security platform at Zscaler. So we actually had one of those really rare greenfield opportunities, right? You only get a few of these in your career, right? And so it goes without saying that we had a lot of decisions to make. And some of those decisions were kind of unique to the SaaS space, especially when it comes to things like multi-tenancy, right? So like most modern apps today, right? We are mostly aligned to a lot of the latest cloud-native platforms, including Kubernetes, to which we really kind of deploy a myriad of services deployed to our Kubernetes environments. And we also actually have platform services as well. So a lot of things like databases and messaging and other platforms, the things that you would expect in a modern app, the glue pieces, right? The glue pieces together that are also hosted on Kubernetes. And all of those together kind of make up one of our environments, something we call a stamp. But we also have really some additional complexity from the multi-tenant side of the equation, because we actually have tenant-specific microservices as well, right? And it's one of the ways that we actually can right-size kind of some of our customer workloads and handle some of the common scenarios that you run in multi-tenant environments, things like noisy neighbor kind of scenarios. It's actually worth mentioning that we lean into another CNCF project here, something called CADA, to kind of help us out in that regard. So I definitely go check that out. I'm not talking about CADA today, but it's worth mentioning. But the trade-off of all this power that we get now to be able to do things that we need to do for our multi-tenant workloads, the trade-off is complexity, right? And especially complexity in our deployments, right? So all of our deployments, right, have multiple environments sometimes. They can be shared on a single cluster, like some of our pre-prod environments where we might have multiple dev environments, and also in regards to our production deployments, right? So we have various stamps that are deployed to different geos around the world. So in many ways, we kind of have a tenant of tenant scenario, right? So we have tenants in the standpoint of multiple environments, and we also have multiple customer tenants within those tenants. So it goes without saying that we have some complexity, right, to deal with. And we started out a bit of our journey with a little bit of a homegrown solution, right? A lot of organizations do this. A little bit of a hybrid deployment, right? The solutions that kind of a combination of Helm charts, a little bit of GitOps actions, and in some cases we were actually using the Kubernetes API, deploying things through code, right? But we really knew that this wasn't going to be a long-term thing. It wouldn't be long-term viable. It wouldn't be as robust as we need it to be. We knew we'd be have probably some maintenance nightmares, right? We didn't want to build this initially, right? So most of our experience on our team comes from traditional platforms, and my background's Azure DevOps. We've got folks on different various teams. I've worked with Jenkins and Bamboo and all the different stacks that are common in these kind of conversations. But we really kind of started asking ourselves a question: we've got this modern stack. Are there any approaches that would kind of give us a first-class experience within Kubernetes? And interesting enough, we actually briefly, we didn't quite learn our lesson of building it ourselves, and we very actually briefly explored some more custom solutions targeted towards native on Kubernetes, using things like custom controllers And that's actually where Nita became involved a little bit with the project and had a good take on that effort. Maybe Nita, do you want to mention something about that real quick? Because I think it's interesting.
Right when you think that you can write controllers, you realize there's so much more to it. You got to manage the CRD state drift, graceful termination, event notification, just to name a few. So writing a matured controller takes time, experience, and the right skill set. And that's where, like, Flux comes in. Flux controllers handle all of that, and the active community like Fluxes, where all your questions are answered with a really short turnaround. This amazing Slack channel, like, with sometimes you even get valuable advice to your particular problem. That's when we started exploring Flux.
Yeah. So part of this journey was a lot like other folks' journey, right? We explored a lot of different options, right? We explored traditional options. We explored homegrown stuff. We explored more complex homegrown stuff, as Nita mentioned. But through that journey, though, it was all very useful because as we started talking about, hey, these custom controllers, wait, there's platforms out here that have already taking care of this complexity. They're solving it in the same kind of way that we wanted to solve it. This desired kind of state scenario was something that was really attractive to us, as opposed to the push model, right? And things can change afterwards. Things can start deviating, and we didn't want that, right? So as we started to explore Flux more, it really started to really check a lot of the boxes for us, especially the multi-tenant support that was really important to us. Some of the built-in native support for Helm charts, something that we already kind of had made an investment in, and we weren't relishing the thought of telling all of our engineers and all of our DevOps teams to completely move to something new. So it kind of allowed us to retain a lot of the work that we put into some of the original efforts. But that's kind of really how our journey started. So kind of, with that context. But what, I'm going to pass this over to Nita now, and she can share a little bit about kind of where we landed and what kind of our journey and what we learned along the way.
Right. Yeah. So as you can see in this slide, like, most of our workloads are Helm charts, and they are getting deployed into a multi-tenant environment. And we were doing things off of a single repository, like, our deployment repository. It had everything, like, it had definitions of environments, it had definitions for microservices, Helm charts, infrastructure definitions, everything's off there. And what we had before Flux actually worked for us, but was it efficient and met the best practices for cloud native ecosystem? Probably not. And we were fine with it for a brief amount of time, because we were in this fail fast mode. But we were in the process of moving our Helm charts definitions closer to our microservices. We were in the process of transitioning them, pushing our Helm charts to ECR. And when Flux came in, it all made a sense, and it all made a very simple and flexible for us. So what we have at the moment is we have multiple repositories. Josh, if you want to take me to the next slide. Yeah. So what we have is a microservices repository. Those individual repositories are still there. We didn't touch those. What we did is we added 2 additional repositories. One is the subsystems configuration repository. That's where we configure all our microservices. Like, that's where we have our Helm releases and Git repositories and so on and so forth. And we have the Flux cluster repository. That's where we have our cluster definitions, our tenant definitions, all our infra, everything's there. What we are also using Flux for is updating our image tags. And we are also configured it, obviously, to give us notifications both on Slack and giving us a notification back to our GitHub repository to what happened to that commit, whether that commit reconciled or it errored out, so on and so forth. Our DevOps is monitoring the Slack to see what's happening in the cluster. And additionally, we are also pulling some dashboards from Flux 2 repository, and we have some our homegrown dashboards. And that's how we are monitoring our cluster state. And ideally, this is where we would like some of our pain points being taken care of. Maybe having some dashboards in there, like, some tool like GitOps from Weaveworks. So visibility is something that's we are still struggling with. We wanted like a one-stop shop where we could monitor the drift in the cluster.
I think it's worth mentioning a little bit. Would you consider that kind of our biggest pain point? One of our bigger pain points was around what you just mentioned, a little bit of visibility and things like that.
Yes.
Yeah.
Because setting things up with an amazing documentation there and the help from the community, was straightforward. Like some of the talks really help us put this all together. However, at the end of the day, when DevOps asks you, okay, give me that single pane of glass, where do I see my cluster? Okay, I see all the events, I see all the alerts on Slack, I see some dashboards, but like a single pane of glass, that is something that we definitely have a big need for. We've used Grafana dashboards. We've also used Argo CD, a UI to display our Flux workloads. However, we are not very satisfied with any of the approaches that we are taking. So I guess we have more room to improve there.
Awesome.
Yeah.
Yeah, no, go ahead, Nita. Sorry.
No. I was going to just talk about more about the multi-tenancy use
Yeah.
in the next slide. So essentially, what's happening here is what we have, as Josh mentioned, we have tenants of tenants. So we have different environments on our cluster, and each of those environments have multiple tenants. And Flux lets us configure those really easily. Up until we had Flux, our tenant lifecycle was managed by some workflow, some workflow that one subsystem is doing something to that, yet another subsystem is doing something else, and so on and so forth, and it worked. However, it was not transparent. It was not something that we could track. It was not something that was easily understood across our different teams, right? So what Flux lets us do is really having it traceable and trackable right there. So our tenant onboarding is nothing but creating a new folder on the repository in a particular environment. Our tenant upgrades is going ahead and changing, adding, removing all of the manifests that are there for those tenants. And then our tenant offboarding is something I love the most, is just going ahead and removing a customization from the tenant YAML and just going ahead and deleting the folder if that tenant is not used across any of other environments and in clusters. So pretty straightforward out there. What it also lets us do, for tenant of tenants environments, is we are highly customizing our subsystems YAML, and we are using patches. It lets us define what namespace we want to put in, what our Helm releases are called, what our chart names are, and so on and so forth. So it lets us do all of that customizations on top of what we define on our subsystems configuration, and it's pretty visible. It's out there. We could see who made that change, what time that change made in, and if there is something that really go wrong, we can always come back and revert it by just issuing another PR. So it works out really great for us.
And I can't emphasize enough from the standpoint of the kind of problems that we're trying to solve and the way in which we're solving them on our platform through some of our customer-specific workloads. They're really important for our platform, but as Nita mentioned, the way in which we were initially doing things was fairly fragile, right? And it didn't necessarily support all of the kind of life cycle that we wanted to be able to do in regards to in regards to how we want to deploy. We'll talk about it here in a short bit here, but as you start kind of peeling back the onion of things that it needs to be able to do, even things like being able to do canary deploys and all those kind of things just became very, very challenging. So for us, when we were looking through for various solutions, especially being a SaaS provider, right, and having what is probably considered a little bit of a relatively unique architecture for some aspects of our platform, that for the native support baked in, right, to the underlying platform to kind of handle all these use cases that Nita was mentioning, from onboarding to updates, to, at the end of the day, offboarding, right? Trial customers who go to production, we get rid of old stuff, things like that, right? That it really just kind of seamlessly handled those in a very, very elegant way. And it's going to make our platform overall a lot more reliable, right? And more consistent experience when we're doing our deployments, and even better so, consistency of not doing customer specific deployments in one way and deploying everything else in a different way. To go back to this previous picture here we have here, we still have your traditional microservices. We got 150 plus growing, and new releases, and that number's going to grow. We're pretty early, pretty new platform, so that's probably going to increase a good bit. And those are what you would traditionally expect with normal deployments, like they're shared services. But when we have these tenant-based microservices, there is essentially a template, right, that we want to apply for every customer that says you get your own little versions of these guys in our key kind of data pipeline areas where we want to have more dials and knobs to avoid things like noisy neighbors and a lot of other stuff. But if you consider it, that means our deployments exponentially grow, right, in complexity as our platform grows. You have 500 customers, we're going to have 500 times 50 of these things, right? And to do this kind of deployment in any way that has any fragility to it is just a huge amount of risk, right? So this for Flux, it's de-risking this whole process and allowing us to kind of get the benefits that we want to be able to get from being able to have the dials and knobs to kind of control our tenant pipelines, but without all the risk of all the challenges when it comes to deployment. So I was pretty happy when Nita started doing a lot of her explorations, right, and started coming up, and it was just, like I said before, it was to start checking every box, right?
Yeah.
But yeah, so I think so kind of really what's next for us, right? So we're a little bit earlier in our journey. So we've only partially rolled out this to our platform, and we're going to continue to roll this out to everything, right? And that's actually one of the benefits that we found. I think in general, sometimes there's hesitations to take on new platforms that offer some value because you have, I don't want to call this legacy because it was only live for 2 or 3 months, because once again, this is kind of greenfield, right? But you're kind of worried about, oh, I'm already doing this now. How much do I have to do a big, risky, massive switchover, right? One of the things that worked out well for us is that we're still doing some things the old way, and we're doing some things a new way, and we've been able to successfully start incrementally changing this, and that's important to kind of de-risk things, right? So we're going to continue to roll this out to our entire platform, and also, one of the things that was important to us as well, once we got this foundational piece together, is that like any other platform, we wanted to explore different ways of our deployment strategy, right? Like many organizations out there, we kind of use a mix and match of kind of canary-like deploys and feature flags and a little bit of both, right? Depending on the use case. But there's a lot of complexity in doing like A/B deployments and feature flags and stuff like that. So I'm not feature flags, but in A/B deployments, canary deployments, all of that kind, right? And especially considering our customer-specific deployments, right? Think of it, it gets exponentially more complex. And so we're going to start exploring a little bit more of different ways that we can do and accomplish some of those deployments, especially around Flagger, right? And I think there was another talk today at Flagger, or there will be. I think there was it's on my backlog to probably watch the recording. Yeah, it was early in the morning. So we're looking forward to kind of exploring Flagger. I think we're also, like everybody else, we know a lot of these platforms move quick, right? We know that there's sometimes there are improvements, sometimes they're fixes, sometimes they're security fixes, when you have something as important to this as it is to our platform, you're always hesitant to rev something. Are we going to break something, right? Or how do you do that? Or it's really complex, like it's a heavy lift, right? So you end up with environments that are just like versions and months out of date, right? So we don't necessarily want to get into that kind of pattern with this. So we're going to start exploring some of the Flux auto update. And as Anita also mentioned, I think no platform is perfect. We're very, very happy, right, with our journey so far in Flux. One of the things is we have a worldwide distributed team. We have DevOps teams around the world, and visibility and understanding the health, right, is really important to us. And like many enterprise organizations, we have requirements about how the tools and the administrative consoles of these platforms must have. And so maybe talk a little bit more about that, because I think that's worthy of talking about, because this is really important for everybody. And I think we came to a pretty good middle ground. There's room for improvement, but I think we got a pretty good middle ground. Maybe talk to that a little bit more would be useful.
So we're using Grafana dashboards at the moment, and we are using Slack notifications. Obviously, we would definitely need advanced security, having SSO and visibility as in terms of doing the drift. Like you see what's on your Git repository, but then can you say 100% that this is what the cluster has it? Because sometimes if you have failures, and then if one of the hem releases is failing, how do you 100% say that this is not what you have on the obviously Flux tried to sync it, but something went wrong. So we are definitely going to explore some of the tools for that.
So that's kind of like really kind of our story, right? A little bit of our journey. It's a relatively new journey for us, right? And I think that's probably the last meaningful thing that I'll mention, and then maybe we could open it up for some general questions, and happy to go into some more details and kind of more in the fireside chat. But I think our journey kind of started just a few months ago, right? So some of these systems you think, oh man, they've been doing this for months, and their teams have been exploring this, for months and months, and it's a lot of effort. We've actually accelerated kind of our adoption of this whole platform pretty dang quickly, and we've been able to do so. I think because inherently, I think the platform has is easier to use. There's good,
understand the documents, the help on Slack channel, active community, everything is a huge plus. Yep. And I see Tamao here. That means our time's up.
Awesome. Yeah, you actually talked for the whole time. And yes, there's a slight delay from the video. So as we've mentioned, please post your questions in the Slack channel where we can continue to address them. I know because of the YouTube stream, you could hit pause, you could watch it later. We'll continue to have the stream up, and so we'll alert our fantastic speakers sharing their fantastic story if you roll in questions later, so no rush at all. So I just wanted to kind of like look at my notes and just really highlight, because your talk was so jam-packed with amazing things, but I really love your emphasis on transparency and how Flux helped to bring that with multi-tenancy. I love the onboarding and offboarding part of that. That's a really great way of sort of explaining how kind of streamlined it feels like that process got. And then the earlier fragility and risk of deployments, that seemed very helpful to sort of hear how, that was something you wanted to address, and hopefully your continued journey on GitOps will help with that. I guess I was hearing for the first time too, the kind of the challenges of canary deployments. That is exciting to hear. You'll continue to go on that path, and it feels very essential, and we're very excited to continue to work with you and hear about that. And then, you're repeating of reliability and consistency. So you have all these different types of deployments, but having consistency across how they're all doing it. That's a great thing to emphasize. So thanks for being so organized is essentially what I'm saying. It's a very organized talk, and to it's funny that, you're like, oh, we're so early, but it feels like, we chatted because we met in the Slack channel, and it was really great to, get to know people. So it's great to see how you really are accelerating your path to GitOps.
Well, thank you for having us.
Yes.
Thank you for letting us share our story.
Absolutely. And it's so great to see you again. And we appreciate it very much. We will see you again. Thank you. So with that, we have another live musical break, live from Berlin, which now is nighttime for sure. And we got Daniel Holbach ready to bring the music. Pinky, you ready to dance?
Yeah.
All right. So just to let you know, we have fantastic music, but we are wrapping up our day with additional fantastic Flux users. Don't miss, you must join. We're so excited to have Yvonne from Ring Central, who will be joining us right after the break. Many of you know Jason Morgan, of course, we'll be talking about Linkerd. Kingdon and Brian Oliver will be talking about particular Flux use cases. And then we'll finally end with really, really important content on policy management and GitOps. And that will be our day. And we'll be able to do a great photo and enjoy a wrap up with music. And wherever you are on the planet, you'll be able to pretend that it's your nighttime and dance away. So for now, we'll have a brief break and we will close with those fantastic talks.
getting massive bill. Fronting like we homies, saying that you know me when I was really hurting. Y'all would take the Copperfield. Where we all at? We all can stay there then. Where we all at? Where y'all can stay there then. Here we go. Fool me once, shame on you. Fool me twice, I'ma cut you off. Time or currency, I don't waste on many mistakes. I'd rather golf. You be you, I'ma be your boss. Put in work, but you rather floss. Waiting for your time to come while you watch me running like Randy Moss. Blue 87, run the route. Made in heaven, watch me catch it left-handed. In my right, go to your helmet and I run it down the field. Matter of fact, when I run it, I David Copperfield. Old friends, new friends, tell me how you feel. Hating on the hustle, cause it's getting massive bill. Fronting like we homies, saying that you know me when I was really hurting. Y'all with David Copperfield. Where we all at? Y'all can stay there then. Where we all at? Where y'all can stay there then. How do y'all sleep at night talking all that mess? If you wanna say something, say it with your chest. But if you really want something, want it with your mind. Take the energy from your jealousy and just put it up in your grind. Southside hustle, getting bundles like we chopping wood, bringing all the healing to your ears like a doctor could. Ferris got me fearless with awareness of these leeches that be swearing that my features kicking lessons like some teachers, boy. Old friends, new friends, tell me how you feel. Hating on the hustle, cause it's getting massive bill. Fronting like we homies, saying that you know me when I was really hurting. Y'all with David Copperfield. Where we all at? We all can stay there then. Where we all at? Where y'all can stay there then. Here we go. Where we all at? Where y'all can stay there then. Where we all at? Where y'all can stay there then.
Is it worth it? Let me work it. I put my thing down, flip it and reverse it. It's your primitive plan yet. It's your primitive plan yet. If you got a big, let me search it to find out how hard I gotta work. Yeah, it's your primitive plan yet. It's your primitive plan yet. This the kind of beat to go. 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 Ba ta ta. I like to get to know ya so I can show ya. Put a hurtin' on ya like I told ya. Give me all your numbers so I can phone ya. Your girl acting stink, then call me over. Not on the bed, lay me on your you're so fine. But before you come, I need to say my job.
I love all the creative mixes. I was not expecting that one. I was like, oh yeah.
That was pretty awesome. I was actually over here grooving the whole time.
Yes, so as I mentioned before this musical break, some of the best for the last. But really, it's been such a strong event, especially Pinky's talks. So yes, we are very, very excited. Pinky is here with me, co-emceeing, so excited. And we are very happy to have our final speakers who are really sharing fantastic, fantastic stories of their experience, starting with Ivan from Ring Central. Thank you for joining us. I'm very much looking forward to this fireside chat. So thanks, Pinky. We will take it away. I will share a slide that I kind of put together to guide our conversation a little bit. Can you see it? Excellent. Hey, Ivan, how's it going?
Hi. Very good. How are you?
Yes. So first of all, want to mention again, thank you so much. We chatted because I noticed that you added Ring Central to the Flux adopters page, as well as I think to the Flagger adopters page too, right? Which is why we're talking about Flux and Flagger. And I said, oh, thank you so much. It's so great. It's really, really great to see, every week more and more companies adding themselves. And we've been chatting with many people in the community as well. And that's what's culminated in all these really fantastic stories. So just think about there are many, many more to come. So many different use cases, so many different needs, so many different industries. And so it's really exciting to hear how people are getting creative with Flux and depending on it and finding it very useful. And so, Ivan, I really appreciate your taking the time to chat with us and to join us today at GitOps Days.
Thank you.
Yes. So let's get started. Yeah, you are very, very passionate about GitOps, about Kubernetes, about Flux. We had a great conversation. So yeah, tell us about the bigger picture. Yeah, your journey with Kubernetes.
Yeah, so we started our journey. So first of all, I want to thank everyone who participates in this conference. It was great talks all day. I watched every talk and yesterday, and I will watch every talk today, thanks to YouTube. I can record, I can pause, I can get back to it. So I recommend to everyone to do it. It's fantastic. It's so fun, so useful, so informative. And so Ring Central. So first of all, I work in Ring Central as director of engineering, but I worked in Ring Central and other companies at different roles, as a software architect, as a team lead, as a software engineer. And as for Ring Central, I just quick overview what Ring Central does. Ring Central is it's a big enterprise company with a lot of regulation, like a State Farm. Maybe even more regulation because we double in communication field. So we provide messaging, we provide video, and we provide phone services to our customers. And we have tens of thousands of businesses and hundreds of thousands of businesses who use Ring Central and millions of users. So it's a very big infrastructure, a lot of servers. We provide our services in North America, in Canada, in Europe, in Southeast Asia, and basically around the world in Australia. And we started using Kubernetes in Ring Central in 2015. So at very, very early stage when the Kubernetes was just a version 1.1 or 1.1 or 1.0. And we, at the time, we basically thought how we can implement a workflow which will help us to drive our development, because Ring Central has a very long history in software development, not as long as the State Farm, not 100 years, but for software companies, pretty big. And we have a lot of legacy systems and very different kinds of approaches across our company. So we started with waterfall processes, some of agile development, someone tried to adopt DevOps style. So we thought what we can do, and we basically what we really want and what we really promote in the company is trying to adapt new technologies as early as possible to see how they work, to see what we can do with them. And basically, when we started to look into Kubernetes in 2015, we started to use it in production in 2016. So we had the first production workloads. And at the time, I basically became familiar with Weaveworks because we tried and we used Weaveworks controller for networking. So it was a very difficult time for us to the early stages, but we managed. And right now we run multiple Kubernetes clusters in multiple regions. So we have Kubernetes cluster running in our own hardware, which we set up. We manage ourselves. We run Kubernetes cluster in Google Cloud and as a part of GKE, and in Amazon as part of EKS. Yeah, so definitely a lot of experience with Kubernetes. Made a lot of mistakes, and we will make a lot more. But it's a journey for us. Yeah. So this is how it started in RingCentral, and how it will continue, and we'll plan to use Kubernetes in more and more in our company.
Yeah, it's great to find a camaraderie in such an early adopter, because I think Weaveworks started around that time too. So we were a small startup, and we could still say like, but we've been using Kubernetes in production maybe longer than most people, because we really got in there early, and you know, our Weave Cloud product had been on Kubernetes from the start. Yeah. And I'm really glad to know also, because a lot of people, so I've been at Weaveworks for a while now. I joined like not one of the first employees, but fairly early. And it was really interesting that, you know, in the early days, everybody said, oh, nobody had heard of our company. But when we went to places where people say, oh, we know what we do, it was WeaveNet, right? And as you can see, you know, we've developed on our various projects and our GitOps journey. And so it's great to hear that WeaveNet still helped in our kind of validation, right? You were saying that like, well, okay, I can trust the company that's behind this thing that people have been using. So that was really gratifying to hear. So yes, okay, so you've been early, and now you know you were saying that like kind of a small component right now is on Kubernetes, but you're very committed and you're interested in the next stages, right? Especially with key needs that you have. I think some of them that involve like scaling, right?
Yeah, exactly. So a small component is relative term, because right now we're running about 200 clusters, Kubernetes clusters, and it's thousands and thousands and thousands of deployments running on them across all regions. Just the scale of the company, it's in the scale of the company, it's relatively small because we have our own data centers, which runs like immense amount of workloads and managed by all kinds of solutions. So yeah, but the scaling, what we want to do, we want to really scale Kubernetes to all of our workloads. It's meaning we're going to run thousands or 10,000 of clusters, and it's most likely will be a quite difficult task, especially with such diverse product as we have in RingCentral. But it's something we are ready to do. It's something we committed, and we are moving in this direction. And what I want to like maybe make a little bit more like clearer focus is like I said, development practices in RingCentral. We have different types of development practices. And as one of the, I was already said before, so the GitOps is a mindset. For me, it's not like a GitOps is a mindset, but maybe a level up higher, it's a DevOps is a mindset. So what we're trying to adopt, and we are adopting it, and started to adopt it back in 2015 as a DevOps, as a process, as a mindset. So our development practices is, and what I mean by DevOps as a mindset is what it's concentrated around the ownership end to end of the product, the build teams. So it does not, we basically do not have, aim not to have dedicated DevOps team who prepare infrastructure and manage infrastructure. We're trying to make sure teams, development teams and engineers work closely with engineers who work on infrastructure, and we are basically in the same boat, and we're maintaining and creating and providing the tools for our teams to manage this infrastructure. So this is something we successfully implemented across the company, and yeah, so how does it work? How it is important? What is important in this regards for us is we. So first of all, because teams and should because we owning end-to-end infrastructure end-to-end, meaning we also responsible not only for development, but also for testing, for deploying and maintaining the product. And here in this big picture and designing it as well. Yeah, so designing, creating, maintaining, testing, etc. So we're fully responsible. And when we're managing even support tickets, yeah. So if something happens, we are responsible to maintaining this product. So GitOps here helps us very clearly. So we adapted the GitOps here to make sure we can see it, basically move the developers closer to the maintaining. It's not as clear and when you're trying to see and trying to get it at the first, but when we moved to this direction, we basically discovered very clear benefit in what developers right now, we have full understanding and clear picture of what deployed in production, what is desired state in the production, and we also can and we maintaining our own manifests, we creating merge requests, we maintaining resources, etc. We are no longer detached from the production and running system. We are now part of the system. So this was one of the many benefits GitOps gave us, and right now we're trying to expand it a lot more inside the company.
It's exciting. Yeah, and in that you were saying that you have some key needs, right? Like horizontal scaling, managing dependencies. You mentioned mono repos a little bit. Can you share a little bit about these key needs that you are kind of what do you call it, like required, and how is GitOps and Flux helped in this way?
Yeah, sure. So I'm big believer, first of all, I'm big believer in mono repositories, and I'm big believer in atomic updates and atomic state. So what we have in a company and what we're doing everywhere, where we adopt GitOps pattern or even just DevOps pattern, we have huge mono repositories. These mono repositories allows us to see the whole infrastructure at a glance. So we have multiple clusters, every configuration lives in one repository. And it's on two levels. So we have two mono repositories, one for code and one for configuration. So it's a GitOps repository and the code repository. So the code repository is also a mono repository, which we using to build and container images. And to build the container images, we utilize Bazel. It's a build tool, which very powerful build tool developed by Google. And we're also using Nix to create this distro, and we created distro images. But the main thing, like main purpose of this code mono repository is to create images, nothing else. And then we have GitOps repository, which have all the infrastructure described and declaratively what our desired state are for every environment. And because we have complicated system and a lot of our components are intertwined, interconnected, and we have multiple requirements, or maybe some component can depend on version of another component, and it can be very, very complicated in terms of configuration, even secret management as well. So a mono repository and Flux especially helps us to maintain this atomic state. So when we do an update, we know exactly when we go to desired state, it will not come from two different sources, and we can synchronize this update and see it at glance. So as we're using a merge request as a change management. So basically, in every enterprise, almost a heavily regulated enterprise, you should have observability, traceability for audit reasons, and change management is one of those. So we're using a merge request basically equals to change management request. So we know everything. Git helps us really, and that was already touched in today's talk. It helps us to facilitate this change management process in a way it's clear and it's undeniable source of truth. So Flux is a centerpiece here. It gives us opportunity to implement this kind of workflow without any imperative pipelines or pipelines which do change state in an unpredicted manner. So essentially what we want to achieve is to have fully Git-centric approach, which fully describe our state, and we want to have this source of truth living in one place, like what we can analyze, what we can work with it. We can create tools which can do additional security scanning, and it's very useful, very important for us, and it helps us to manage very big infrastructure. And from the even management perspective, before we tried to adopt it, we had multiple multiple teams maintaining and delivering system. Like we had delivery teams. But with GitOps, we do not need a delivery team. Yeah, so we just need to make sure the changes are synchronized, and we trust Flux to synchronize these changes for us. So we are operating Flux from version 1.0, and right now fully transitioned to version 2.0, and not zero. I mean 2 point something. And it's proved for us it's working quite well. There's always hiccups and something, but it's early adopters. There's always some problems, but we are not interfering with our workflow in a way it does not allow us to do what we want to do.
Yeah. And I'd like to emphasize what you mentioned a couple times now, right? Depending on your industry, just there are regulations, and so this process just helps to. There's the transparency already in the process that then makes you compliant, right? Or at least helps with the compliance for those regulations.
Exactly, yes. It's very big, like in every big enterprise, in every big company, it's very hard question. It's not easy to answer, and it's compliance, a lot of different systems, and security as well, and part of the security, part of the compliance, and Flux makes it so much easier. So it's like GitOps as a process and the Flux as a tool, which allows us to implement this process, makes life much easier. It's just a better tool. I mean, even if you when we talk with our compliance officers, chief compliance officers, and our auditors, it's just so clear what GitOps allows us to make much more auditable changes, more compliant changes than any other tool. Because before we had like change management process, which we need to describe what changes we do, but it was done by human. So if you want to do something, you need to go and check what human performed exactly stages described and not did something else. And also you need to give access to the human, to the person, to the system, maybe give them root access. It makes so much more difficult to reason about these changes than if you're using GitOps.
Yeah, absolutely. And you mentioned this, but we have to appreciate that. In the decades that RingCentral has been around, that's technology that has to get updated, and not just technology within RingCentral, but the technology within the larger fields, right? So it's really impressive to see your commitment and RingCentral's commitment to modernizing always and leveraging the tools that we have in the CNCF and elsewhere. So it's such an exciting story. So with that, I just wanted to check in if you had other things you wanted to touch base on before we talk a little bit more about progressive delivery.
Yeah, I think we can talk about progressive delivery, and if we can always circle back. It's like a live conversation. So if we have maybe some questions, I can try to answer on live. So we'll see.
Yeah. And I'll bookmark a second, because it's progressive delivery is still a new term. So if it's the first time you're hearing it, it's kind of become more and more a used term to reflect things like canary deployments, blue-green, AB. It's sort of like people started listing out all of those, and somebody, I think it was a friend of ours, was saying like, well, what about progressive delivery? So that's what we mean when we share that. So yeah, so how are you using Flux, Flagger, Istio, exploring this space?
Yeah, so this is very interesting and important question for me, because part of the progressive delivery, we had a lot of talks in this conversation and in this conference about the delivery itself. But for me, like if you like DevOps, you end to end, you also have this process called quality assurance. And the quality assurance is could be very complicated, especially when we started to trying to use this GitOps pipelines, trying to automate it as much as we could. We quickly found out what the quality assurance is a really big part of this process. Yeah, so in terms of if you do not have robust quality assurance set up in terms of testing and maintaining, you will most likely will hit the wall in terms of how rapidly you can update and what you can do with it. So you will still have to do some manual testing, and it will slow it down. So tools like Flagger, which is fantastic tool, it's helped. Like I just want to say, if you have service mesh set up in your cluster and you do some Kubernetes delivery, just use Flagger. It's only like, even in its basic form, it's only benefits you. So it gives you ability, and you can start using Flagger from where it like just to check if your container not crash looping and it switches traffic for you. When you can progressively add additional checks, you can use it for canary analysis. You can do add integration and post verification checks. It's fantastic. So in terms of progressive delivery and as overall, we in Central using like multiple tools. And what additional like not only Flagger, of course, because we're trying. I'm a big believer in house engineering as well. So, and I will try to tell you why. Yeah, for example, what house engineering and maybe tools like Flagger is important, because I'm a software engineer, software developer in the past, and right now I still feel like a software engineer. And as a software engineer, right now we are lazy. We are trying to cut corners every way we can. And if you can force, so you need to create an environment which forces software engineer to adhere to specific practices. So how do you do it? You can try to get around, stay behind the engineer and trying to tell them, okay, you need to write more tests. Okay, this is not covered, etc., etc. But it will most likely, we will find way around it. There's always path of least resistance, and engineers are smart way know how to navigate here. So what we're trying to achieve, what we're trying to do, is to put the engineers in an environment where they cannot just cannot cut corners. So for example, chaos engineering. You put the engineers in the environment where everything can fail, even in production. Containers can restart, systems can fail, and they just need to know, they need to implement high availability practices. They need to think how we're going to recover from the disaster. So for example, Litmus is a great tool which allows you to set up inside the Kubernetes cluster. We also need to know what they cannot really have like blocked testing, manual regression testing. So when we deploy something in the environment, we need to make sure we're part of this deployment, because we use Flagger, and Flagger we use Flagger to verify the deployment process as a post verification, as a canary analysis, will fail. You will not be able to deploy. You will not be able to progress your delivery if you do not have, like, if your system does not conform to the specific policies and specific tests you create. So this pipeline allows us. So basically, yeah. So it allows us to create the environment for engineers where we need. So we just basically need to write tests. We need to think about architecture, overall architecture of the system, how we're going to deploy it, how we're going to work with changing state, updates, and progressive delivery. And we do it everywhere. So we have, like, it's set up from the lab to stage to production. It's a continuous pipeline, and basically, yeah. So this is one of the most important components. When I talk inside the company about Flagger and Flux and all the stuff, I always basically, I always think about how does it really focus on Flagger. So Flagger is a great tool. You're going to hear a lot more about it today.
So thank you so much. It's just really gratifying that, as people might have known at the start of today, with Stefan Prodan, who's on our team, who created Flagger. That's what Stefan does. It just says, oh, this weekend I started a thing, and then a couple weeks later, I don't know, it just seemed like something cool to make, and now it's a whole phenomenon, and it's in the CNCF, and it's so great to hear you really finding use from it. So I noticed we are at time, so thank you so much for taking the time to sit with us, and again to add Ring Central to the adopters page for Flux and Flagger, and I'm sure we'll have many more conversations to check in again on your fantastic GitOps journey. So
thank you. Feel free
thank
to
you.
ask questions in the Slack. I will try to answer all of them.
Absolutely, yes. Great
Thank you.
reminder. So we'll be monitoring the GitOps Days Slack for days and maybe weeks to come, because people can watch at their own time. So we'll make sure that we ping Yvonne if there are any questions. So thank you, and thanks for watching us today.
Thanks.
Bye. So Pinky, you are here to introduce our next speaker.
Yeah. Sorry. So our next speaker is Jason Morgan from Buoyant, and he's going to be telling us about using Linkerd and Flagger together.
Jason, whose hair changes a lot every time I see you. you have many looks.
Yeah, I gotta do something. I'm staying home all the time, so that's the only thing I get to work on.
Have you learned how to give yourself a haircut? That's the COVID thing, right?
Yeah, although it's turned into a lot of mullets.
Oh, wow. I did not see the back. I'm glad.
I'm so glad you showed us that.
We would have never known.
I don't share that all the time. But
That's amazing. Wow.
Sweet. All right, that'll be the next Linkerd t-shirt, which I have, by the way, from Los Angeles. Cool.
So go ahead and start?
Yes.
Yeah, awesome. All right, well, let's start by sharing screens.
I'll just see if I can give you a share screen thumbs up. Yes.
Okay, can everybody see this? It's a whiteboard looking thing with a...
Yes.
Great. Awesome. So I want to kind of talk about what it is that we're going to talk about today. So first off, hello everyone. I'm Jason. I talk about Linkerd for Buoyant, the company that makes Linkerd. I think it's great. I'd love to tell you why it's great, and feel free to hop over to buoyant.io if you have any Linkerd questions or you want to hear about Buoyant. So with that, let's go into a quick demo. So I'm going to show you today how to use Linkerd with the Nginx ingress and Flagger to add some capabilities or do a type of progressive delivery that isn't available in the SMI functionality with Flagger and Linkerd, but that we can do anyway, because with Flagger you can do like canary types or rollout types with your ingress. So here's what my environment looks like at a high level. I've got the Linkerd control plane, I have a Kubernetes cluster, I have an Nginx ingress, and I've got a pod info application. So Nginx is talking to pod info and it's sending some traffic over. Now we're going to add in Flagger into the environment, which is going to change some things. So let's look at that new version of what we're going to see once we get Flagger in there. So first off, I add Flagger and connect it to my control plane, and it gets permissions to do a bunch of stuff in the environment. It also is able to talk to Nginx and create ingress resources. So what I'm going to get here is Nginx, instead of talking directly, well, Nginx is still actually going to talk directly from Nginx to the pod. So the basic flow doesn't change, but there's some new decision points. So this canary object is going to come in, and it's going to instruct Nginx that when it sees certain criteria, it's going to use an ingress and to change a new ingress to change where traffic gets routed to. So instead of going from Nginx to pod info, it's going to, under certain criteria, go from Nginx to pod info canary, that's the Kubernetes service, to the pod info canary pod. I hope that makes sense. If it doesn't, feel free to make a message in the Slack or put something in the chat here if we can do chat in this, and I'd love to address it as it comes up. So yeah, let's kick off by doing a little demo. So here I've got the pod info application that a lot of you are probably familiar with. You can see, someone can give me a thumbs up that the text looks big enough. You should be able to see on the left-hand side, I've got a watch running at the bottom right or bottom left, which shows you what's going on in the pod info namespace. So I've got a traffic generator and I've got two pod info pods. On top left, I've just got a blank thing, and here on the right, I've got the pod info application. We can go into Linkerd. We can take a look at our different namespaces. If you're curious, go to dashboard.civo.59s.io, and you can actually follow along with what we're going to do live. We can see here, Linkerd sees that there's another, there's a pod info primary deployment and an empty pod info deployment. This is what we've created with Flagger. Once we created this canary object, we get one new deployment, one for the new version of pod info, one for the existing running version, right? And to go back from our diagram, what we're going to do here is we're going to put an update to the pod info deployment. It's going to effectively update pod info canary, and we're going to get some new pods. And traffic for our test users is going to run from Nginx through to pod info canary. We're going to use Nginx's capability to do header-based routing at the ingress to actually get this kicked off. And so with no more hype, let's do it. So micro patch. So I've got a patch file. This is the changes that I'm going to make to pod info, right? And we're going to change it from, the basic cuttlefish logo to, we've decided that we really want the Linkerd logo on our pod info site. And actually, you can see this yourself too. If you go to podinfo.civo.59s.io, you'll see this app changing as we go through the process. So I'm going to save my changes. I'm going to get out. I've got a new addition I've got to make, so I'll do a git commit. So I've changed the logo, so we're going to go ahead and add that to git. We're going to do a push. Because we're using Flux with Flagger, because why not? We're going to make a push, and then we're going to let Flux reconcile our environment. Give me just a second while I get my key. We're going to make our push. Then we can wait for Flux to reconcile on its own, or if you're impatient, you can force Flux to reconcile with the Flux reconcile command. I'm going to do with source, so it updates the source. What we're going to see is Flagger's watching the deployment. It sees there's an incoming change, and so it's going to spin up 2 new pods, right? And those new pods are going to receive some of the traffic, some of this test traffic. We'll show you how that works as soon as the reconciliation is done. We've got a couple little pauses in here, so if it's possible to do questions live, I'd love to hear from anyone that has anything that they'd like more elaboration on. So for now, right, only the pod info service has valid endpoints. The pod info canary currently doesn't have any, right? We can look at Linkerd. We can see that there's no pods yet, but that's coming, I promise. All right, good timing. So now 2 new pods are getting spun up. So these are the new versions of the app, right? And these new versions are going to have that new image at its core, right? So instead of the main logo, they're going to have a separate Linkerd logo. But if I go look at my app, right, what I wanted to do here was show how we could do header-based routing, right? So I'm saying, hey, listen, if you've got a certain header, we'll let you see the new version of the app. But standard users aren't gonna interface with it, right? So I've got pod info. It looks like while my canary looks like it's going, right? I can't actually see anything here. But if I go and change my header to say X canary always, any second now, my image will change from little cuttlefish to Linkerd. And if I turn it off, because I'm no longer simulating I'm a tester, it goes back to the cuttlefish, right? And now all I have to do is wait for the validation I set up in my canary to pass, and then we'll get the next version of our application. So here, the flow from Nginx to either podinfo canary or podinfo proxy is being determined by certain header or cookie values, right? That's what makes the decision about where you're going. I could also, again, set Nginx to do it based on weight from one service to the other, or I could set the service mesh itself to do it based on weights, right? The metrics that are powering the decision making that Flagger is doing are coming from Linkerd. So while Nginx is setting where the traffic's going and it's handling the routing, Linkerd itself is providing the metrics that power the decisions about whether to go forward. And we're going to take a look at the canary object. We're going to take a look at the ingress object as we go. Let's put this back because we're about to see this change as the change successfully completes. So let's look at our ingress. There we go. So here is the ingress. So when I created my canary, I told it, hey, you're going to work with the Nginx ingress, and you're specifically going to mirror this pod info ingress object that I've created. So let's look at what it creates. So this is what Flagger created as an ingress. So it created an ingress, and it put in a bunch of annotations. One, it mirrored my Let's Encrypt stuff, which is good. So I've got a valid HTTPS certificate. It also gave me some cool features around the canary. So canary true, canary weight 0, set service upstream. Oh, it also has the headers somewhere, but I don't see it on this one. Did I grab the wrong one? Well, I may have missed my time frame on it. But it also sets in here the rules for specifically what under what circumstances I should route it. And there's 2 rules, and I don't know why I'm not seeing them. I may have missed my time window. But that's what gives us the routing from one service to the other. All right, and let's go take a look at the canary. So what we had to set up to actually make this thing work. Oh wait, one more bit that's worth doing. When you're integrating Nginx in particular with Linkerd, it's got a really cool feature called set service upstream. Right, so Nginx by default is going to try and route to individual pods in a service. With this value here, we can tell Nginx to instead default to routing on a particular ingress, to default to routing to the Kubernetes service instead. And that allows Nginx to play seamlessly well with Linkerd in your environment. So you won't have to do any configuration to Nginx or Linkerd to tell them to work together. You just add the proxy and everything behaves as normal. And this here will determine who makes routing decisions for your app, either the service mesh or the ingress. So let's look at our canary. So let's do yet Nginx canary. So we'll see what does this canary actually look like. So the big thing you'll do. So if you've done this, or if you saw my talk last year where I showed you how to do it via SMI, right? This section here is new. This is the ingress reference. So I tell it what my provider is. So this could be Nginx, it could be a number of other ingresses. It could also be Gateway API, which is a kind of a neat one. We're looking to talk more about in the future. You give it the API class of thing that you're working with, and then the particular one to worry about. Then when you get down here to the analysis, you're going to add this. When you're doing A/B testing, you're going to add the number of iterations, and then you're going to add the criteria. And this is what appears. This is what appears in the Nginx annotations when you catch it in a timely fashion, right? So exactly under what circumstances we'll get the new version of our app. At this point, you can see on the right, we finished our deployment. On the left-hand side, there's no more old pod info that's gone through and finished completely. And the last thing that we do here is because I've got a traffic generator in my environment, but the traffic generator is just sending traffic to the main app. So I needed something that would generate some traffic to this version of the app so that we could get metrics, right? Inside the canary, I always define like what Linkerd metrics I care about to determine whether or not this thing is passed or failed. In our case, I want the success rates to be a minimum 99% successful, and I want the request duration to max out at whatever 200 milliseconds. But to get that traffic, I had to use that load tester that comes with Flagger that you can use to send traffic, and on it we just set our headers, one header, one cookie, so we could send some traffic over to PodInfo. And yeah, this is the demo, right? Like it's not crazy exciting, but what you get is a lot of power for very little work, right? I've installed Linkerd in the environment. If you're looking for an example of doing Linkerd in a full Flux setup, here I've got this repo, Jason Morgan Linkerd demos. Happy to send it in a link or make it available in the chat. It walks through how do you set up a fully highly available Linkerd in your environment, install Flagger, install Nginx, and do this exact demo yourself. And of course, if you're curious, go to linkerd.io, check out the Linkerd service mesh, and install it in your cluster and see if you like it. And I think that's all I've got. Do I have any questions?
Awesome. There's a little bit of delay, so we'll check. Yeah, thanks for the great demo. Let me just do a time check.
And if we have a good amount of time, I do have one more, so I can show you how to do it the other way as well.
Yeah, that'd be great, because we're actually 10 minutes early, or 7 minutes early, yeah.
All right. So what I did here is I just opened up the little editor that I have. So we're going to modify this canary. So let's do some commenting. So here, right, what I'm going to do is I'm going to comment out. The settings to make it be header based, right? And I'm instead just going to have it be weight based, right? So for weight based, we're going to uncomment max weight. We're going to uncomment step weight, and now we're going to get like that just percentage of traffic, right? So Control S, Control Q, and sorry. All right, so we've pushed that canary. So that's just going to change the type of canary, but we still have to change our app. So let's swap that logo out one more time. So now instead of the Linkerd logo, it's a GitOps conference. So we're gonna change it over to the Weave icon. All right. So Control Q. There we go. We're going to change that logo one more time and do a git push. And we're going to see now the same thing happen, but let me do the reconcile one more time. When we see the reconciliation happen, now I won't have to do anything header based, right? Just some percentage of the traffic is going to flow to the new version of the app instead of the old one. And then another great time for questions. Otherwise, I've got a really terrible joke for you. All right, so I have a UDP joke for you. You may not get it. Works better when I have it. You can hear the audible groans. So what we've got here. So the canaries picked up. So we ran the reconcile there. We ran the reconcile. We've got a new version of pod info coming out. And what we're going to see, and we can force it to refresh a little bit if we want, right? We're going to see is periodically this logo is going to shift from the Linkerd logo to the Weave logo. Because now instead of going by header, it's going to go by weight, right? And one thing we didn't look at this before, right? But this is the map of who's talking to what inside the cluster, inside that namespace, right? And generator last time only spoke to pod info primary because at no point did it have the header value set that would tell it to go to the next version of the app, right? Sebastian asked for the joke, but I feel like they regretted it after hearing it. But what we're going to see here is now some percent of the traffic, and we can see it starting to occur already, is going to the new version of pod info that's spinning up. And at some point, this thing will update and show you that. And if you're watching the pod info URL, yeah, you're going to periodically see the Weaveworks logo come in and replace it. Again, just based on a percentage of the traffic, and whether or not I set a header is going to be totally irrelevant, right? Here my header set. That's bad timing. This shouldn't actually keep going. Well, that's bad luck based on weight. There we go. The header set, and it doesn't make any difference to what version of the app that I see. And here, let's see if I can refresh you, get a better view. No, I'm still not seeing it. Anyway, at some point I'll see the calls also coming from pod info. And yeah, that's our oh no, sorry, I have the generator point at the wrong service. My bad. We're not actually going to see that in this graph. But again, we've got weight-based routing. So if generator were speaking to the ingress instead, we'd see that flow getting split at the ingress because that's where it gets split. When you do SMI-based, right, the big change is with SMI-based, we're splitting on a service, not at the ingress, so where the split occurs. So with Nginx routing, the split's really occurring up here at Nginx, and it's deciding whether to go to the canary service or the primary service. When you do SMI-based routing, you get a third service in the mix, and then everything calls to that common service URL, right? It'd just be podinfo dot whatever namespace dot canary, and then based on a percentage chance, it would either go to the primary or the canary service in that environment. With Nginx, it's even a little simpler. You just tell Nginx to split it, and it makes that decision itself. Ivan has a question. So Flagger right now does not work with stateful sets, but there is scenarios where stateful sets can be deployed progressively. What are your thoughts about how we can do it with service mesh or Flagger? Oof, that's a good question. I guess, sorry, Ivan, I'm gonna totally weasel out of this and punt. I'd love to understand a bit more about the scenario that you're talking about, because like, I guess it depends what you're doing, right? Like I wouldn't want to do, or at least I can't think of wanting to do like progressive delivery with like database changes or something like that, right? So it'd be useful to know a lot more before I can provide you any kind of useful answer. You can do all sorts of, like, there's all sorts of stuff that you can do, right? So with stateful, I remember when I used to do Kafka on Kubernetes, right? You'd give like every single pod its own service for a while because you were trying to get like, you're trying to be able to send send data between replicas as they send things to each other. It was really an unpleasant experience. But yeah, the foot logo because I'm punting. All right, I like that. Yeah. So I guess I'd really want to understand what you were trying to do and like what's the best way to accomplish it. Linkerd doesn't do anything particularly magic around stateful sets, right? It will just honor in Kubernetes routing decisions, right? And specifically, it takes over routing decisions when you route to a Kubernetes service. You can see our deliveries, our rollout's finishing here. So what's interesting is now you'll only see the Weaveworks logo, right? So when Flagger wraps up, so the way Flagger goes, right, is it spins up a new deployment that has the new version of your pods, right? And then once it's hit its success criteria, I'm going to stop this thing so we don't keep seeing it. Once it's hit your success criteria, what it does is it takes the old deployment, which still has, you know, however many pods of the old version. It deploys new versions of the pods of the app, and then turns off those old versions. Then it shifts traffic back, and then it deletes the canary version, right? So you always end up, you know, with one deployment at any one time, and that's the basic story. If you're looking for examples, right? Well, one, the docs are actually really good. So go there. But if you're looking for actionable examples that involve Linkerd, this repo's got a ton of them. You know, I've got two different versions. If we look at the source, I keep two different versions of the canary, right? So Nginx-based canary, so that you can do, you know, the routing decisions there at the Nginx instance, or you can go to the SMI side of it, right? Where again, there's no reference to an Nginx ingress, and that everything just goes on the wait, right? Because Linkerd itself doesn't do header-based routing, doesn't want to do header-based routing, right? It sticks with that. Let's see. Yeah, that's kind of the big thing. Couple useful things. If you haven't used Linkerd, check out our Getting Started guide. Docs Getting Started. If you're interested in Linkerd, we've got an active Slack. So slack.linkerd.io. We'd love to see you there. Yeah, I guess that's the whole of it. Oh, one last thing. If you're looking for a job and like the Linkerd project, we're actively hiring folks for Linkerd. So we'd love to see you.
Awesome.
All right, sorry.
Great plug. No, don't apologize, but we are at time. So thanks so much with always your great talks. And I appreciate it very much. Great way to start heading toward the end of GitOps Days. So thank you, Jason. I will introduce our next speakers. And actually, on that note, that reminds me, we also have a role here at Weaveworks on the developer experience team. So if you are interested in being in this space, the cloud native Kubernetes Flux Flagger space, we have a role on our team that we've posted very recently. So if you have any questions, then ask me on Slack. Again, we have people monitoring the Slack for a while, for several days. So if you're watching this later, please still join us on Slack and ask us questions, and we'll make sure that they're answered. So we're really excited to have, speaking of our developer experience team, one of our members, Kingdon Barrett, will be joining us together with Brian Oliver, and they will be talking about, hello, hi Brian, I've heard so much about you, and it's really nice to meet you in person.
Nice to meet you as well.
This is the new in person. So yes, I'm really excited that you'll be talking about GitOps and Flux scale to hundreds of developers, which scale has come up many, many times. And so I'm glad that you're here to share your story. Take it away.
Super. Thanks for the great introduction. Yeah, this is our GitOps and Flux scaled to hundreds of developers talk. I'm Kingdon. Brian, you want to introduce yourself?
Yeah, I'm Brian Oliver. I love everything cloud and DevOps. I don't have two jobs. I'm currently in transition from my role as the head of cloud engineering at Priyanka over to principal architect at ThoughtWorks. I'm an avid Flux user, and I'm all over codes on the internet.
Great, thank you. And I, just a little bit about myself. If you don't know me by now, I'm Kingdon. I'm a Flux maintainer. I'm that cow on the internet. You can tweet at me or find me on the Kubernetes or CNCF Slack pretty much every day, as well as the Weaveworks community Slack. And here's our agenda for the talk today. So we're going to move pretty quickly through the intro to GitOps and Flux. And Brian is going to present some different patterns, some enterprise GitOps requirements, an image layer reconciler, and we'll see that as we get to it. There will be a demo. Actually, there's two demos, I think. So, all right, so it's GitOps days, day 2. We're nearing the end. There's a high probability that you already know what GitOps is, or at least you may have a decently solid idea of that. So I'm going to provide a reference to the formal definition for those of you that don't, or maybe who got the wrong idea from wherever you heard about GitOps first. So what is GitOps? Let's start with the single source of truth. The concept of, in Git, we want our, Git is our single source of truth in GitOps. So that's where we'll keep the desired state of our Kubernetes system that we'll configure using declarative artifacts. So what exactly is GitOps? Well, GitOps exactly is a set of principles, and these are not Weaveworks principles of GitOps. This is a vendor-neutral working group, the GitOps working group that was started by Weaveworks, Azure, Red Hat, AWS, GitHub, and CodeFresh. The list of vendors involved in the conversation does continue to expand. We welcome you. So GitOps working group is a time-scoped working group, and OpenGitOps is the permanent product. Since we think that GitOps can sort of be defined and then the work will be done, so the working group can close. So you put your Kubernetes manifests into the Git repository, and those are declarative artifacts. Okay, so that's at least 50% of GitOps right there. If you had the idea already of putting your YAML in Git and keeping your YAML in Git, rather than writing them from scratch again every time or generating them, then you're already well on your way. So I'll draw your attention to points 3 and 4, which is how GitOps differs from probably what a lot of people thought of doing next. GitOps, as defined here, requires an agent of some kind, we'll say Flux, running inside of the target cluster. That agent's function is to pull changes into the cluster, and once it's committed and pushed in the main branch, there's no further gating or approval. So we'll always see that the desired state of our cluster is going to be represented by the main branch of the Git repository, and we'll see that main branch is used for all environments in a multi-cluster configuration. And also reconciling continuously. This is just as in Kubernetes itself. So these resources are declarative, so everything is idempotent. So reconciliation enforces the desired state. Changes are auditable and clearly communicated within this model. So remember, not Weaveworks principles of GitOps, vendor neutral. If it's Seems like too much. I'm not here to gatekeep or exclude impure GitOps implementations. All the principles are roughly equally important, and you can start where you need to. This is going to be a unique story for everyone. So the solution that we're demoing here today, we hope embodies all of these ideas. So maybe you're already on the path, and if you're using Kubernetes, then you're already using declarative artifacts. I think this is the first principle because it's the principle that makes this whole thing possible. I don't think that Kubernetes is mentioned in the definition though, so just be aware it helps. Flux requires Kubernetes, but GitOps itself does not. And you can find out more at the GitOps Working Group website. So anyway, there's no mandate that you follow all of these principles. We don't require you to give up your cluster admin privileges, but we do recommend that you keep them for break glass scenarios and try to use GitOps instead in a closed loop. Okay, so that's our concrete list of principles and what we're talking about. Generally speaking, you can start where you want and start towards the city on a hill. GitOps is our city on a hill, so here's time for a diagram, and we're going to move quickly through this diagram as it changes a couple of times. So ignore any flaws that you see here. We're going to keep the pace quick and head to that city on a hill. The circular arrows represent agent reconciling, and that heptagon steering wheel, of course, is Kubernetes. So as we update Git with new versions of our infrastructure, the reconciling agent will pull them into Kubernetes for us continuously every few seconds or minutes. And it was woefully oversimplified, of course. So let's make it a bit more accurate. Not totally clear maybe what the robot is doing in the picture. He's taking a selfie. That's the best emoji combination I could come up with for taking container images and doing what we do with them. So I'm talking about image update automation here. Let's draw a box around this to remind us that this is all something that happens inside of Kubernetes. And we also said it was pull-based, so we'll move this guy into the cluster space there. And CI is nominally responsible now for building and releasing images to that package box icon, which represents the container registry where our new images are published as they're being produced. And also the two arrows representing the additional idea that we're monitoring an image repository for updates, besides the original point we already mentioned and hopefully understood that all of our Kubernetes YAML comes from Git and it's continuously synchronized. So what else is wrong with this diagram? Well, there isn't only one Git repo. You may have noticed I did a little bait and switch there before the app. The Git repo was first called the system and now it's called the app. So let's bring back the system and have a few more apps here since you're doing microservices. I'm sure there's not only one app. And let's rename this thing and call it a config repo, since we might have more than one of them. We also said that Flux monitors the container registry for image update automation. So we define an image policy, perhaps per environment. And when Flux decides to release an image into the cluster, it does that by writing the update to the system or the config repo. So it should be clear what I meant when I said that Git is our single source of truth based on that and how this approach might differ from other solutions that are push-based. So going to go through this section pretty quickly because we have seen these before, and this is near the end of GitOps days, but here's our cast of characters. The cuttlefish is named after kubectl, and the source controller and the customized controller do the main heavy lifting. At a glance, so here's a slightly different picture. Customized controller receives that artifact that's fetched from the source controller as a tarball, and the source controller serves it over HTTP, so that's what this part looks like. And Flux's customized controller is used as an applier. We have two options for appliers. The Helm controller is our other option. That also depends on the source controller. So the notification controller has responsibilities mainly related to elevating our situational awareness and making things happen faster. Providers handle outbound notifications when the Flux controllers will generate events that you can pick up or filter out through alerts. All of the important nouns in that sentence there are CRDs. And then what about these guys? We'll see them in a bit. Actually, we have seen them before. So if you recognize, this is image policy. Okay, so image reflector controller, image automation controller, here they are in the same setting with all of their friends. And let's call this all GitOps toolkit and move on.
All right, I'm gonna take the share.
Okay.
There you go. All right, so for part 2, what we're going to do is talk about the config repo pattern and image layer reconciliation. But before we get to that, we kind of need to talk about some requirements. So in the enterprise world, when you're doing software delivery, you have hundreds of developers and maybe dozens of teams. These are some of the basic requirements you're probably going to have. Release automation, you need a really simple and easy to use pull request process. You need to be able to fix vulnerabilities. You're probably going to have more than one environment. You're probably going to have more than one cluster, and you're definitely going to have more than one pod. And then lastly, all of this complex stuff needs to be easy to consume for those development teams. So for scaling to lots of teams, if you go to the Flux documentation, you'll find 3 patterns. The monorepo pattern, the repo per team pattern, and the repo per app pattern. These are extremely robust and good patterns. For example, the monorepo pattern is used by Google today. But depending on the company, you may have different requirements. And in my case, you have hundreds of microservice projects and need some way to manage all of them in sort of a cohesive, easy to understand manner. So we literally just started talking to Flux and kind of came up with a new pattern. And before I move on, I think a lot of speakers have mentioned how great this community is. And this entire presentation is because we talked to Flux or talked to people on Slack in the Flux community. So like they're not lying. It really is a great group of people. So moving on, the config repo pattern in the continuous delivery case is expanding kind of on that repo per team concept and repo per app concept and sort of becoming a hybrid. So at the top level, you have a bootstrap repository. This is probably what you've all seen in multiple sessions today, where you're bootstrapping a repository to a cluster. You have all your Flux system type stuff. In our case with this demo, we also have some secrets that are encrypted and managed there. And then you have pointers to config repos. Now, these config repos are essentially the central point of entry for a single application. But that config repo is actually managing the deployment of more than one microservice. So, for example, you might have 2 teams, and I'm going to actually go to the next slide here. You might have 2 teams, application team 1 and application team 2. Each one of them is going to have their own config repo. They're both bootstrapped through the same multi-cluster configuration repo, and then they manage all of their microservices in separate repositories that are linked to the config repo. So you essentially have 3 tiers of abstraction. At the highest tier, you have all the really nitty-gritty details in the multi-cluster repo. In the configuration repo, we have everything we need to deploy these applications into the different environments. And then at the microservice level, we're following the 12-factor app pattern, where there is nothing environment specific or configuration specific stored in those repositories. They are following that pattern correctly. A nice side benefit of this setup is your config repos also represent a bill of materials for each one of your environments, because you have an image tag list for all of your microservices deployed inside of each environment. To give you a sort of textual version of what this looks like, and also a Fluxified version, at the top level, it's the same thing in the previous diagram. We have a Bootstrap repo that is housing 2 pointers to 2 Git repositories, both of them config repos. We then, down there in the config repo layer, we have 2 Git repositories for dev, 2 pointers for test, and the releases for each. And then lastly, we have 2 linked microservice repositories that are being listened to by that config repo layer. And those guys have our actual either Helm charts or manifests, but they are not environment specific. The values that those charts and manifests or customized manifests need are passed in by the config repo. So the next problem that you have to solve in sort of the enterprise delivery area is if you're shipping that many containers and you're trying to scale Flux, you're probably going to come up to some point where you have the need to patch your images. A lot of companies will use base images from like Docker Hub or Bitnami or whatever, but a lot of enterprise companies build their own base images, sometimes called a golden image, and then they build their application code on top of that layer. Well, most of the third-party tools out there today don't support that custom golden image layer building process. So, they'll probably give you some information on how to keep that guy up to date, but not how to automate patching it out there in the wild. I think some third parties are starting to get there, but it's still a pretty tricky problem to solve. So what I did in sort of my free time and nights and weekends was wrote a Node.js application that uses the Kubernetes client and talks to the Flux API inside of the cluster and listens for that policy that Kingdon talked about and sends image layer updates to our different services and applications. And you'll see a better example of what that looks like. From an architectural perspective, essentially what this means is if you remember those microservice repos from the app config repo diagram, they have a Docker file inside of each one of those repositories. Well, if it's, say, a Rust application, you're going to have a layer that is referencing that Rust-based image. And so what we are essentially doing is running a scanning process on our Docker registry, publishing the secure versions of the layers to the registry, and then we are syncing that to our image repositories whenever we find new ones through the Flux image policy. Putting this all together, we have a scalable, multi-team, multi-developer, multi-cluster architecture that also helps us facilitate providing patching and updates into those environments, as well as continuous delivery. So we're not going to click the recorded demo link because I made a better demo. So I'm going to pull up a series. We have two demos. The first demo is the config repo pattern, and the second demo is the image layer. For the config repo pattern, I'm going to use a video because the CI build part takes too long. We'd be here for a while. So we're going to go through that first. So here we have on the left I'm going to pause for a moment, a microservice repository, and on the right, we are linked to our different clusters. We have two clusters. The top left is our staging cluster. The top right is our production cluster. And on the top left, we are bound to our namespace for this microservice in staging. And on the top right, we are bound to the namespace for our microservice in production. On the bottom right, we are bound to, that's also production cluster, to the namespace for that image updater, which we're going to demo that one after this demo. So I'm going to go ahead and hit play here. We're going to make a small change to our Rust program here. And in this, we're just going to write simple message. This is a Discord bot. So instead of saying hello, we're going to say something like hello GitOps days. And we're going to create a pull request for this. And that pull request is going to be built by GitHub Actions. And then we are also going to actually deploy that pull request as a preview into our staging environment. So here we'll see here, we're going to open up the GitHub action and just see that Rust process building. And this process takes about 9 or 10 minutes. So I'm going to skip to the next video here. And you'll just kind of see it keeps going, right? So next we have our pull request has finished building. And we're going to take a look at our GitOps days PR. We're going to see, okay, our build process finished. And we're going to look at what we changed. We got hello GitOps days. And then on the right there, we can see our new image. And you can see there that image tag 9F0, whatever. We're going to go over here and make sure that that's the correct image tag for our preview environment. So if we go back into and we can see 9F0. Okay, so we've successfully deployed our pull request preview into our staging cluster at this point. We're going to go ahead and merge that pull request And then we're probably going to trigger a production release after that. So I'm going to slide this wall here. Well, actually, so for the production release, a lot of teams follow the trunk-based delivery pattern. We're kind of mimicking that here by creating a release tag. So we're going to do release like 018 on this guy, and then that will trigger a release into our production cluster environment after we build from that pull request that just got merged. So we'll go ahead and publish that. And we'll have to let that build for a minute. So we'll see that that guy is going out there. And while that's building, I've pulled up our Discord chat. And I'm going to scoot back here for a minute. And in that, we're going to see a demonstration of that chat feature that we just pushed. So the hello GitOps days. So on the left, we can see we have flip check and we say hello GitOps days right there. And then the other one, hello, that's from the production environment that hasn't received the new change yet. So we've only made it to the staging one. So the staging bot is saying hello GitOps days. All right, so I'm going to pause here again and we're going to slide forward. And yeah, here we can kind of see where we updated the code. There's hello, etc. And so we have one more video to look at, and that's our production deployment. So if we go here, we have our build just finishing up. And slide this forward a little bit. And there's Kingdom's face. And all right, I'm going to stop here. So for this one, I wanted to make sure we also showed you the config repo process. So I'm going to, on the left, jump to the config repo, which is that middle tier. And we're going to see where Flux actually updates our production environment. So you can see that we have a push to our deployment file. And 16 seconds ago when that was created. So that was when that build finished. And you can see here, Flux has pushed release-018 to our deployment. And on the top right, we don't yet have the image deployment coming, but it should be there in just a moment. And we'll slide this just, there we go. Okay, so on the right, we could see, okay, there's our new deployment coming in. We still have our old one running. So if we pull up that Discord bot again, and we actually do our check right now, we should get 3 responses. The new production one that says hello GitOps days, and then that old hello, which is that pod that's still terminating. So if we slide forward a little bit further, and once that guy finishes terminating, now we go back to our bot and we do it again, we're only going to get 2 responses from our Discord bot. All right, so that concludes that demo. Now we're going to take a look at our image reconciliation. So for this we're actually going to do live. What we're going to look at is first a GitHub repo here. So we're going to take a look at our microservice guy again. And to trigger this reconciliation process, first I want to show you the Docker file. So let's look at that. Here we're going to have a version for our Docker file, which is going to be Rust 1.59. We're going to be updating it to Rust 1.61, I think. So here we can see, so we're pretending that that's essentially our insecure version. So I'm going to go over here, and our bot has already been trying to update it. So I'm going to first delete our pull request that it creates, so you can actually see it happen in real time. So we're going to close that pull request, and we're going to go over here and just delete this branch real quick. And then while we're waiting for that to reconcile, if we come over here on the right, you can see I have 3 image updater sort of jobs. So what this is a Kubernetes cron job that continuously reconciles and reads our Docker files and finds those insecure image base layers. And it runs a job about every minute or so that pushes that image base layer out to our microservice. It then triggers a GitHub action inside of that microservice. So if we take a look here, we have a image layer pull request GitHub action. And what this guy does is says, anytime I get a push, you see down there at the bottom right, we just got a new job triggered. So we should have a pull request in a minute. Every time there's a push to that golden image branch, we're going to go ahead and automatically create a pull request for that layer. So if we go back to the root of our project here, we look at branches. Here we have our new branch, and we should have our new pull request. And there we go. And if we waited 10 more minutes, which we don't have time for, we would see this pull request with our patched image layer getting pushed to our staging environment. And yeah, that's pretty much it.
Cool, perfect timing. Thank you for this talk, and it's always fun to see demos working. You have both recorded and live, it seems.
Yep.
So with that, yes, we are at time, and remind everybody, we'll move over to the Slack channel where we'll continue to monitor, not just now, but in future dates. So if you are watching this recording, please feel free to come to our Slack channel and ask questions, and we'll ping Kingdon and Brian to help answer. So thank you so much. Appreciate it.
Thanks so much for sharing the stage with me, Brian.
No problem. Thank you.
Good to see you. All right, so now we're going to go to our final speakers. I'll introduce Tony and Mo. Can you join us on the screen? Oh, and then I guess, Brian, if you could stop sharing. And
No
thank
problem.
you so much. See, oh, I'm looking at somebody's background. Mo and Tony, are you back? Here.
Yep. One second.
There you go. I can hear and see you now. You look like you're in a sunny place. Oh, it's adjusting. I see. How's it going?
Doing great. Thank you very much, Tamao. Pleasure to be here.
Thank you for closing out our 2 days of GitOps days. And Tony again. Hey!
Yeah, sorry, my cam fell asleep.
Yes, you look like you're partly in the void. You're about to fly off.
Camouflaging it with the background, Tony.
Exactly. Great. Well, thanks so much. Definitely excited to have you close out GitOps days with a very, very important topic, which of course is policy. We've heard you talk about this before, and so I think it's really important to reiterate. And for those who are new to GitOps days, you have a treat ahead of you. So yes, Tony and Mo, take it away.
Awesome. You hear me okay, Tamao?
Yes.
All right, great. So hey everyone, my name is Tony, and I'm going to talk about policy management in GitOps today. Just to tell you,
and this is Mo. I'm the VP of Developer Platform. I'm also partner in crime with Tony and the Policy as Code. We came together from Magalix through the acquisition that Weaveworks did earlier this year. So all to you back, Tony. I'll be just listening in the background and answering questions.
Yeah, all good. Yeah, as Mo said, we've been a part of the Weaveworks team since the beginning of the year through the Magalix acquisition. And for those that are not familiar with Magalix, Magalix was a company that was providing policy as code essentially as a service to integrate into your CI/CD pipelines. So moving on. And so today, I'm hoping we're going to achieve accomplish a few things. One, I want to demystify policy as code. I want to teach you Rego in under 5 minutes. And then I want to explain the connection between GitOps and policy as code and why not only the acquisition, but why the two, different technologies come together and why it makes sense. And so just taking a step back here, how many out there have witnessed a production outage due to a misconfiguration? And this is from a movie that I saw recently. I joke that I have, sausage fingers, and I'll tell you something that these have done more than witnessed production outages. Back in my day, right? I think if you use kubectl to manage your production clusters, sooner or later you're going to apply a misconfiguration. Even in my own history, I remember I worked on a team where every time a new microservice was developed, that same development team was responsible for creating their own Kubernetes deployment manifest. And I remember when we were first getting started, they wouldn't add things like replica count, they wouldn't define the resources or the ports, and it was just, I get it, right? Because that's not their bread and butter. But I think at the end of the day, cloud native is not hard because of like the difficulty to like administer these things. I think cloud native is hard because there's just so many things that like you have to remember. So as a developer, not only am I responsible for the business logic, maybe from full stack, I have to work on the UI, and then all of a sudden now I have to configure, ports and replica counts. Like that's a lot, right? And so, what if there was a way to say, look, we can ensure that only proper configurations get applied to any cluster that we choose. Like, what if we can codify that? What if we can cement that? What if we've learned our lessons and we don't want that ever happening again, right? And this is where policy as code, right, really, really, kicks in and solves, right, this problem, right? So, what do I mean by policy as code? When I first heard this term, I was like, what is policy as code? Or do I take the HR's do's and don'ts and like scan the text into Python and do something? Like, what does this mean, policy as code, right? And so I'm going to break it down for you, right? Policy as code is simply a way to codify your organization's technical standards. And what does that really mean, right? So let's say in your organization, all deployments to production require a replica count of 2 or greater. You can write a policy to enforce that. Let's say you want that policy, but then you have another policy that says, well, except in the case if the clusters are named, US East something, those require a minimum of 3. You can write a policy for that too. So, because this policy is code, right? It's written in OPA Rego, right? So what is this? OPA, for those that don't know, OPA is a CNCF graduated project for policy as code. And if you're using this, if you're using a policy solution now, I'm pretty sure it's OPA under the hood. And thirdly here, this is more, I would say, more of a description, an attribute of policy as code, or something you should do versus a definition. But when we're talking about policy as code, policies as code should scale out. And what I mean by scaling out is I can write the policy once and apply that to one cluster, a subset of clusters, or across my entire organization. And to the left means that for my Kubernetes operators or administrators, you're not constantly trying to track down bad configurations to get them fixed. You can start moving the responsibility over towards the development of configurations and deployable Kubernetes artifacts, and incorporate that into your development pipelines. All right, and so I talked a little bit about teaching policy in the 5 minutes. Well, here it is, right? And so what you're looking at is the Rego Playground. This is available on the web. It's a place where you could test your Rego code. And so on the left-hand side, we actually have a modified version of one of the earliest policies that we wrote at Magalix that represents exactly the replica count example that I've been talking about for the past couple of minutes. That's on the left side. On the right-hand side, you'll see this section called input and some JSON. What that really is, it's a deployment manifest that I had that I use for demos that's just been converted to JSON format and pasted in there. And so, if you've dabbled in OPA a little bit or looked at the docs just briefly, you might be asking yourself, you might have asked yourself like, what is this, right? It's not object-oriented programming. I think the way to look at it, it's more like querying, right? You're asking, is something true or false? And so if we start breaking this code down, I think the first statement is pretty straightforward here, right? Replica count, scalar value equals 2. So it's like a variable declaration. We get to the violation block, which is just how our system works. And then you have this statement here, which looks a little, maybe a little backwards to some. It says not input.spec.replicas is greater than or equal to replica count. Well, if we start breaking this down, replica count we know equals 2, and input, you see it's in blue here. Blue, it's a special term in OPA. We saw input earlier, and so input.spec.replicas. So if we look through the code, spec is at the root level, .replicas equals 1. So this statement here says if 1 is not greater than or equal to 2, trigger violation. And I'll run that back real quick in a different way. So if I were to rewrite this in kind of a more positive way, I suppose, it would be input spec replicas is less than or equal to replica count. Because then if you read that out loud, is 1 less than or equal to 2? Well, that's true. We don't want that. Kick a violation. And that's how Rego works. That's how policy works under the hood. And so what does that have to do with GitOps? Right, so you've heard for the last 2 days about GitOps, some experiences. In a nutshell, right, it's continuous delivery, or continuous deployment, right, of IC. And so if you're using Git, what you're seeing on the screen probably mirrors a flow similar to your own, which is somebody proposes a change, that gets requested, there's a peer review. If that's approved, that code gets merged into some main branch that then triggers a deployment into your cluster. Right? If you're following GitOps, this is constantly reconciling, this is constantly happening. Right? And so as a standalone product, policy usually comes shipped in the form of an agent that you deploy to a cluster, right? And then you tell the agent, these are the policies that I want applied, and then you get what's known as runtime or audit time feedback. It's not really blocking, it just tells you, based on the policies that you have enabled, where your cluster sits, against your standards, right? But then talking about, shifting left, well, as you deploy an agent and see what's going on, your Kubernetes operators are trying to figure out, okay, how do we decrease the numbers to a point where everything's compliant. You don't want new objects coming in, creating new violations of existing policies, right? You don't want to just keep adding to the problem, right? Adding fuel to the flame, right? And so policies should be integrated, can be integrated now with your mission controller, right? So if replica count should be 2, and then a deployment tries to get applied, a scan is made, and if the replica count is 2 or greater, or based on what the policy says, it will get scheduled. If not, it will get blocked. And then thirdly, this is really where GitOps and policies, come together, right? Because everything's in Git, pretty much a pull request is, something missed in a pull request is going to go out to production, right? This can happen to the best of us. So enforcing the same policies that are applied to production at development time means that now, before, even before there's a pull request, right? You could even use a pre-commit hook. I mean, shout out to the homie Samir, who was on our team, my team at Magalix, where he built our own internal OPA testing policy testing pipeline, where on a pre-commit hook, we would run an OPA container that would run an OPA test, and we would inject test, and if we would expect pass or fail, right? And so you can even do this at development time. So these known bad configurations don't even get attempted to enter the system, and if they do, they're blocked. At emission control time, and if they happen for whatever reason, it's impossible. But if there's something new, or I should probably say something existing, right? You get it at the auto time, right? And policy should cover, all of this, right? I think a good analogy is essentially if you're doing continuous deployment of your microservices, how are you able to do that? It's probably because you have some level of automated testing that you trust, or you should, wink, wink, that gives you some confidence that at least the basics smell okay, right? I think using that same analogy, you could look at policy in that same way, right? Does this configuration pass the smell test? Yes or no, right? And you get that at CI, right? Or even pre-CI. I hope this stuff is starting to make sense. If not, I'd love to talk with you. So look, scripts, manual deployments, double checking. I will quote my friend Kay. My friend Kay told me this 2 weeks ago. He goes, "Hey, Tony, that's so Yahoo 2005. I had a laugh. And here's the thing, there's no knocking Yahoo. And let's not knock 2005, because you know what? That's what we were doing back then, right? I was working at that time in the Yahoo Center in Santa Monica. It wasn't a Yahoo, it was a Yahoo Center. There was a lot of folks from Yahoo, right? We had custom scripts, but also we had 36 boxes, right? We weren't even running VMs. We were building ears, and we were running WebLogic. It was a different time, right? And that worked, right? But now we're talking cloud native, Kubernetes, multiple things changing on top of a constantly evolving ecosystem. You need some guarantees, right? And that's how we're doing it today, right? GitOps and policies. And so, all day you've heard about GitOps. What about policy? Maybe it's still, you're not sure. Maybe it seems a little bit overly complicated. Here's the thing. We're still talking GitOps. So even the policies are in Git. So you get all the benefits of GitOps, right? You get the paper trail, you get the audit trail. Sorry, I'm still talking old school stuff. You get the audit trail, you get all the benefits of Git. And it's in code, right? Just like everything else. Again, we're integrating our policy. What I'm talking about rings a bell. Right, we're not discussion here, right? This is simply talking about. Sorry, my internet is unstable. This is simply talking about adding checkpoints to your existing workflow. Dev and ops are aligned again, right? No more throwing over the wall. Developers get a feedback loop. If you're using a Git, hosted Git solution, GitHub, GitLab, Bitbucket, your own, hopefully not, right? You're more than halfway there. And then lastly, if you are interested but you're not sure where to start, you can always reach out to us. And a big shout out goes to the developers on the enterprise team, the sales and the SA folks, helping people adopt, really good practices and resiliency in the organization. And so again, my name is Tony. Thank you. Hopefully you learned a thing or two today, and I will catch you on the next run. Thank you.
Thank you,
That
Tony.
was awesome.
We were laughing in the background. I felt like you were at the pulpit. You're like, oh, we have to go.
And he's out.
Okay, well, Tony and Mo, you will be backstage, right? Because we're going to have a group photo in just a few minutes. We'll be bringing in anybody who's awake at this time zone and available to join us for a group photo, our GitOps Days tradition. So thanks to everybody. I'm seeing still people watching and in our Slack. It's really great. Hey, Mo. Thanks for joining us. Yes, and just a reminder, we've got Mo here. So as I've said throughout the event, the recording will continue to be available, and we'll continue to monitor Slack. So people like Mo and Tony will be online to answer any questions you may have. And I'm seeing some speakers who are up very late, willing to join the closing photo. So with that, we will have a wrap up here a little bit. Mo, I don't know how much you've been able to watch. I know you're a busy person, but any highlights for you that you've seen at GitOps Days at all?
Well, unfortunately, I wasn't able to see every all the sessions, but certainly lots of excitement. Maybe one thought to add here to all those sessions, and hopefully it will be a good wrap, is that GitOps at the end of the day is one of the best manifestations of DevOps. And if you think of it as a delivery vehicle of your software, it makes it faster, more reliable, etc. But what you need to think about is the next level of engineering of your ops and your apps and your infrastructure. You need to deliver secure, reliable, efficient applications, and DevOps are just the starting place for you to do all of that.
Absolutely.
Well put.
And Pinky, you had many friends here who join you from past and present. Some reflections, what stands out for you?
Honestly, I really liked the focus on security. I feel like it was more today. Like there was a lot of talks that were focused on security, and even if they weren't like surrounding security, all of them mentioned security in one way or another. So that was really cool that that's become like the shift.
Yes, and I'm glad that you've brought that up because absolutely essential, right? Hopefully with this event, and you'll see many, many more from startups to enterprises that have been around for 20 years, 30 years, 100 years, right?
100 years, yeah.
Security is just, it's a non-negotiable, right? It's going to be. And so that's why we're so proud of how Flux has been going through graduation, and we were very, very close. And, we've gone through the external audit through the CNCF for security. And it's just, it was really gratifying to see that we've got great people in the maintainers group, great people who contribute, and great people in the community who continue to help us. It really is where it is because of the great technical work that people have done, but also so many of the speakers, so many more people that you'll hear about in the community, posting issues and giving suggestions and sharing their use cases. Without that, a community can't grow and a technology can't advance. So quick wrap up, overview again. If, it always happens. Some people might be like, oh, I just found out about GitOps Days. If you are literally just joining us, then no worries. I'm glad you registered. You have the links to the 2 streams, which we will have up for a while. And later, Stacy, our Oz of others. Oh, we've got some people joining. Hold on a second. We'll be doing a group photo in just a second. The event is about, GitOps in general with many technologies. This particular one, we did focus on Flux because we had so much to share from the community. So if you missed anything, GitOps is pretty much kind of the natural evolution of Kubernetes. We really were thankful to have Taylor Dolezal from the Cloud Native Computing Foundation kicking off that keynote. If you want to get your hands dirty, roll up your sleeves and really try it, we have a fantastic 90-minute tutorial that Tiffany and Joaquin shared at the beginning of this event. Check out the recording right at the very start. It was kind of our quote-unquote pre-event. And really thanks to the generosity of Microsoft and the Codespaces team, they will make available that hands-on environment for 2 weeks. So make sure that you join our Slack channel to get those instructions. And again, the many, many stories, the many use cases that the community members have shared. We had State Farm, OSO.sh, Ring Central, Anova. I want to get everybody, I'm blanking, Orange, Safaricom, Priyanka, which I guess we can mention, Brian came on, and many, many more. Again, I want to repeat, this is open source. It is in the Cloud Native Computing Foundation, but if you are already using Azure or EKS Anywhere, all these different other platforms, you saw talks by Weaveworks, Red Hat, VMware, D2IQ, Microsoft, and AWS, all sharing how you can use all these different products that have trusted Flux as their underlying technology. We've had feedback from people saying, wow, that really helps to make my decision to know that all of these major providers are using Flux under the hood. That's how good it is. That's how secure it is, and how the development is happening so rapidly. As I mentioned, Daniel, who will be coming on to close us out with some music, puts out a monthly newsletter to the Flux community. I think Stacy posted a reminder of that link, and we saw a lot of people signing up for the newsletter. So once a month, you'll be alerted of the Flux blog, which you can see at fluxcd.io, with all the latest information with what's going on with Flux. So that's the best way to keep up with that. And finally, thanks to everybody in our communities talking about, like right now, Linkerd and Flux and Flagger, cross-playing with Flux, and we've had our own talks on Terraform, Visual Studio Code, HashiCorp Vault, and many, many more. So please, yes, check these out. And if you have any questions, join us. We both are in the CNCF CNCF Slack channel under Flux and Flagger, as well as you can join us here at the Weave community Slack channel, where we are answering questions for this event. So Pinky, it's so great to have you co-MC with me again. And Vanessa earlier, always bring your fantastic energy and your knowledge. As I've shared, we've gotten feedback before, like, Pinky, so disarming, and then comes in with the zingers. And I think that's something that a lot of our speakers share today. So with that, I welcome everybody to join us for the group photo, our tradition at GitOps Days. Please welcome to open your cameras, and it's really lovely to see everybody's fantastic faces from so many different time zones. So many.
Is that what you walked away to grab? Is that what?
And so I've invited our speakers. Let me just make sure I can see everybody's view.
There's multiple. You have colors. Oh my goodness.
So welcome everybody. Our speakers, our friends from Weaveworks. Some have joined us. I'll take this moment again to put a shout out that we do have jobs here at Weaveworks. One of them is here on our developer experience team, many of whom you've seen here speak or have been in the background and making things happen. And I want to give a big shout out. First of all, I see Stacy. Stacy, wave your hand. Stacy is the Oz of making GitOps Days happen here. Yes, making it all happen. Thanks to Kingdon for also both being in the back room and speaking, doing multiple roles. Of course, you saw Daniel Holbach here, who is providing music late into the night, Berlin time. Vanessa is out sleeping now, but Vanessa and Pinky were my co-MCs. Really appreciate your help. And some people you don't even see here who are answering questions in the background, doing social, giving talks as well. Scott was running back and forth, giving talks and doing social, and the others. So thank you so much again. And yes, let's take a group picture. Thank you, everybody. Thanks for joining us for GitOps Days. Thank you to our audience. And we will, I don't know, with Jeff's glasses, they're cracking me up. Oh, yes. the freeze. Do we have to do that like somebody made a funny joke?
Stacy, okay. We can't hear you. Or
yes,
maybe
we can't hear Stacy. Jesus had the voice of God. Yes. All right. Awesome. And with that, we thank you so much again. And we will sign off and have about half an hour of fantastic music that you can relax to, work to, and whatever. Daniel, aka DJ Desired State, take it away. Thank you, everybody.
Thank you.
Is it worth it? Let me work it. I put my thing down, flip it and reverse it. It's your primitive plan yet. It's your primitive plan yet. If you got a big, let me search it to find out how hard I gotta work. Yeah, it's your primitive plan yet. It's your primitive plan yet. This the kind of beat to go, 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 ba ta ta, ba ta 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 ta. Sofa. Oh, before you come, I need to shave my chop chop. You do what you don't know, you will, I won't chop. Go downtown and eat it like a vulture. See my hips, big hips, so chop. See my butts and my lips don't chop. Lost a few pounds in my waist, oh yeah. This the kind of beat that go ba ta ta.
Hold up.
Top dog, bite them all, yeah, I'm burning it up. Top dog, bite them all, yeah, I'm burning it up.